Mandwal, and for those of you who met me yesterday, well, we are pretty much familiar with each other, I believe. But for those who are joining us today, a very warm welcome. In fact, a heartfelt welcome to each one of you today who has been a part or chosen to be a part of this entire convention and exhibition. As we all know that today is the second day, it's also going to be a day of sessions and discussions, sessions that I believe should be very insightful and also imparting knowledge on several topics and genres that may turn out to be very useful for all of you, especially the delegates and people associated with the railway industry over here. On that note, ladies and gentlemen, since we have started now, we're 30 minutes late approximately, I'll quickly get down to formally opening up the first session of the day. The session chairman for this would be Mr. Franz Hagen, ex-director, EULYNX. And the session moderator would be Mr. Akhilesh Yadav, MD, Frosher India. And the session is all about intelligent control and command systems. Well, the panelists and the speakers in this session would be Mr. Axel from Munich, Siemens, Germany, and the topic that he shall be addressing is technologies for digital transformation of Indian Railways infrastructure in the cloud. Our next panel speaker would be Mr. Naveen Pandey from NCRTC and Mr. Navaneet Kaushik from Director Systems NCRTC. And they'll be talking on advancements in high-speed rail signaling, packet 44 implementation and interoperable ETCS solutions for platform screen door interface management. We have a few more panel speakers in this session, ladies and gentlemen. I'll be requesting you to kindly welcome them with a bigger round of applause, everybody, as I call out their names. Thank you. Our next panel speaker is Mr. Sebastian Sahairaj from Frosher, and he'll be speaking on intelligent data platform as a key driver for digital railway operations. Then we have Mr. Bal Murugan Rajsekharan from Hitachi Rail STS, and he'll be talking on advanced electronic interlocking solution, wayside station platform with hot standby for high-speed train operations with RAMs. After that, ladies and gentlemen, we have Mr. Digvijay Sharma, who is Senior Director Sales at Sienna, and he shall be speaking on converged and coordinated multi-layer infrastructure networks. And finally, ladies and gentlemen, our last panel speaker in this session would be Mr. Ratan Saha from Bitkom, who shall be speaking about AI-powered OFC DAS-based intrusion detection system. On that note, ladies and gentlemen, I believe we have all our panel speakers over here right now, as well as the session chair and session moderator. So I shall now hand over the session to our session chair and our session moderator, everybody. Have a good session and a good discussion, everyone. All yours, gentlemen.
Thank you very much. Thank you very much for the warm welcome. We hope to finish on time, like yesterday. Welcome to you all, everyone, this morning. I know it has been a long night yesterday for everyone, but seeing the interesting speakers we have this morning for this session, I hope you will be all attentive and pay good attention to our speakers. They deserve it. I will now hand over to the moderator, Akhilesh Yadav. He will do the hard work. I'm just sitting here to oversee his work.
Thank you, Franz. A very good morning, ladies and gentlemen. This is a very interesting session on intelligent control and command systems, a subject very close to my heart. And we have lined up a very interesting 6 topics from our eminent speakers. Some ground rules, of course, because we have a limited time, so 20 minutes is where every speaker has to present, and also we have to finish the question and answer in that session. So 15 minutes I'll request everyone for presentation, and rest 5 minutes for 3 or 4 question and answers. So with the permission of chair, let me start the first topic, and this is technologies for digital transformation of Indian Railways infrastructure on cloud, and it will be presented by Mr. Axel Munch from Siemens Mobility. So let me request him to please start the session.
Good morning, everyone. So I hope I don't have to bend down. So is that understandable when I stand up? Yeah? Okay, good. Yeah, 1 week of thinking about this presentation, coming to this, being slightly nervous, thinking, okay, big day, and now it's on. Siemens being the first presentation of the day today, it's a great honor for Siemens and for me. And I hope we will deliver on this honor and give you an interesting 15 plus 5 minutes. And the time is on. I will do my best to stay in this time. Yeah, so I think I'm in control of this computer here. Let's see what happens. Okay. So when I prepared for this presentation, when I thought about it, I thought, what's the message? What makes it relevant for you? So because it's technical, and with a technical presentation, it can be very dry, and then I just dive into topics, and then you are getting lost. So I thought the message has to be somehow relevant to you. And I feel, we heard it yesterday, it's all about digitalization now. So it's a big word, but it's not a buzzword. It is something that's becoming real, and that will change all our world. And it is not just for railways, it's in principle the case. And then I thought I'd give you one simple example which has nothing to do with the signaling systems. It's just an experience. On the weekend I was already here, and I had time. And I was browsing the internet, what can I do? And then I selected 2 things. One was the Railway National Museum in Delhi, and no one has actually seen it, but this is the button from there. And yeah, I checked on Google Maps how to get there, and I found, okay, it's very small to see, but it's on the right side there, and it's actually saying that via public transport it takes 30 minutes, walking it takes 30 minutes, and by car it takes 6 minutes. So I thought, so what else? And I was curious, checking. Then I realized, okay, then I selected just a silly location, Siemens in Delhi. And then it was even worse. 1.5 hours for public transport and 30 minutes for a car. Okay, walking 5 hours. Okay, no competition there. And then I thought, okay, this is not an Indian problem, that must be global. Let's check, to be fair, with Berlin. And that's the same story. Exactly the same story. I picked the same principles, going to a museum, a rail museum, and to Siemens, and it's the same pattern. The public transport always loses, time-wise. And then I think that is actually the most important thing. That should be our challenge, make public transport the system of choice. I know this is a big word, and everyone loves their cars, and I do too. But in essence, we have to pick up the fight. And I would say digitalization is the lever to do this. And let me go to the next slide. Systems will be required to fully understand the need of transport, the need. Everything starts with understanding what do we actually have to deliver. Public transport has a history. It was implemented over 150 years in India, or a bit longer. And it does a very good job. The capacity it offers is excellent. However, the population in India has grown at the same time from a few 100 million now to 1.5 billion. And I firmly believe that no one fully knows how people need to travel from end to end. And all the systems are being improved, and more capacity is thrown into it, and every system is doing the best it believes it can do. but in honesty, no one fully knows what the true capacity is that a system has to deliver. At least that's my understanding. And so there is digitalization coming in, because with a clever computer and data mining, let's say, it can start from there. It can understand how people want to travel, how freight is going from end to end. And then basically look at the bigger picture. Yesterday the word digital twin came up, and I think that's a good word there, to create a model that basically shifts everything into the same, I feel like, is that a good angle? I'm actually quite pleased to see that is the technical slide, because yesterday this was all the people, and I have to tell you that headlight is not very fortunate. Lots of people then realize there is some hair missing. So I don't want to see this. Yeah, please keep my technical slide. So I hope there is enough hair from the angle I see when I look into my mirror. But so I don't want to be told otherwise. Okay. So I would say, okay, I'm drifting with time. I spent 5 minutes right now, no? Okay. So Siemens has two platforms now that are trying to address the challenges of the transport system. One is the bigger platform, which we are calling accelerator. Okay, it's a word, but it's something I would say really powerful. It's a cloud-based platform where non-safe applications are at work to do many tasks. And this platform is not just the Siemens platform, it is actually open for other content creators to load apps and to make this bigger. And the idea of this is basically to create something that allows to understand demand, tailor demand, find out where the bottlenecks are, have apps that are digital twin type apps that are basically playing with understanding the network layout and where the bottlenecks, what needs to be adjusted. And this is, okay, the word ecosystem, okay, it's a modern word, but it is a bit like Google Android, where everyone can push something on there so that others can make use of it if it makes sense. So, and we are inviting everyone to put their ideas into the same cloud. It's not that Siemens makes all the money then, it's available for everyone. Okay, we make a bit of money. But, so that's the accelerator side, and that's the big digitalization side of things. And the other side is, okay, we are IRSE here, and we talk about signaling systems. That's the safety-related platform, and that's the main title of my presentation, so I have spent about 8 minutes before coming to the point, but I thought I wanted to give you the context why we're actually even talking about it. So the topic is that railway signaling system historically has very dedicated tasks. Railway signaling is mostly related to interlockings and automatic train protection to make everything safe and powerful, but not so much about optimization, about doing the same things but in better ways. And okay, oh sorry, it started already. If it is okay, I would force you to listen to a 2-minute and 20 seconds video, and so that gives you a concise overview about what I'm talking about, and afterwards I will rush through a few technical slides.
Safety and security are an important focus in rail traffic. That's why the control logic for signals and points has been run on proprietary hardware so far. But now it has become possible to use commercial off-the-shelf hardware for safety-relevant applications. This helps to maximize the use of existing capacities and can make axle counters, track circuits, and signals a thing of the past. The key is to centralize the control logic in a data center in a safe and secure manner. DS3, Siemens Mobility's new distributed smart safe system platform, makes it possible to run existing signaling applications on standard hardware while maintaining the highest level of safety. DS3 uses the multi-core architecture of modern standard CPUs to process safety-relevant logic applications in parallel in several processor cores. In this way, it becomes possible to migrate existing signaling applications and permanently move the control logic to the cloud. Field elements can disappear. Instead, the trains report their position to the central system via radio and receive their movement authority accordingly. Compatible with numerous existing systems and standards, the scalable platform is the basic building block for flexible cloud solutions and can be used to bundle the tasks of all interlockings and other components in an entire country in the cloud. This provides the basis for seamless geographical redundancy. At the same time, it helps to enhance punctuality through high availability, ensure highest safety and security, and reduce lifecycle costs by enabling the cloud-based control of rail operations. Moving the control logic to the cloud, Siemens helps you to make the most of your infrastructure and pave the way for sustainable, future-proof mobility. Siemens Mobility, moving digital, moving beyond.
Okay, I'm just realizing this is my timer there, yeah? 4 minutes 30. You cut this short, there's something not right. Okay, good. So, as I only have 5 minutes, maybe I would stretch it to 7. I'm not diving into these slides. I will do something else. I will give it the Indian context. This is signaling systems in India today. Everyone knows this. You have your stations, and every station essentially is an interlocking. The interlocking drives the outdoor via relay racks. And so it's all about that side. And then it's a lot of cable to go to the outdoor elements. And now with Kavach being in the picture, it attaches to the existing relay racks, and it's a solid picture. It works. But there is a big push now towards moving away from relay racks, going to direct driving of points and signals and access counters and so on, and change the interfaces to unified interfaces, protocol interfaces, so that it's not all based on extracting from relays, so do it more protocol-based, but still the same logic. But our offering or the suggestion is now to go the next step and basically reduce the need for cabling and even reduce the need for direct driving and shift this even further into the field. Having, as part of the ULINX world, distributed elements in the field. You can call them object controllers, element controllers, XCM, 1 million names for this, but they have the task to control the field elements very efficiently out there. They could come from any supplier. Frauscher will be able to handle ULINX protocols. Other interlocking suppliers will understand the language between these things. So this will be much cleaner in the future. That's basically the key offering of, 2 minutes 20. This clock is speeding up. I have to compare this later with the atomic clock. There's something wrong. So that's the main suggestion, to have a system where an indoor part is only the logic part of the interlocking, and the rest is handled via object controllers with dedicated tasks to control the field. And this speaks a unified language based on ULINX. Okay, it's an Indian decision what language is supposed to speak, but taking ULINX would make sense because that's now developing globally to become a language of choice for all the industry. So now I'm rushing. If we are already at this point where the digital interlocking is, or where the interlocking front end is the only clever part in the technical room, why putting this in one location or in every station room? Why not putting it central for one complete line, and let's control from there the complete line? I mean, that's normal in the railway world now, that basically instead of having intelligence in every station, you have it maybe for one line or for one zone. And then basically, if you're saying, I put my interlocking in one central location, I put my ATP controller there, I put my CTC logic there, so you have one room full of technical stuff. So then you can go the next step. Instead of putting all of this in dedicated hardware from one supplier, like from Siemens, which would be nice for us, but in principle, there's a better way. Putting this on commercial off-the-shelf hardware. And that's basically the big step now. So in the end, the digitalization, or basically the ability to load safety-relevant functions into a commercial hardware environment. And that's what this video was about, and that's what this picture is about. You don't have to do this, but it becomes possible. If you are thinking about centralization anyhow and shifting your main parts of the signaling systems into one central location, then I guarantee it will be much more efficient and cost efficient and lifecycle cost efficient to go the next step. And instead of putting it into dedicated computer hardware, which in Siemens would, okay, let me take I will use this as the final slide. Yeah, time is up, but I still talk 1 minute about the slide. And because this is explaining how this is supposed to work, how this is working. Today you have your dedicated hardware, different names in Siemens. Our West-Race interlocking use PM hardware and whatever. And this hardware is then substituted via normal server hardware, the multi-core technology, and on top of this we have dedicated software that allows to one-to-one transfer the logic from existing interlockings without touching it, without recertifying it, without any major hassle. It just gets loaded, okay, I'm simplifying now, like with a USB stick from an interlocking into the private cloud. And it works in exactly the same way, so nothing is changing. And from this moment onwards, you are hardware independent. From this moment onwards, you are not relying on someone saying 10 years later, sorry, I can't get the chips for my computer anymore. I'm struggling. For this one, it's generic servers. Yeah. So there's big advantages in there. And as my time is up, I would say I'm finishing at this moment. And there were still a few slides, but I think the main information have been covered. Everyone is nodding. I hope you would feel the same. Yeah, thank you very much for your attention. And most applause came from this corner over there. It's the Siemens wing. Okay.
Thank you, Mr. Axel. This was a nice peep into the future of interlocking on the cloud. Any questions now? We have a time for 3 or 4 questions, 5 minutes. Yeah. Can someone take the mic there?
Hello. Good morning. Myself, DST Rangia. I have one question that you are proposing cloud-based solution. Means for example, we have 100 of stations. All the application data will be shifted to a generic cloud server. From there, you will control the station equipments, right? So how it is different from the general CTC, which is currently implemented in Indian Railways as well as in other railways also?
Okay, first of all, we are talking about different applications. So the safety-relevant applications, like interlocking functions, they are normally not in a cloud. There is no system like this at this moment in existence, and we would offer it for the first time to put this onto a central server and control basically all the interlockings you think you would like to control from one central location. And so the difference there is that this would be the first application. I mean, there are pilot projects. We have a project in Austria where we are doing this, so we are not starting it in India for the first time. So we have existing applications. But let's say for railways, normally this is very different to what you were asking. What you were asking is the CTC. A CTC and interlocking are very different applications and have different requirements. So putting a CTC into the cloud somewhere is not unheard of, or putting it on a generic server. But we are suggesting to put the interlocking onto a generic server and add the CTC as well into the same hardware, because the hardware is so powerful, it can be scaled up to, I'm just saying, to control a complete zone in India, a complete zonal railway from one location, including all interlockings, this potential CTC, all ATP requirements, all on the same, we are throwing it in there. And it's done from the same location on generic servers. I don't know if it answered your question, but if not, we are still here the rest of the day, and we can have more dedicated discussions somewhere with a coffee.
Yeah, can I have a question, please?
The mic is over there.
Good evening, good morning, gentlemen. My very basic suggestion, rather more than a question, is, here please. More than a question, it's a suggestion that when we are trying to implement technologies, how we make it financially viable in a given environment. Because my observation has been all through, in the metros also, we are not able to make profit all over the world. Less than 10% metros make reasonable, survivable profit. We may have excuses around all the things, carbon footprint savings and all that, but there seems to be a lot of gap somewhere in the overall thinking process. All these proposals or technical papers, they are not covering the cost implications and the study on that. I think it is better we put in some cost element along with the technological improvements. So like in the mobile communication, there has been a lot of changes. Initially, we had a highly priced calls, and slowly somebody took a dig on that, and the costs were brought down. So today, we find mobile in every hand, almost. So that is the power of technology with the financial viability. Unless and until we work out towards that and provide the cost element along with the technology, it will be very difficult to push it forward. So that is my suggestion, and to work. Thank you.
Okay, this is quite a general, let's say, observation, but I would say with the initial comments I made and where I spent most of my time, I feel that the railway system in the future will offer the exact, let's say, answer to what people want. And that means they will have an end-to-end connection that makes sense for them, and they will actually pay a reasonable fare for this. So by using digitalization to improve the offering for people, it will pay for itself. And by shifting the, let's say, signaling systems from which are now in every station room, you have a lot of equipment, by slimming it vastly down to putting it only in one room for the zone, again, it will pay for itself. So it's not about, I mean, obviously I fully understand that before any contract will ever sign, things will have to be put on paper and fully explained, and pros and cons and cost savings and so on, but I guarantee with the improvements in the overall transportation intermodal connectivity, people will pay more or less what they are paying now, but they get a much, much better offering, and not for much more money for the railway operator. The railway operator will be able to unlock the capacity that's sleeping in the system, but no one is aware of. So that's not about extra money. This is about making the system more powerful out of the same infrastructure, just by rearranging the modules. So, okay, I could keep talking because that makes me passionate. Okay, but, sorry.
We are in a increasing competitive environment of a road sector or air sector, or maybe the drones in time to come, or waterways. So many sectors are opening up.
Yeah, I think, thank you for the comment. You can also take up later with Alex later on. Maybe one last question over there, gentlemen.
Namaskar, sir. Sir, I have a question that we are working into a reduction of electronics along the track side, making it more centralized. So, are we planning for reducing the axle counters, the DPs, and making the system more GPS based so that it is more accurate, as well as we have a direct transmission with the communication of the signals, means moving radio block in the future?
I think this is a little different than what Axel has presented, the cloud interlocking. So your question is more relevant to a different aspect of the signaling. We are not going to reduce the objects. Your point machines and few other things will remain. Train detection, as of now, we don't see anything replacement of axle counter or track circuit, they remain. But in future, something might happen. But his presentation was on taking the interlocking logic onto the cloud, on commercial off-the-shelf hardware, and centralizing all this thing. So,
Maybe
if you want to comment on this?
Just quickly, maybe our video has maybe give you this idea, given you this idea. And there was this part in the video which was saying axle counters and so on will not be needed. This is only true if the whole idea of the, let's say, signaling and operational technology is changing, but that will not happen overnight. So, so at this moment, it shows options where to put this in the cloud and without actually taking any elements away. But if the overall landscape is changing, only when the Bara trains are, is that the right pronunciation, on the network and everything is very, let's say, closed loop, then we can start reducing wayside elements. But if you have a mix of freight trains and all of this, we need all these elements that are in operation today.
Thank you. Thank you. I think very interesting session. I know there will be a lot of more questions. So Axel is also available in the Siemens booth. Maybe you can reach out to him later on. Moving on to the next presentation, and the topic is advancement in high-speed rail signaling using Packet 44 implementation and interoperable ETCS solution for platform screen doors. This is from RRTS project, and it is going to be presented by Mr. Navneet Kaushik, Director Systems for NCRTC, along with Naveen Pandey, DGM SNT from NCRTC.
Yeah, good morning, everyone. Thanks IRSE for allowing us to showcase what NCRTC is doing. This is one of the global first, among the many global firsts, what we have done. In fact, it's not only on signaling front, it's on other areas also, whether it's rolling stock, traction, in every area. Probably at this speed, which we have designed, 180 kmph, we are perhaps the first in the country. But when we come to the signaling front, then there are many areas where we are first globally. Among that, I'll cover few. And the most important one which we are going to cover today is the use of Packet 44 for controlling platform screen door. Apart from these few things, then other technological uses like providing IoT, providing distributed acoustic system, deploying cyber security measures. These are the areas where we have worked in. So going to the topic, a little bit of introduction of NCRTC, because probably few people may not be knowing that we are implementing high-speed corridors in the NCR region, which will be serving around 40 million people in the NCR. And the three corridors which are shown here are Delhi Meerut, Delhi Panipat, and Delhi Alwar. These are the three corridors, approximately 300 kilometers. And what we are targeting is that we can reach up to the headways of the order of 3 minutes, and therefore we will be in a position to cater to 2 million kind of daily ridership. Then few parameters. The design speed is 180 kmph. The operational speed 160 kmph, and the train will be available every 5 minutes. In fact, today, the small section which is operational, that's from Sahibabad to Duhai, around 17 kilometer. We are running train at every 15 minutes. And this will gradually the headway will gradually reduce, because in the month of February or March, we'll be extending it by another 27 kilometers. So the whole total corridor will be of the order of 42 to 45 kilometer. And then the 15-minute or even less operational headway will be there. Then from the signaling front, we have deployed ETCS level 2 along with hybrid level 3. Both of us have worked in CBTC environment for pretty long time in Delhi Metro. And we wanted to bring that experience. And therefore, this hybrid level 3 is helping us to reduce the headway. And that too is deployed on LTE communication backbone. Again, this combination is not there anywhere in the globe. And LTE, of course, along with what railway got, 5+5 megahertz in 700 band, we also got a similar band adjacent to the railways band. And this dedicated band is used for ETCS. Operational headway 3 minutes, and of course 3GPP release 15. This is what we ensured, so that whenever we want to switch to 5G, that should be easy. And in fact, we have already started looking for migration to FRMCS or 5G, because the changes we anticipate are very less. So maybe in few months' time, we might see FRMCS implemented here in our country. And then integration with PSD. This is an important thing. Nowhere in the world the PSD has been integrated with ETCS. We have done it. It's already operational on this 17 kilometer. And people who are visiting tomorrow, they can see that this PSD integration is already there. Of course, it is in a different way. It's through Wi-Fi, but right now we are testing this PSD integration implementation through packet 44, which my colleague will cover. And in the next stage, maybe in another 6 to 8 months' time, or maybe 10 months' time, we'll also have ATO implemented on this ETCS. And why PSD? The run-through speed on the platform is 100 kmph, and you can appreciate that if the train is running at 100 kmph on the platform, then it's very hazardous. So it's better to provide platform skin door to take care of the commuters. We have in Indian context, if you see, we have seen tendency of people crossing the platform through the track, and then also on the underground station, if you have to preserve the cooling, then platform skin doors are needed. So what we decided, and in fact in the beginning itself, we mandated this, that we will be using this spare packet 44 in ETCS implementation to suit our requirement. The details will be covered a bit later. These are the basic commands. In fact, those who have worked in metro where PSDs are used, they know this. There are some vital commands and the vital interfaces that exist between PSD and signaling. So just few of them. The most vital thing is platform PSD open command. Along with that, all door closed and locked, and then interlock override. These are the three commands which comes from, apart from that, there are two more commands which come from either the onboard or from the platform computer, platform screen door computer that is provided on the station. And this communication takes place through the ETCS backbone. So I'll request my colleague to cover a little bit on packet details.
Good morning all. Now we will discuss packet 44 data flow. There are 5 types of packet 44s which we are using in our project to meet the requirement of train door management and PSD management. The issue with packet 44 is that packet 44 is defined by ETCS specifications, but variables inside it are not defined. Whereas the length of packet is similar to the other packets, which can be defined with 13 bits. As NCRTC is pioneering packet 44 implementation, we have decided to maximize the number of variables which we can define so that the complete functionality of train doors as well as PSD is managed. As soon as train is routed to a specific platform from the entry signal, ETCS trackside, that is RBC, sends onboard a packet 44 which has operational data and platform data. It has variable like NID PSD, which is the identification for PSD. We can uniquely define each and every platform using this variable. We are using 3 types of trains, 3-car MRTS trains, 6 and 9-car RRTS trains. So this information needs to be communicated to train. For each type of train, we have one reference values that can be defined with NID BG. Train has to read these values. After this, train has to move a distance defined by variable D stop so that train can accurately stop at the stopping point. Number of first PSD to be aligned with first train door of active cab. This is required to align PSDs with train doors. Door authorization window at NSP. Onboard should have this information so that at the NSP window, door enable can be provided and door can be opened safely. As soon as the first packet 44 is received from ETCS trackside, ETCS onboard sends to ETCS trackside the second packet for PSD innovation. It has the same PSD identifier which onboard received from trackside, and on which side innovation is required, whether on left hand side or right hand side, these 2 variables can define it. As soon as door open request is received from rolling stock and train is standstill, in correct stop location, ETCS onboard sends to ETCS trackside the 3rd packet to open the doors. It has same PSD identifier which onboard received from trackside, PSD open command, and on which side PSD needs to be opened. As soon as door close request is received from IRSE, ETCS onboard sends to ETCS trackside the 4th packet to close the PSD doors. It has the same identifier which onboard received from trackside, PSD close command, and on which side PSD needs to be closed. After closing of doors, PSD are closed and locked. This information is communicated to interlocking from PSD, interlocking to RBC. Our RBC communicates this information to onboard, and onboard requires this information so that train can depart safely from the platform. This is the typical packet 44 data structure. First variable is NID packet, identification of packet. We can have maximum of 256 packets through ETCS. Q direction, validity direction can be defined with the variable QDIR. Length of packet can be defined with variable 30 number of bits. NID user, identification user, here NCRTC is there, so a number can be allotted. NID NIT function for providing the information whether this packet is being used for PSD function or not. Just now we discussed there are 5 packets, so NID NIT message can be used to describe those packets. NID PSD, we can describe each platform uniquely with this NID PSD. Iterations, number of repetitions. Train variable, we have 3 types of trains, so train type can be used, this variable, for defining the different types of trains. NID BG is the identification of the BG which the train has to read before stopping, and train has to move D-stop after reading reference value so that train can stop accurately at the stopping point. Door authorization window can be defined by these next 2 variables, D-stop min and D-stop max. ASD direction, in which direction train is moving, whether it is normal or reverse, can be defined with the ASD direction. Number of ASDs on platform can be defined with the variable NASD, and whether the what is the operation status of each PSD can be defined with the ASD operational status variable. All the vital functions between PSD and interlocking are managed through relay interface, wired interface, 4-wire double cut. There are many certain outputs from PSD which are critical in nature. For example, bypass, PSD bypass, interlocking override, close and locked. And similarly, there are certain outputs from interlocking towards PSD side which are vital and are managed by relay interface. PSD door enable 3 car, 6 car, 9 car, and PSD open command. This is the signaling interface block diagram. Here we can see between ETCS onboard and RBC, the communication is done through packet 44 for train door management and PSD management, whereas there is no RBC from RBC towards right hand side. Between interlocking and platform, vital interfaces are dealt through relay interface, and there are certain non-vital interfaces like synchronization of PSD with train doors. These type of interfaces are managed directly through network without any relay interface. This is the timing diagram with packet 44. Here we can see the door opening time with packet 44 is around 6.5 seconds, and door closing time is also around 6.5 seconds. Whereas in CBTC, this timing is around, for opening it is 4.08 seconds, and closing it is 6.43 seconds. When we compare these two timings, we realize that there is not much difference, and at this initial stage of implementation, the timings are quite encouraging, and I think the timings will further improve.
In fact, you have seen that how this packet 44, the 5 formats which we have used. Timing is a challenge because in CBTC what we have realized that even there it's quite high, because when I compare it with the present implementation which is through Wi-Fi, the time lost in the message exchange is of the order of 2 seconds or 3 seconds, whereas in CBTC is the order of 10 seconds, and in the current implementation it is of the order of 12 seconds or 13 seconds. We are working on this, how to reduce it. So out of the total dwell time of 30 seconds, the passenger exchange time reduces to just 16 seconds or 18 seconds. So that was basically what we wanted to present to you, that what we have done. And in fact, to test this, since the revenue operations are running, we have made a setup in our lab and along with test track. So a spare RBC has been provided and other equipments are there to test it because this is first implementation. So we are doing it on the test track. So that's all from our side, and this being the first implementation globally. Of course, packet 44 has been used for ATO or other purposes, like Siemens has used it on Thameslink, and then other implementations are there. But for PSD, for stopping, for accurate stopping, this is the first implementation what we are doing. Thank you very much.
Thank you, Mr. Navneet and Mr. Naveen. Time for questions. Yeah, madam over there. Here.
Thank you. Just one question. In packet 4, the fourth transaction that is taking place, why do you have to confirm which side of the door is to be closed? The door which was opened in packet 3, are you checking it again?
Hello. In fact, if you see that there are locations where PSD is on both sides, like there is a island track and platforms on both sides, then you have this choice that you can close the door on one side, let the other side remain open, and people, for example, if you have seen on the airports, when you have to disembark people, one side door is open, people disembark, you close it, then open on the other side, and then allow others to. So for that flexibility, this has been provided.
Any other question?
Yes, sir. Very nice presentation. I have two questions. Number one, the redundancy part I want to know. And the number two is the standard-wise, the cell 1, cell 2, cell 3, cell 4. So your design is, okay, belongs to which cell level, please? Thank you.
Yeah. So if you look at this ETCS implementation, it's cell 4 implementation. So communication from onboard to RBC, to interlocking, to the object controller, and then the final interface 4-wire double cut with the PSD. This entire flow is cell 4. So what was the second question? Sorry, I forgot that. Okay, redundancy. Okay, fine. So as far as the redundancy at processor level is concerned, so RBC is redundant, onboard equipment is redundant, interlocking, object controller, and the processor of PSD, everything is redundant except this interface between object controller and PSD computer, which is 4-wire double cut, that is single.
No, sir, just let me add on. If suppose by the packet 44 the gates are not being operated, then how that is to be handled? That's what I want to know.
Okay, so there is in fact one of the packet covered that inhibition command. That command, what it does is that suppose a particular train door is not opening, it doesn't allow the corresponding PSD not to open, and similarly if a PSD is defective, it doesn't allow the corresponding train door to open. So this is the way where we keep the correspondence between the train door and the platform screen door. But as far as redundancy in terms of, if you ask me packet level, I mean it's only repetition of packet which is sent, and that helps taking care of any failure scenario. Now I don't know,
Yeah, my question is, suppose with this system the doors are not getting open, then what is the next?
So again,
thank you.
So if PSD is not opening, is it one door or multiple doors? So if it is one door, there is a command available, physical command on the door controller. A person can go there and he can bypass it. Once it is bypassed, then there is another feature available that if any door is bypassed, the 20 kmph DSR is applied on the platform. However, train is allowed to move because it has been manually bypassed. If none of the door is opening, then again local level command is available. The driver can come out, peep out. There is a panel available in front of him. He can give the command on the panel
manually, so doors will open. Yeah, thank you so much.
Thank you.
I know this is a very interesting project, doing a lot of first and globally, and there will be a lot of questions. So maybe after the session, some discussion can take place. Moving on to the third, but before that, is Mr. Digvijay Sharma here? Can you please join us on the stage? He's Senior Director Sales, Sienna. I think his colleague, Mr. Amit Malik, he could not join us, so he'll be presenting us here. So then the next topic is intelligent data platform as a key driver for digital railway operations. And this will be presented by Mr. Sebastian Saharaj from Frauscher.
Thank you, Mr. Akhilesh. Very good morning, ladies and gentlemen. So, Frauscher, we don't need any introduction basically. So we deal with wheel detection and axle counting systems, and it's a 30+ years old company, fully focused on wheel detection and an axle counting system. So with reliable solutions, we make rail operations easier and more efficient. So I want to start with the challenges what global railways are facing, basically. So we heard about keynote speeches and inauguration speeches yesterday from Chairman Railway Board and AM Tele and all. So these are the global challenges. Basically, like we have a challenge in front of us, like warranty of operational availability, like on-time performance, and increasing passenger numbers day by day. So we heard that more than 1.8 crores of passengers we are dealing day by day in Indian Railways, actually. So similarly, global railways also, they are facing the similar situation. So day by day, the increase in passenger numbers are increasing. And to maintain all these assets, staff, basically maintenance staff are required, and that shortage is always there. And we have to quickly troubleshoot. Need for rapid troubleshooting is required. And we have, for all these challenges, digitalization is the only key, actually. So I'm going to talk about a couple of solutions, what we have and how we are progressing in Frosher in terms of digitalization. So let me go ahead. I know time is the challenge for me. 15 minutes I need to cover in both the solutions. First, I'll go with Frosher Connect. So it's a common communication interface for all Frosher products, basically, to have a communication with external world, meeting both safety and security requirements. So that is how we designed this Frosher Connect. So on the block diagram, basically we have axle counters, outdoor equipment at the level 1. And in level 2, we have the indoor equipment, axle counters. And then at level 3, we have this Frosher Connect environment. Basically, it's a combination of software and hardware. It's a platform where we connect to the external world. So it could be any diagnostic system, or it could be an interlocking with Frosher axle counters, and then the diagnostic app, what we have developed here. So Frosher Connector, basically the benefits at a glance. So it meets both safety and security requirements, and we can have interface in terms of multiple protocols. So we can have ULINK's protocol, the standard one. And we have our own safety protocol. It's an open protocol, Frosher Safe Ethernet. And we can also customize to interlocking protocols. So for example, interlocking could be like in Siemens, there's a West-based network communication protocol. And with Alstom, we have developed FSFB2 protocol. And with Hitachi, we have done it with our own FSE protocol. So we have done in both DFCCs with serial interface. So these protocols helps to exchange data, basically, in terms of data transfer. And from the cloud, basically, we can also load all security patches straight away through Frosher Connect. And we can have open interface for diagnostics via industrial automation protocol, open protocol, OPC UA kind of a thing. And even for distributed architecture, we can have this environment, and then we can have multiple connectivities. Yeah. So I talked about the software interfaces. Frosher Safe Ethernet is an open protocol, which we have our own protocol, which can be shared with our system integrators and partners. And we also have a solution with ULINK's protocols, and we can have with customized protocol, which we talked about, like interlocking protocols. Yeah. So let's quickly talk about serial and hardware interface. So just to have a basic understanding, so if you look at on the right side thing, basically it's a parallel interface. For each and every function, we need to run a cable, and then we have to interface with our equipment, basically with axle counter and interlocking. Whereas on the left side, if you see, if it is just a serial interface, we can exchange the data through a serial data cable, and n number of data can be shared with two-wire communication. So basically, serial interface is a digital transformation, I would say. Yeah. So these are the few functions which can be achieved in hardware interface on the right side. If it's a relay or optocoupler interface, we can only have clear and occupied status, and we can have direction information, and also reset can be exchanged. Whereas in serial interface, if you have either through an open protocol or a customized protocol, you can have n number of information exchanged through the serial information. So clear occupied, direction, IO data, resets can be exchanged, diagnostic data can be changed, and speed, wheel diameter, even number of axles in a section can be given. All these things could be on a vital platform we can exchange this. So the benefits of serial interface could be less cabling required because we are not connecting each and every function with wire basically. And when we have less number of cabling, cost is less number of hardware, less equipment and EC integration, and EC access to all information. So from a cloud or from a central server, you can have access easily. And installation becomes much easier, and maintenance also is less because equipment is less and number of wiring, everything is less, so maintenance is also less actually. Yeah. The differences, so we talked about the advantages of serial interface. On the flip side, on the hardware interface, you need extra hardware. For I/O exchange, you need the I/O boards on the interlocking side as well as from the axle counter side. And you need more number of cabling for each and every track section for delivering clear and occupied status, as well as for exchanging reset data, you need more number of hardware and wiring. And when we have a hardware interface, you need additional boards. So it's not just a serial exchange, it's basically with the hardware, each and every I/O has to be exchanged between the systems, and you need additional boards for additional data. And when we need more information, you need more contacts, I mean relay contacts, and more wiring. So obviously, the choice should be for a serial interface, and we should move towards serial interface in exchanging the data with our axle counters and any other interlocking. So moving on to the next solution, which is Frosher Insights. So it's an intelligent data platform. Frosher Insights is basically overlay on existing data logging thing. So where we have an event logger. So Frosher diagnostic system we already have. On top of it, we'll have this solution. So on the left, you could see sensors and indoor equipment that is placed. And then the platform which we talked about, Frosher Connect, which is nothing like software and hardware combination in which where we have gateway and firewall protection and all, and then it gets connected to a cloud, which is a central data storage, and where we have application loaded Frosher Insights. And there we are running a couple of apps, which I will talk about in detail for the diagnostics and motion app. So this is how the insight is basically on the block diagram level. The two apps which I am talking about, diagnostics and motion. So diagnostics is a higher ranking diagnostic system, and the main features is basically you can have a system overview on a dashboard which you can customize. So whatever you want to see from your installation, so those errors and warnings can be customized, and that dashboard you can keep it in front of you, and you can guide your maintainer basically. So for maintenance thing. So logging and messages, basically it fetch all the data from Frosher diagnostic system and it stores in the cloud basically in the Frosher Insight. And then when you have data, you can customize the screen, and then you can do many things with maintenance basically. So, and then we have an integrated interactive track plan. It's not just a track plan, it's an interactive track plan where you can get into a element level. So any DP, you can just click on it and you can get the information on those DP, including the current level. So you can get into the detail, and this can be accessed from a remote location. Yeah. And you can have an element overview, so whatever elements it's all connected in that particular system, you can get the overview of that. And you can have preventive maintenance and predictive maintenance also in that. And wheel sensor status can be monitored, and affected elements can be highlighted actually in a different color in track layout itself. So please come down to our booth where we have live system connected in our booth actually with Southeastern Railway, where we are doing a trial. So we can see more in detail actually there. I have 5 more minutes. So this is how the dashboard will look like, where you have this affected elements, errors and warning on the top, which can be customized actually. Basically, user can configure this dashboard also. And time trends of errors and warnings can be seen. And track plan, basically with the affected elements also, this track plan will be there. It's a signaling layout which you can see with all the DPs which is there in the particular section. So this is a snapshot from Southeastern Railway trial which we are working on right now, and it is also live connected here in booth. So this shows that sensor current statistics. So this is a snapshot on error and warning. So errors and warnings, whatever you have in that section for the 30 days, or you can filter that, in 24 hours, how much errors and warnings you are having in that particular section. That can be filtered, or it can be seen for the entire 30 days. The use cases of this Frosher Insight could be for remote troubleshooting. You can guide your maintainers. So sitting in a test center or sitting in your office, you can guide your maintainer actually. So seeing the data, you can guide them on the maintenance part of it. And you can also do a proactive maintenance. So when you know that the current is drifting, or it's a overcurrent or a wire break, sitting in a remote location, you can guide your maintainer, and you can do a predictive maintenance also. So this particular sensor needs your attention. That kind of instruction you can pass it on to your team. And we can also do root cause analysis on this. Yeah. So I'm coming to the next app in Frosher Insight, Motion, which is nothing but a ticket system, I would say. So where when there is a need for a task, you can assign the task to your maintainer, and then he can get to the maintenance, and then he can report back in that same app actually. So he gets a push notification, and then this can be handled there itself in the app. And it is not just for maintenance. You can also digitalize installation, testing, and commissioning also. Today, for every installation, we have to sign this PCCL, pre-commissioning checklist basically. So that can be digitalized. So this can be digitalized, and you can have a traceability for all your installation actually. So you no need to fill up each and every DP. You have to sign this PCCL, which can be digitalized and can be stored in a central server. So this is what I was saying. When there is a need for a task, you can assign it to a particular individual, and that app will send a push notification through SMS or through WhatsApp. So this push notification will be received by the maintainer, and it will be assigned to one particular individual. So who is working on it, you can monitor that, and then the task will be executed and then reported back. So in a central location, you will have a complete traceability. So the functions could be, it can be used offline also. So he can do everything offline, and when it gets connected to the internet, it gets uploaded to the cloud storage. And structured task overview is there. Defect documentation, how this failure was attended, what was the root cause, everything can be documented in that app, and it can be in a central location, which helps you in further maintenance also. Traceability of all activities. And we can generate PDF reports, basically. So when we have multiple data, any reports can be generated out of it, actually, the way we want it. Yeah. And photo documentation is feasible. So whenever he goes to the site, he can click a photo and then attach to that particular event. Yeah. And geomap integration is one of the possibility, which can be linked to OHE mass number or a signal number. So we can do, there are many possibilities actually. We can do a segmentation, and we can have which section is having this particular sensor. All those things can be linked to a map also. And different data fields can be just a checkpoint. So instead of writing each and everything, he can just do a checkpoint and then proceed with further tasks basically. And this app will directly synchronize with the cloud, and this goes to the central location basically. And multilingualism is a possibility. So possibly we may have a Hindi app also in India, probably. Yeah. So same thing. So any questions? I'm done with these two solutions, basically Frosher Connect and Frosher Insights. So digital transformation is the key, and Frosher is already working on it. So a couple of years back already we started on the development of digital transformation. So any questions?
Thank you, Sebastian. So time for questions. Can someone bring mic here in the front row, please?
Hello?
Okay, okay, go ahead.
First question is, the that you are saying you have a central, I'm here, central server storage. So as of now, you are, I think, testing with SECR, right?
SCR, Southeastern Railways.
Achha, Southeastern Railways.
Yeah.
So for that particular central server is located at Froscher's premises, or it is located with SER Railways?
It's not with the railways right now. We are using an external cloud. Right now we tied up with Microsoft actually. So we are using that external cloud for this.
So the next is, so if NFR, I'm from NFR, if NFR goes for this kind of solution, Froscher Inside or this application motion, so we will be able to get complete access of this server first, or the complete data which is available with your server will be shifted to our blade servers or whatever is the generic servers we are maintaining at our premises.
Definitely, sir, we can have access of this. Complete access can be provided to the user railways. It should not be an issue. Right now, we have not commercialized this product actually, but in future it could be on subscription basis also. So this we can discuss about it. But today we are talking about the technical feasibilities. But definitely, data can be accessed by the user railways for sure.
But the complete data will not be shifted to our servers, right?
Shifting we did not think of for now, but we can think of this also later. Yeah, if at all, if it is really required. Yeah.
Okay. Thank you.
Thank you.
Thank you, sir.
It's an interesting presentation, and in some kind of a concept which I think has multiple possibilities and use cases. The one observation that is quite flexible in the interface from the angle of U-links and any customized interface which you want. My question is that while you were indicating that a lot of information is going through the serial interface, you mentioned about the wheel diameter. I wanted to know to what extent it is precise and accurate so that it can be used for purpose of rolling stock maintenance as an interface to the rolling stock system. Thank you.
Yeah, thank you, sir. Thanks for your question. So basically, this wheel diameter is one of the options which we can share it basically through serial interface. And this can be used for any application. So when we have two sensors in one particular wheel DP basically, so we have system 1 and system 2, and we are able to establish a direction as well as we can measure the diameter of the wheel actually. So this information vitally can be shared to any external system for sure. Yeah. Accuracy is 100% and it is cell level 4. Yeah.
Can you throw some light on how many deployments have been there in the field on Froscher Connect?
Froscher Connect, today we have done a trial in Southeastern Railway, and very soon we'll be deploying in South Central Railway also. And in future, Southern Railway is showing interest on this, and slowly we'll deploy across the railways. So right now it's in the early stage, I would say.
Yeah. Railway is going for SMMS, Signaling Maintenance Management System. So many things we want to do what you are conceiving here in application motion. Yep. Is there any plan to integrate these two things? Because in isolation, so many diagnostic tools are coming. Integration will be an issue. Any thought on this?
So this data platform can be used for external systems also. So we can have API interface or something, and then we can integrate all the diagnostics into this platform. When it is in storage, I mean in cloud storage, you can have one platform and then you can customize everything there. So this is in future it will be possible, and we can also extend our data, diagnostic data, through a XML interface or something to the external S&D center kind of a thing. Yeah. This is feasible, sir. Technically, it is feasible.
It is feasible. But only thing is that the work has already been started in that direction. So let us think over.
Yes, yes. So the point is well taken, and we have already identified that through API interfaces we can integrate into our platform. The external diagnostic data can be integrated into our dashboard. Yeah.
Thank you.
That we already thought of. Yeah.
Good morning, sir.
Yep.
Sir, my question is that do you have any statistics of what is the data of false positive and true positive what we have implemented in Southeastern Railway?
So this we can see actually in our booth. We have connected our Southeastern Railway installation. So there are certain false alarms. I would say it is basically like a few DPs were disconnected, so it is not matching with the configuration. So those alarms are there in our system, which we can discuss in detail. Please come down to our booth and we can have a discussion in detail, sir.
Sir, thank you, sir.
Yeah, thank you.
I think that's it for this part of presentation. So moving on to the next one, and this is advanced electronic interlocking solution, wayside station platform with hot standby for high-speed train operation with RAMs. Quite a lot of topics intertwined here. So I'll request Mr. Balmurugan from Hitachi Rail STS to present his paper.
Thank you, Mr. Akhilesh. Very good morning to all. As Mr. Akhilesh told, it's a lot of stuff we are going to discuss here. So we have 15 minutes time to discuss. I will try to cover as much as possible in this presentation. So when we talk about the signaling, the contribution for the Indian Railway need of the hour is mainly on many fronts. Basically, there are three major needs today. First need is we have to reduce the traveling time, and we have to enhance the safety. There is no compromise while increasing the train speed. And of course, we have to enhance the passenger comfort. So these are the main three criteria in which we are supposed to work on that. So in order to reach these objectives, so what are the major contributions which the signaling industry can provide to Indian Railway? If we talk about the Hitachi, we started installing the electronic interlocking way back 23 years back. And compared to those days and today, I don't see much development in terms of integrating the stations and taking it to a centralized control. So now we have to integrate all the local controlled electronic interlocking systems into central locations where we can apply more standards and safety norms so that the safety and the reliability is enhanced over the larger section of the stations. So that is the major need. And secondly, we need to, when we move everything to a centralized location, we have to deal with disaster management. So we have to deal about the capacity of our system handling such situations. Then, of course, as we discussed before, the field gears will remain in the same place. So we have to take control of the field device into the central stations through the safety application layer. And so we should decentralize all the field gears control from local to the central place. Then finally, the operation control also should be shifted from local to central locations. So we have to handle the wider range of management of systems across the section. So these are the major requirements. In addition to that, when we talk about the safety, signaling does 50% and remaining 50% we have to deal through the ATP. So now there is a total disconnect between electronic interlocking and ATP because it is handled by a different group of OEMs. Now this is the high time we have to integrate both systems to talk in a safe manner and exchange the data. So this is another requirement we have to discuss. Then the last one, it's not the last one but not the least, we have to discuss also on how to deal with the local repair work and the safety of the people and safety of the system and safety of the operations. So now it is totally controlled manually. So we have to form a system, a safe system to deal with such situations in future. So these are the basic requirements we thought we have to deal in a near future. So when we talk about the centralized controls, so from Hitachi we suggest a solution called Wayside Standard Platform, Hot Standby Plus, which is a third generation system. So we will have the central processor at remote locations that will be connected to the field device controllers through optic fibers, and the field controllers will take the command or will take the command from the processor and execute it and give the feedback to the central location, which is similar to what Siemens has produced before. So it is almost same, but so this is out of three major sections. This is the hot standby processor. This will be located in a centralized place with architecture of 2 by 2 out of 2 system. It's of Cell 4 with high availability and reliability. All the train management will be done through this logics, and it will also interface with the human machine interface system through wide area network scheme. So this is the third section, which will deal about the human machine interface, that is the centralized traffic control management. The server will have in a centralized locations, and we can have the local control panels at the stations or at divisions. So we can switch the control from centralized place to the local control. So there are the possibility of switching the control from central to local. And this, the panel layout and the command and the warning area can be configured. So this will be running at the software of Cell 4 level. And we can, as I said before, we can switch the control from centralized management to the local control and vice versa. And this is the third system peripheral device. So this will control all the field gears, and it will interface with the main processor through optic fiber. So we will have the CPU 2 out of 2 architecture CPU in this field device control units. And through this, the points, signal lamps can be driven, and we can also have the interface board for interfacing with the axle counters. And we can attach another called PCB for managing the IOs coming from RBC or going to RBC from IXL. So this management can be done through the IO boards. So this FDC configuration can be configured according to the need of the field and need of the other subsystems. So basically the system will work on 3 Ethernet arrangements. One is the vital communication. The safety nucleus will be communicating through this network. And the second one is external communication. The communication from other subsystems or other systems like Kavach, then ETCS, and electronic interlocking of another OEM can be communicated through this network. And the third one is the communication network for the HMI, the human machine interface. And this network will be used for the diagnostic of the system status. So when we talk about the disaster recovery capacity, so we can suggest a centralized or distributed recovery configuration, having a safety nucleus at one place and the field devices on another place, and we can have emergency room where we can replicate the same system in another geographical location in 1 or 2 more locations. So this will meet this disaster management requirements. Then next one is when we discuss about the design and the validation process, currently most of the 90% of the process are done manually. So we have to move towards automizing this process by development of region-specific tools for the design as well as validation. And again, diagnostic and maintenance management system, we would like to propose by using through the web client browser also, along with the cloud-based networking. So this will enhance the communication with the maintainer and the operator. And we can fine-tune the level of diagnosing to the rack level, to the board level, and also to the specific field gears level. So this kind of in-depth configuration we should be able to manage. So when we talk about the troubleshooting, so currently it is mainly depending on the skill set or the knowledge of the maintainer. So which we would like to propose to use generic artificial intelligence tool, which will have all the historical intelligence with the system. And whenever the maintenance call is received, based on the historical data and the location specific data, it will precisely suggest the troubleshooting order to the maintainer so that we can reduce the downtime. So we expect 60% of the downtime can be reduced by applying the generic AI solution for the troubleshooting. Then another one which I covered in the beginning, that the possession management system. So we have to hand over the control to the local repairing team in order to execute their work in a safe manner. And again, we have to protect the safety of the people also working on middle of the track. So we should have sufficient level of integrity, safety integrity in handing over the section and taking over the section. So we manage this through a system called PMS using SRS subset 98. So this is another solution from our side. And finally, after the major accident this year, so we have triggered our R&D to provide more solutions on the point detection systems. So we have come up with one idea of using the proximity switch to be installed on the point zones. So that will send the positive detection of points back to the interlocking. Then in addition to the existing in logics, this input will go and it will act as a second additional safety layer for the train movement command, etc. So these are the topics I covered. I think I almost covered. So I'm okay to receive any questions.
Thank you, Mr. Balmurugan, for completing the topic well before time. So we are able to cover up for the previous extensions of time. Let me open the floor for some questions now. Maybe if you can raise the hand, someone. Yeah, over there. Mic over there, please.
Sir, nice presentation. Regarding the proximity switch at point, just I want to know, kindly put some more light that the switch is single or how the system like you proposed. Am I clear?
Yeah, you are clear. So the proximity switches will be fixed on the rails. Then it will have the transmitter which will be mounted the nearest point, probably on the junction box of the point machine. So from there it will be sending the signal through Wi-Fi. So there will be a receiver at the stations. So that will take the input, and that input will be integrated with the IXL.
Yeah, yeah.
So this is
now
the
the
basic
switch
concept.
is single, or there also some two numbers or something?
That we can configure. So it is a concept stage only. To start
Just
with, we can
it
have a
is,
single system.
my idea.
Yeah.
Previously, we used to have this sort of technology where the maintenance is the problem. If I am correct, the mechanical switch is connected to the electrical, okay, the capturing of the status of the point, right?
Yeah, yeah.
There, please add on, one is a NC and one is a NO, thereby the reliability and the redundancy will increase. Have you got it?
Yes.
Yeah, instead of
We can
single,
configure,
go for two.
yeah.
That too, where the proving a switch, there must be a two ways to prove that is. One is NC and other one is NO.
Yeah, yeah.
Thank you.
You are right, yeah. We'll consider that.
Hello, sir. Here. Here, sir, on your left. Sir, my question is, you have introduced WPS systems for keeping the logic of this interlocking at centralized place and direct driving those systems at the field gears at remote locations. My question is that because our train operations are real-time systems, is there any bottleneck of latency while giving those commands from a centralized location and direct driving those field gears at remote locations?
No, we don't foresee such situation because this is quite fast. Compared to the local management, we will not feel any difference or latency in the real-time basis.
Sir, is there any geographical distance limitation for keeping those logics at some remote location and driving those field gears?
As Siemens was suggesting before, the entire divisions can be managed through one processor at one locations.
Okay,
and
sir.
we can combine more than one divisions also. It depends on. So for Hitachi, we have the limitations of handling a number of IPs through one processor. That doesn't mean that we can't exceed more than that. We can stack another processor side by side, so we can increase the number of stations. So I don't think there will be a constraint on the distance.
Sir, but there can be situations of command conflict at wayside stations, means reaching from two different paths. If there is a redundant path, commands can conflict at wayside stations.
When we talked about the distributed resource management configuration, so we can have a number of locations based on this constraint.
Okay, sir.
Thank you.
My question is here.
Yeah.
You talk about advanced electronic interlocking system, and my question is basically related with the computing capability of that system. Let me tell two examples. Right now, just not much time passed, we developed Kavach version 3.2, and then little modification we did on that, and we changed the version, and we found that our basic system, basic computing unit is not capable to handle that modification, and on that case we need to change that basic microcontroller, and that deployment of that version is taking much delay on that. Similarly, your own system at field is not much capable when it comes to computing. Little modification in the yard or little enlargement in the yard gears, we have to replicate your own computing unit in a multiple way to handle. From that perspective, it is good that you mentioned that you are using microprocessor here. We are seeing in field microcontroller in most of the signaling system. Yeah. And that microcontroller are also, I understand, to control the cost, we are using a very primitive or not much capable microcontroller in the field.
Please come to the question.
From that perspective, how capable is going to be your computing unit in this advanced electronic interlocking system? And my second question on that is, when we are going to control all the field gear from centralized unit, on that case, when the ring would be large ring would be generated, on that case the experience which we are getting CTC, which we have installed at Tundla, how that kind of problems, you are aware about the problems we are facing, how your the system you are planning is going to tackle that kind of problems?
Yeah. So basically, it is a sort of teamwork. So as a OEM, we should not think we are the solution provider. Or from railway side, they cannot say that it is the part of OEM which they have to give the solution. So it's a joint effort. I would say the functional requirement specification for such advanced electronic interlocking system should be discussed in detail in a joint manner, which RDSO right now is doing it. So we are in touch with RDSO from time to time to frame such requirements, FRS, where all these capacity constraints from OEM or the requirement expectation from the field will be discussed, and we will come to an agreement, common agreement. So for that, it is worth spending more time to deal such discussions and come to a conclusion. Then we have to launch. So maybe in Kavach, we are going very fast. That's why we are getting into all these kind of teething issues. Yeah. So this, my humble request is, it's a joint effort. I request all of us to sit together and finalize the specifications.
Thank you, Mr. Balmurugan. Thank you for your topic. Moving on. The next topic is converged and coordinated multi-layer infrastructure networks, and this will be presented by Mr. Digvijay Sharma from Sienna.
Thank you, ladies and gentlemen, for giving us time. Absolutely excited by the questions asked and the responses given. We are network. Before I give my introduction, I'll just go back to the last question that was asked on the network challenges that you would have around latency and quality of service. How would those problems will be solved? The two commands the gentleman asked coming out. Most of you might not be as familiar with Sienna as your counterparts are in the network side of the world, because we take care of, we are the #1 connect piece provider globally. All the tier 1 service provider in India are our customers. You name it, Airtel, Jio, Tata, Voda, all these are our customers. And globally also Verizon, AT&T, these are our key customers. And we are putting more and more focus on government side of business, and that's the reason why we are present here today. In India, we have over 2,500 employees working on R&D largely, developing software and hardware for around the network solutions. So today I'm going to talk about the network, and while I get on to that, I'm literally amazed with the kind of automation that is getting in to the networks, and then hence the requirement of that IoT devices getting connected to command control centers, and hence the dependence on network. So it's very close to heart, and very excited and thrilled to be part of this forum. As you guys also realize in these questions, the networks are becoming far more important as the IoT is going further, and because of the reliabilities that you guys want more into the system, you want them to be fail safe. So the importance of the network is even more. And networks are needed not only for the IoT devices, but also for the automation that is going to get through into the network across the globe. The CCTV systems, the monitoring systems, the unmanned sites that are there, everything is getting automized. And I was thrilled to see my friend from Frosher as well as from Hitachi. The AI/ML is not only hitting the world, it is hitting the railway networks also. We want to do preventive automation, preventive maintenance through AI and ML. And all this data is going to get into cloud, and hence the reliability of the networks is even more. And there would be multiple such networks that would be there. And so you have got LTE networks, you have got IoT networks, you have got command control systems, you have got AI/ML. So there are multiple networks that would be needed, and hence there would be multiple technologies that would be needed. You can think of how many such networks you can have within a large size infrastructure of Indian Railways that you have. And apart from that, the complexities around the demands and needs of various devices that you have, there is an architectural shift that is happening in the networks globally, not only just in railways. Like you heard from my friends in Hitachi, they spoke about AI and ML, which is going to be part of the ecosystem that is getting built today. There is everything that is getting moved on to the cloud, and then the workloads are getting moved on to the cloud. And hence, the way the networks were built are going to be different. It goes to the point of the latency, because now the sensor is coming to the command control, and then from command control they are going to the servers. Gentlemen spoke about the system is in Microsoft Cloud. So there is an architecture, because you cannot have that kind of compute sitting at each and every site. Then there is a concept that is called mobile edge compute, wherein the latency requirement is so low that you need to have the actuators working at a very low latency. Then you can have something that is called mobile edge compute. So there are different concepts, because the compute is needed on real-time basis at local locations. And there would be a need of compute at the centralized workload, wherein you would analyze the data, process it, and come up with some kind of analytics. So there are different kind of workloads that are there, and hence the processing of those would be needed. And then there are different kind of signaling that would be needed. Some would be time specific, some you can have a little bit of relaxed latency requirements. So there is an architectural shift that was happening earlier. Rather than we used to talk about E1s and P1s connecting these SCADA systems, there is the traffic is also increasing. Moving on further, as the traffic is increasing, the capacities that you need is also increasing. Earlier, the main requirement was low-bit SCADA system and voice. Now there is enormous amount of data that is getting pumped through these networks. Now video is also part of the requirement of these networks. There is lot of AI ML that has been done based on the video surveillance that is being done in other industries also. If you talk about agricultural industry, there is lot of surveillance that is being done based on the video footages that are taken, and that can be further processed into the cloud workloads, in the network workloads, and then there could be lot of fault detection that can be done through those. So that all these video streaming data onto the cloud would require a lot of bandwidth, and that's where the expertise of Ciena comes in. We are the market leaders. Today we have so largest number of 800 gig trans receivers across the world, and we are the first one to give you 1.6 tera wave per lambda, and we help you to provide the maximum bandwidth out of each strand of fiber that you would have. And we have worked in a very, very large collaboration with organizations like RailTel to provide connectivities to the big OTTs that we have. The other aspect that I would like you guys to leave you with you guys is that, you know, India is becoming going to be third largest economy. The importance of railways network is going to be critical there. So whatever that we are building is not, we should have at least in our mind that it should be not only for year or today's requirement, which is urgent, but also from the perspective of what we would be needing for another 5 or 10 years from now. Because building such large infrastructures is not a daily trigger, and considering the fact that my friend mentioned here about the shortage of funds also. So whatever that we are building today, we should keep in mind how long it is going to last, whether what we are building today is going to cater to the requirements of tomorrow. With the advent of AI, ML and generative AI, the amount of data that can be captured and can be put to use by all these cloud compute resources is enormous. So it makes all the sense to capture as much as data and put it back to use. So, and maybe even more. So whatever networks that are being built today should be kept into mind for future years. The other aspect of it is that not only the different networks that are needed, but also in each network there are different technologies. We talk about IP, earlier it was frame relay, then it was TDM, then there is WDM, and so on and so forth. Then wavelength, then photonic infrastructure. So there has to be a simpler, flatter network for you. You cannot run multiple networks to serve one requirement, another network for another requirement. You need a single flatter network so that it is one network to manage, it is simpler to manage, and lesser overheads on operations. So that's the idea. So globally the networks are converging. IP and optical, you would have heard, that is converging. What we specialize in, that it should not only converge, it should collaborate also. Right, IP and optical as well as earlier TDM, these technology, while they are converging, it should not be that you have a product, a networking device, it has got TDM interfaces, IP interfaces, WDM interfaces, but when you look at through command line, they are very different. Their treatment is different. What we do is that we provide you a single pane of glass for all these technology and simplify these things so that it is easier and more efficient for you people to put into force. So what we say, not only converging but collaborative convergence. That's what we mean by that. Now another aspect is that bringing humanity to innovation. There has been a focus all across on the carbon footprint. We use today 3 nanometer chipset, which is the one of the highest, the latest technologies in the area of compute. Why we do it? Because of the purpose, not only it brings down the cost on day 1 basis, but also day 2 and day 3 tomorrow. What it does is that instead of using these hand devices that we have, the mobile phone, the compute power that they have today is far more than the computers that we had as desktops in our offices and at our home 3 years back. So it brings down increases the compute power and hence the space also. Space is also an OPEX. Then also the carbon footprint, the power consumption is less, as you would need much lesser compute resources into your sites, offices, as well as in the data center. So we continue to invest into the bleeding edge technology so that you have got most cost effective capex as well as OPEX. That's pretty much from my side, and I'm open to any questions that you guys might have.
Thank you, Mr. Digvijay, for completing it quickly. So the forum is open for questions. So a question from my side, actually. This IT and operational, OT kind of separation. So a lot of action is happening on cybersecurity, on operational components. But is there something also, in terms of cybersecurity, IT infrastructure providers or network component providers, they're also working on these kind of things?
Sure, there is a lot of focus on the security aspect of the network, because we need to make sure that the network equipment is fail safe. So we do lot of we have our own standards and protocols that ensure that there is no ports open and there is no firewalling attack. Plus our transceiver are also encrypted. In case you want to ensure there is no tapping happening between different stations, we provide you encrypted waves by which the traffic itself is secured. Not only the devices, but also traffic while in transit, it is also encrypted. So that makes sure that the security element is covered.
Thank you.
Hi, good morning. My question with respect to would be on the infrastructure network which you were mentioning. and you mentioned about the telecom companies across the India. And we know that Railways got 2.4 lakh crore as a sanction for the budget for various infrastructure activities. Now, when you talk about telecom, they work on a build, operate, and participation contract. Like 2% of the total revenue goes to the IT setup, and entire cost is managed by the IT company, whether it's IBM or Mahindra or XYZ. Now, in Indian Railway context, it will be build, operate, and transfer. So you make your margin and your cost plus model, or you will participate in the overall functioning of the, because this is a very high-tech industry we're talking about. And in 3 years' time, as you mentioned, that the mobile phones are much more faster than the laptop. And the laptop life is 3 years, a desktop 8 years, and mobile phone is 1 year in terms of Chinese company. So with respect to various platforms which are coming, how will the Indian Railway manage their budgets? End of day, it's taxpayers' money, and Government of India's budget is limited with respect to infrastructure and overall economy. So if you can explain, how will you participate as charging a fee to the entire infrastructure and not taking the full cost on day one?
So I will split this thing into two aspects. How do you wisely use the budget? I think there has to be a lot of thought process that has to go in choosing the right technology. There are various flavors of technology by which you can build your network based on the requirement and the potential to generate revenue. Like if you talk about the fiber, at the end of the day for these LTE-R deployments, where there would be a radio which would be placed approximately 3 to 4 kilometers on the tracks. So there has to be a fiber that needs to be laid out, and fiber for the utility companies is a precious resource. So you can generate revenue out of that also. It's not just the expense. That's one aspect. So how do you, and then, so that becomes part of how you think for the future and how you build your infrastructure. So there could be a discussion on how we build our infrastructure. We can generate revenue out of it, and we can make sure that it is ready for another couple of years to come so that you don't have to reinvest. So one aspect is the strategy part of it. The second part of it is the commercial model that you are touching upon. Obviously, there are different commercial models. We usually work with partners, Tech Mahindra and others also could be potential partners. But we can obviously discuss with railways and the esteemed leaders here what kind of business model constructs that are more suitable to them, and definitely we can come to a solution there. We are open to different commercial constructs.
So Digvijay, I think question also bordered on the lifetime of the network components being provided, because some of the signaling systems, they come for 30 years, 25, 30 years, but with the evolution of technology, when he gave an example of mobile phone and on, you're replacing so quickly. So whether these network components which you're providing today, whether they will come good for next 20 years or 30 years, or there'll be a need for replacement earlier on?
So what I have seen in my career is that usually the network equipments don't age out. They are still reliable. They still keep on working. It's that the amount of capacity that you generate out of it, that becomes short. So you end up upgrading it. It's like, like in PSTN that we had at our home, would give you bandwidth at your home of few kbps. So the copper wire and the modem is still okay, but the problem is that is not giving you the enough bandwidth that you would need for a high resolution TV that you have at home, the work from home Zoom sessions that you would like. So you end up getting fiber there. So, and that's where the question comes up, right? Right now, the most of the infrastructure that is already being built is built on fiber. So essentially that piece is there, and it makes more sense to invest into a capex which is more future looking. So the question is not around whether the product would sustain that life or not. The question is around the usability of that product, whether that would last or that long or not.
Thank you. I think Franz has a question.
You touched on a very interesting topic by saying the avoidance of CO2. I think it's also a moment for reflection, because the more possibilities we give, the more we're consuming, which means you're not avoiding, you're also maybe helping to get more use of CO2, because the possibilities you create are giving people the opportunity to use more computing power, shifting everything to the cloud has has brought more flexibility, but also more energy consumption. IT is now good for about 10% of the world's energy use, just by having all this stuff. What's your role in that?
So, what we think is that, so it's much broader question, and it can go in many dimensions, right? And I would like to keep it short with understanding, but I'll make an attempt to answer your question. So IT workloads are increasing, but at the same time that you look at the amount of ease that these IT workloads are bringing in. Like if you go to any airport, most of the advanced airports that you go to, you just put your passport there and you scan through. There is no immigration officer. Look at the amount of time that it has saved for everybody. And all these people who are traveling, their time is much more productive when they are actually working and doing good things that they are supposed to do. So, in my mind, technologies are bringing good, and that's the reason why mankind is investing into it. The moment it becomes less good, it won't be adopted, right? Our role is that we ensure that whatever new products that we bring up, because there would be need of capacity. I can do it in an inefficient way, or I can do it in a more efficient way. So what we do is that the more products that we sell, the new products that we make, they should be more efficient. So we keep our thought process in that alignment.
Thank you, Digvijay.
Thank you.
Moving on to the last topic of the session, AI-powered OFC DAS-based intrusion detection system, and it will be presented by Mr. Ratan Shah from Bitkom.
Good morning, everyone. Thank you, IRSE, for giving us an opportunity to present our system. We, Bitkom, Indian company, we work very closely with Indian Railways, especially in signaling and telecom, where we do in-house in Make in India hardware, software, IoT devices, software especially on AI MLs. These are our basically expert areas. This presentation, I'm going to present this the presentation basically on the intrusion detection system. That is basically in this agenda of the presentation is I'll give you an introduction of IDS, then we'll run through one of the application which we have deployed, and then architecture and some of the way forwards which we learned from the existing implementation which we had. So I think yesterday also there were some presentation on intrusion detection system. On this topic, basically the objective of intrusion detection system is to sense and identify various parameters remotely over a optical fiber. Optical fiber is an asset which is very very important asset of Indian Railways, which is existing pan India. So we want to use that optical fiber as a sensor for the various applications which can monitor up to 40 to 80 kilometers over a distance. In IDS basically there are right now three kind of, I would say, technologies or parameters monitoring happens. One is distributed acoustic sensing, which is basically ray lag backscattered phenomena, where we can monitor the vibration and the sound nearby the optical fiber. Then there is a distributed strain sensing. This is basically Brilliant scattering, which is monitoring the strain near the fiber because of underground earth movement. Then there is another thing which can be done on the fiber is the distributed temperature sensing. So this is a Raman effect which used to monitor the ambient temperature in the, for example, in a relay room, you can monitor the temperature over optical fiber. These technologies, on the top of this, we have to do edge computing and artificial intelligence. to get the application out of the data which we will be receiving on the fiber. So what is basically distributed acoustic sensing? This is basically a laser source which will be continuously sending laser light on a fiber. So in this case, we need one dark fiber, and the laser will be continuously sending on the fiber. And like you say, you know that fiber is made of glass. So there are a lot of particles, impurities in the glass. So whenever fiber laser pulses goes, and that impurity sends a backscatter. So that is kind of Rayleigh backscattering. When there is a movement, the different kind of backscattering comes. So that backscattering we are analyzing, we are doing the signal processing, and then we are applying the intelligence to give you a classification what kind of movement has happened near the fiber. So this particular movement is mostly related to acoustic or vibration near the fiber. Now the second, I was talking about how fiber can be used for strain monitoring, that is distributed strain sensing, where when we have a fiber laid underground, then generally in case of, for example, landslide, there are a lot of slope, downslope movement are there. So when the earth movement is there, then basically the surface displacement can be monitored with the help of, because there are some fiber characteristic changes, and that monitoring can happen with the help of this DSS strain. So there is a Brilliant optical OTDR based technology available. On the top of that, we can apply our data science and then give you detect the different phases of landslide. When basically landslide evolves, it evolves slowly, and then we can predict that it started moving. So this use case we are right now implementing in North Frontier Railway in Silchar division, where this is work in progress. So I think right now I will be giving a detailed implementation of elephant intrusion later on. So these are the other applications which can be possible with the help of optical fiber based sensing. So like elephant movement near railway track, landslide, rockfall, digging near the fiber, rail flat wheel, rail crack, and then some of the application like LC gate train approaching LC gate by identifying the train movement near the fiber. So I think most importantly, the overall architecture of the IDS system is we have a edge computing device which will have a optical fiber sensor, signal processor, and then some part of edge computing. And then there is a kind of, at the edge itself, the feature selection and extraction can happen with the help of time and frequency analysis, FFT, and some kind of wavelet transformation. This is something which we do at the edge computing. For example, in a station, this can monitor up to 30 or 40 kilometer either side. So 80 kilometers, 70 to 80 kilometers. So that edge computing and signal processing is done at the station level, and the data, meaningful data, is sent to the server where we do the machine learning and then give a classification of the kind of alarm. So the problem statement which we got 2 years ago from North Frontier Railway, there are a lot of elephant movement happens and that gets killed due to collision with the train. So they have tried like camera based solution, honeybee system, but all these are basically you need an installation in the field, power supplies in the field, so that's why this could not be successful. However, this AI based DAS optical based system which we have implemented and it is running successfully from last 1 year in NFR. This project, Minister of Railway recently had given a name like Gajraj, where this particular implementation. So the deployment mechanism, if you see, this is, like I said, there is an existing fiber of railway, and then we are using the existing fiber, and in case of all elephant corridor, we are putting a fiber loop for detecting, the elephant movement little early. So the design of, the loop is something which is essential when you want to do little bit early, early detection. Like this system can, the fiber is laid almost 5 to 10 meters away from the track, but the system can detect 25 to 30 meter away from the fiber. So overall, you can say 35 to 40 meter with the existing fiber, it is possible. However, we have to do it little early, so that's why the looping of the fiber is designed. So then this is the implementation. If you see the DAS unit on the left side in the rack, it is installed in the OFC room, and in the next you have two fiber coming. One is from one side of the station and another is another side of the station. So total 80 kilometers we can monitor. The right side there is a station master unit. The alarms is given to the station master, and then also the control station, and then to the loco pilot. Loco pilot right now they have a 4G system somewhere. LT 4G is available, so there we can give them directly. Otherwise, the station master communicates with them through VHF communication. So this is one area where we need to improve the infrastructure of wireless to give alarm directly to the loco pilot. So this kind of alarm, elephant alarm comes to the loco pilot. This is one of the elephant signature. If you see when there is a elephant movement happening on that particular distance, let's say 23 or 24 kilometer away from the station, there is a waterfall movement, and then we are basically monitoring the vibration, audio signal, and then their amplitude, sensitivity, and then we are classifying this as an elephant. So this is one of the dashboard which is given to the control room, where the elephant movement, pole kilometer, where is the elephant movement, date, time, and everything is given, and accordingly the message is passed to the patroller, and then information is basically recorded. So these are some of the case studies which we have done for elephant intrusion only in Lamding division for 60 kilometer, which is commissioned and running from last 1 year. Alipurdwar, Rangia, Tinsukia right now we are doing, and landslide monitoring also we are doing on this technology. This is one of the official use case tweet which the system has saved almost 25 elephants last year. They had given an early detection. This was the official tweet from the GMNFR. The system had given alerts to the loco. The loco they reduced the speed of the train, and then he himself recorded this video. So 25 elephants were crossing, and this was an important savings which the system had done. So likewise, there had been a lot of incidences might have saved but may not be recorded. So this is some of the outcome of the trial last 1 year which we have done in this area. It is able to monitor around 35 kilometers one channel with the underground fiber of 1.2 meter depth, the detection possibility like 25 to 30 meter from fiber. The accuracy is 100% in terms of the true positive rate is 100%. If you see into June and July, there are certain decrease in the accuracy because of there was no power supply available for those time period, longer period. So then, because we were using the existing AC power supply, then it has moved to the railways, DC power supply. So then it started giving a 100% accuracy in terms of the true positive. This is one of the, there are many contributions to this project, starting from North Frontier Railway, the team completely supported for this overall solution. Then Forest Department, Railway Board, RDSO, our team, Bitcom, and especially this award, the PMI Southeast Asia have recognized and given this award to North Frontier Railway for this solution, implementation of the solution. And Minister also had given the name to the solution in NFR as Gajraj. So these are the contribution. There are a lot of things which we have learned from the last 2 years work in NFR. So some of the way forward which we felt should be there going forward to apply, because this technology can be used in many other applications. Like Frosher already they have done work on the rail fracture and some of the other applications. So it is very important to have a trial for more applications in railways, so that we can finalize on some of the RDSO can finalize the specification. That is also important. The designing of the fiber network guidelines has to be there, like 4G LTE network, when it can be implemented. So that is some of the challenges we felt. There are a lot of coordination with the forest and other departments. That also something needs to be looked into. And most importantly, how to basically validate the system, whether your system which we have deployed, it is working fine, is it giving 100% true positive, or there are false alarms. That is the most challenging thing for us. So what we have done is, today railway and forest, they have their patrolling team. So whenever any movement happens, they basically issue a caution order. So we have cross-checked that most of the time the system had given the alarm earlier than them. So that is one of the method. But however, it is not possible to deploy patrollers in the field all the time, right? So there has to be some mechanism to define that how the validation can happen. Maybe some areas we can put cameras. So that needs to be discussed with OEMs, railways, and take a joint call. And most important, second thing part is here is the safety integrity level also slowly may come into this kind of application, that when you are basically giving a solution for saving a wildlife or any like train positioning, also we can give alerts to the LC gate for the public announcement system. So this needs kind of safety integrity level also for the equipment and the software which the system we would be using. So this is all about our solutioning. So any questions, I think we are able to take. Thank you.
Thank you, Mr. Ratan. And yeah, here, first row.
Mr. Sai, like you have a physical deployment of the system in NF Railway, and you also mentioned that Frosher is having an other application where track sensing, rail fracture, etc. can be sensed. No, deployment of this system requires fiber, then some hardware, then power plant, then space. So all these assets have been created on that. Then, I mean, my suggestion is from industry side, if you can allow Frosher to deploy their application part, I mean, industry should come together to help railways create a combined infrastructure so that the multiple applications can be utilized and the harnessing of fiber can be done in a better way.
Absolutely, sir. This is very important question, because when this kind of new technologies come into existence, or we being a R&D design and technology company, it is very important to work in collaboration. Like we also have been working closely in touch with Frosher. Some of the application they are doing, we want that more OEM also should come, and we can have a kind of synergy in between, and then with railways we can definitely do this. I am really very much encouraged about your question, and we want this should happen actually. This should happen, and we are open for it.
Thank you. Any other question, please? Yeah, over there.
Deployed the solution in NFR, like the existing OFC of railways was used as it is, or any modifications were required? Like from the center of the track, the OFC may not be always 20 meters apart, or sometimes there will be track crossing. Sometimes the depth of the fiber keeps varying. So the existing OFC of railways was used as it is, or any modifications were required for deploying the solution?
Okay. So generally, I mean, in this particular implementation, we have used the existing railway fibers, which was almost 15 years old. However, it is recommended to use new fiber to get better sensitivity. To answer your question, in the corridor area we have done some modification where we have make a loop. We have gone little inside the forest with the fiber and then make a loop and come back both side of the track. It's not. It is just to ensure when there is a elephant movement, more elephant movement in that area, so we should be able to detect early. So that was the modification we have done to extend or to predict this little early, but existing fiber only.
Yeah, over there.
My question is actually, what is the redundancy mechanism you have introduced?
Okay, so like in case of optical laser system, if you the redundancy, there is right now no redundancy on the laser part, but we can have one more channel to put the redundancy on the laser. However, on the basically the remote, we call it a remote DAS unit, which is having a laser as well as computing. This is sending data, keeping our data locally as well as sending some process data to the central server. So there are two central servers available. So basically the data is available on the edge as well as the central server, and also two different central servers. So the redundancy on the computing level and storage level is available, whereas the laser level is concerned, right now we have used optimally. So one laser, so one channel used, we can use two channels, then the redundancy can be increased.
Thank you, Mr. Ratan.
Yeah, one more thing I just want to add. If you want to see the system, we have a stall here in Hangar Hall, hall number 1011. You can have a look at it and then we can discuss in details if any questions left. Thank you everyone. Thank you.
Thank you, thank you. So ladies and gentlemen, we had a very fantastic session where we covered from cloud to elephants, very diverse set of technologies, and a peep into the future also, the things, the way of things to come in going forward, the cloud and AI and ML and their applications. So let me thank all the speakers of the session, starting with Mr. Axel, who started on cloud, infrastructure on cloud, and then to Mr. Navneet Kaushik and Naveen Pandey, who gave a glimpse of usage of packet 44 in specific application for the PSD, and then Sebastian, who talked about intelligent use of data platform for insights and also for their Connect system. The fourth presentation was from Hitachi. It covered a lot of topics. Their new Wayside system platform. In fact, I had a lot of questions, but it'll take a lot of time, so I'll connect with him afterwards. And the fifth one was on network components from Mr. Digvijay. And lastly, from Ratan, talking about intrusion detection system. So a lot of topics covered. Very nice presentations, and we could complete the session on time despite starting a little bit late. So thank you to all the presenters. Thank you so much, and I will request the chair, Mr. Franz, to say a concluding.
Thank you very much, Achilles. Is this working? Yes, it is working. Thank you very much, Achilles, because I think we did better than expected. We covered 10 minutes on our delay, which means you have 10 minutes more for your lunch. I would thank the audience very much for their attentive questions, attention to the speakers. I think they have said the speakers deserve it, and they made up a good show. I thank you everyone, and I will hand back control to the real control of this system.
Sakshi.
Sakshi, please. Control is back to you. We hand up.
Thank you.
Thank you, gentlemen. Yes, indeed, I just heard our session chair, and along with that, of course, our moderator also mentioning that they were able to wrap the session on time despite the fact we started a little bit late today. It's commendable. at the end of the day. Ladies and gentlemen, can we have a huge round of applause for our entire panelists over here, for our session chair, Mr. Franz Hagen, and session moderator, Mr. Akhilesh Yadav. On that note, thank you so much, gentlemen, for having been a part of this entire discussion. Thank you very much.
Thank you.
And to our entire audience members, I indeed would now be saying that it's time we part ways for a while for lunch. Before that, I have a couple of really important announcements. I'm going to be requesting you to kindly stay over here for just 1 minute. There are a few vehicle numbers that I'm going to be announcing which are not parked. I'm going to be requesting the gentlemen who own the vehicles to either just park those vehicles themselves or have their drivers park it. This is a white Kia 7654, a Brezza 5198, white BMW 0444. Whoever these vehicles belong to, humble request, kindly park them in the right place. And more importantly, gentlemen, we shall be meeting back in the room over here at 1:30 p.m. I'm going to be requesting you all to kindly make it back over here in the ballroom at 1:30 p.m. For now, have a great lunch. I'll see you soon after. Thank you. Thank you, gentlemen. Please enjoy your lunch. Thank you. Good afternoon, ladies and gentlemen. For those who have just joined us over here, welcome back into the auditorium. And for those who have been waiting for the last 15-20 minutes, I thank you for your patience and for making it on time. We are now indeed going to start with the sessions. The rest of the audience can keep joining in as and when they are done with their lunch or wish to. But since a lot of you have already assembled inside the hall, we do respect your time and patience. So we're going to get started with the next session of the day. Before I do that, ladies and gentlemen, I would just like to make one announcement that I did speak about earlier also, which is that tomorrow, each one of you who is going to be visiting the technical visit or shall rather be a part of the technical visit, you have to be there at the Railway Officers Club, State Entry Road 9. Okay, you got to be there at the Railway Officers Club, State Entry Road at 9 a.m. is what I meant. 9:15 is when the buses will start taking off. So please make sure that you have assembled by 9 o'clock. In case you do not make it by 9 or 9:05 a.m., I am sorry, my apologies in advance, because the buses will not be waiting for you. So once again, I say that you have got to assemble at...
In railways are not immediate. It is possible that people, there's digitization in railways is very difficult task, it's not so easy. And this session, we have 6 speakers, and the topics covered are very versatile. A wide spectrum of topics are covered in this. There's one topic is experience and outlook with secure connectivity in rail. Similarly, on the other side, there's a discussion on quantum compute, quantum secure networks, which is another complex topic. At the same time, 5G mobile network, though we are talking in railways today of LTE, but the future is 5G, so the relevance and then how can we bring this new technology to useful and make it useful to railways. Then innovation in digital technology for safety enhancement, at the same time cyber security and all those things will come into picture. So yesterday's session, there was a question in fact raised by one of the delegate that you are installing so many devices along the track, how we make them safe, tamper proof. This topic is also equally relevant. So with this little introduction about this session, I will not wait for moderator to join, and I invite Mr. Christoph Jacob from Siemens Mobility to deliver his topic. Thank you.
Thank you very much, ladies and gentlemen. To warm up now after the lunch, I do want to start with a question to the audience. And please, please raise your hand. Everyone, please raise your hand who has never heard of something that is called Stuxnet. Who has never heard of Stuxnet? So I suppose that there's many people that have heard of Stuxnet, but for all of them that have never heard of Stuxnet, Stuxnet was the first security exploit that was targeted towards an operational technology network. And it's about 10 to 15 years ago when a very supposedly government-driven attack on PLC-based systems has completely closed them down. And this was just one example of all the threats that we are facing now with networks and the connectivity, the increased connectivity that we do see in many, many industries. It's not only in rail. However, many or most of these threats are still targeted to clearly IT systems, and so far not that much on our operational technology systems, but one trend is very crystal clear to see. It's getting more and more. The more IT systems we do deploy, the more complex they grow, the more complex the threats grow with the ones that are attacking these systems. And to show one more slide on that, it's that these threats are also very valid for the rail industry. And this slide shows a couple of examples, and many of these examples, or let's say all of these examples, are not showing incidents that did imply safety critical incidents. It was all only on the availability. Some of the incidents did target customer data, ridership data, but most of these did in the end result into a disruptive operation. And this disruptive operation can take not only hours, it can also take days. So this is in the end underlying that managing the cybersecurity of connectivity and the cybersecurity of our rail infrastructure is one of the major targets that we need to ensure, while at the same time we want to leverage efficiencies with all the digitalization efforts that we're driving. Another topic that we do see in the rail arena, but also on the operational technology networks, is that there is a paradigm shift visible. We have all started, looking back a couple of years, that everything was purely hardware driven. Looking at the relay interlockings, there was no software at all, so the complete functionality was only driven by hardware or designed by hardware. And looking at today, the trend is clearly moving towards the increased importance of software. So you do see that more and more functionality in everything that we do is driven by software. And to give you a couple of examples, maybe from maybe the private life, if you look at a Tesla car, you actually need to pay for additional functionality. And the functionality is already built in the car from the very beginning you actually receive it. It's just the click of a button and releasing the software function that you can actually use it. A completely different example, looking at radios. In the past, radios did always have a fixed frequency, did have a fixed functionality, and nowadays we're looking at software-defined radios where we very easily can adjust the functionality of a radio to the actual networks, the surroundings, so it's very flexible. So in the end, the value of our operational technology is more and more defined by the software we're putting on it. And as such, also the criticality of managing the cybersecurity in the connectivity of the overall environment is a crucial element to ensure the safety and the availability of the systems. So looking at why do we actually connect more and more, and what's the reason for us wanting to get more and more data? One of these reasons is, let's start with the middle one here, is the remote work. And remote work is not about having a fancy dashboard sitting somewhere and someone looks at green, yellow, or red dotted lights. It's really about getting the maintainers a help in the hand, that they know not only that something is wrong, but they exactly know where is it, they exactly know what is it about, which tools they need to take with them, and also where to go. Especially looking at a distributed wayside architecture, it is crucial that maintainers do not drive to the wrong location, and do not see when they're on a location that they did pick the wrong material in the car. So this is the remote area where it's crucial to have data and the right apps to really see what's necessary for the operation and rectifying errors. One other element that is crucial when it comes to secure connectivity is providing updates. As I just said, most of our systems are more and more defined by software functionality. And we all know with cell phones, with our computers at home, we do require updates, and especially most of these updates are security updates. So we have to find a way, and we need to implement means of updating these systems very easily and remotely with providing updates, because no one wants to go to a signal location and updating each and every component one after the other. It needs to happen by a click of a button. So this is a couple of values that secure connectivity in rail can offer to operators. one other aspect to look at when it comes to updating the systems is when you look at the classic lifetime of a system, you see that at the very beginning, the level of obsolescence, it starts at 0, but honestly also for looking at rail equipment, with normally having started R&D efforts already 2 years, 3 years, or maybe even more so before it's being deployed. Sometimes obsolescence already has started the moment when you click the button on the commissioning, that it's putting the system on operation. And then the system grows older and over again. And one way to mitigate that is to, one after another, migrate these systems always in separate passes to a new level of security, new level of functionality, and this way managing the obsolescence over years and enabling the systems to be at a, I would say, up-to-date level for a much, much longer period of time. Because we all know the railway equipment, and I'm sure it's very similar in India, that the average age of the equipment is quite high. And when we want to, at the same time, increase digitalization and get all the benefits out of it, we cannot always wait for this equipment to be fully replaced, because that's a task that is close to unmanageable. Now looking at an example architecture of even a modern interlocking here, so you do see object controllers. It is an architecture that you will be seeing in many, many modern interlockings. Let's see what kind of elements we put in addition to the current functionality to secure, or let's say to ensure the cybersecurity. On the diagnostics part, we do enable the system to push data out to other systems, out to cloud-based systems or on-premise solutions, whatever you actually choose. And the way we're doing that is we're ensuring that this data flow is a one-directional, unidirectional data flow, that there's absolutely no way that anyone can go into the safe interlocking system from the outside. There's only one data flow to the diagnostic system or to the data cloud. The next thing is we want to ensure that the overall network, the operational technology network, is free from any harms of, let's say, from the inside, that no one is plugging in an unsafe, unsecure computer. And this way is monitored by a so-called intrusion detection system. And for this one, there will be implemented a couple of sensors that do measure, or let's say that do hear everything that happens on the network, and then find out if whatever happens on the network is something that maybe should not be happening. If there is something that is unknown, then this system is sending an alarm. And the third one here is a juridical recorder. And the idea of the juridical recorder is to record everything that is happening on the network. Every operation a user is doing on the network is being recorded there. And the reason why it is considered being a cybersecure element is that everything that's happening on that recorder is being stored with cryptographic elements in a way to ensure that whenever there is a legal incident, any incident, and then the Attorney General wants to have a look at the data, that this person can really rely on the data being non-tampered with, that what has been recorded and what has been sent on his desk is really the same as what has happened. That's the juridical recorder. Okay. One example on the connectivity solution. That's how we do it in our own interlockings. That's what we call call-shared connect. It's the way we collect the data with the data collector. And what I just said earlier about the unidirectional gateway, it's called the DCU, the digital the data collector unit. It's a one-directional gateway, ensuring that nothing from the cloud or any other network segmentation that is above is being introduced into the system, but you do get all the data out. The system is designed in a way that it not necessarily needs to be in a cloud. It's also possible to have it as an on-premise-based solution for everyone that is feeling uncomfortable with having data placed somewhere else. However, the system is also open, it is modular, which means that this system, or let's say these components like the DCU, can be used by anyone. Yeah? And we have, I think it's in the Hall C, where F-Tronics has displayed also that unit in one of their use cases. So it's just that one component and a totally different system, which is not from us. So it's very scalable, modular, and based on commercial off-the-shelf hardware. Other use cases to look at, and I just have a few to see, to give you a look at that. These use cases are very different. Starting on the left-hand side, it's just from very classic diagnostic perspective. Going more to the right-hand side, control card aero, looking at data and measuring based on the data on the ridership and making assumptions on what kind of ridership to be expected in the upcoming days. Maybe if there is a big sports event, to make assumptions that in the nature of being a sports event, that the need for public transport is increasing. The ARC analyzer for the overhead system with measuring, getting data out of the substations to see if there is additional ARCs at very specific locations, so that someone needs to do something in the maintenance. And IRSE is also the diagnostic system for the mass transit metro solutions. And these deployments, it's not just examples or view into in the future. These examples are already deployed globally. As you see, there's many countries already using cyber-secure connected products. So it's already happening today. And even India, we also have the first deployments here. And to wrap up, for me, there's three things that I do see that are happening in the future. The first thing is the drive for standardization. And the examples I've depicted here is ETCS, but it's also ULINX. All these standards are based on standardized interfaces. And these standardized interfaces also require cybersecurity. With the ULINX, it's also already integrated in the specification that all communication needs to be secure. And with these standardized interfaces, it's a lot easier to also provide open APIs, which in the end means that this data is opening up for others, that others can also make use of this data, and not only the initial suppliers, but also the third parties. And it's in the end, with managing that, it's about building the ecosystem around that. The second one is managing the legacy system with migrating the legacy system, so it is possible to also systems of today, even relay interlockings, to deploy those ones, or to add the cyber-secure connectivity on top of these interlockings and getting data out of these interlockings for making a better maintenance, for predicting errors before they actually happen. That's also possible with the legacy infrastructure. In the end, then also prolonging the lifetime. And the third is then the lifetime updates. That's then more targeted not towards the legacy systems, but towards the new systems that security patches are being provided on a regular basis. Remote update is possible, but also looking into the future that new functionality can be added just with software updates. This is where I do see the three major pillars where cyber-secure connectivity can bring us a real benefit to operators, to ridership, and also to our suppliers. Thank you very much. Yeah. Okay. Okay. Perfect. Okay. And just if you can play the video for the India use case, please.
digital world, data is a new currency in the bank and this data has to be secure. Railway signaling is safety case certified systems and there is a thin lining between the real world and the virtual systems when IoT data is exposed. The critical signaling asserts in the critical network has to be secured and there should be additional locks. So this virtual lock is a cyber security. Data capture unit fulfills the security level 3 according to IEC 62443-4-2.
Today, electronics have given lot of data loggers, health monitoring units to lot of signaling assets. These health monitoring units, also called as Internet of Things, are located in all the stations across the country. This solution is also provided to dedicated freight corridors. So in one of these pilots, we partnered with Siemens, the multinational company, and we, Electronics and Siemens, jointly collaborating to provide a cyber-secured health monitoring systems. In this application, we have used Siemens data capture unit to provide this operational data, which is residing in the OCC of dedicated freight corridor, and this data is being given to all the users with a mobile app called Nirdesh. This joint collaboration will help railway users to gain access to all the data being captured by these health monitoring units.
Thank you very much.
Thank you. Christophe. Good afternoon, everybody. Apologies if I was a bit late. Stay on the stage. Yep. Christophe is part of Siemens. I am the CEO of Siemens Mobility Asia Pacific. We are going to open the session for a quick question to the forum. Thanks for the very comprehensive presentation. Just a quick input at my end. Digitalization is enabling the mobility business. In fact, first of all, in our core activity, which is to make sure the operations are optimized, for sure in a safe way, to make sure the maintenance activity is optimized, as well as the life cycle. And definitely we have seen in the past, let's say, decade, an area of business which is coming from, let's say, the threat that our system can suffer from, which is the cyber security, and we see new also possibilities which are not in the realm of cyber security, but in the realm of sustainability from the digitalization. So let's open for maximum 2 questions from the forum to Christophe. The first one is always the most difficult, so we start by the second one. Then, Christophe, a question at my end. You have spoken about a product named DCU, Data Capture Unit, which is definitely a Siemens product. What is, let's say, this product providing in terms of interface with any other system, not necessarily provided by Siemens Mobility, but typically for other OEM? So is it possible to use this DCU in other installation than Siemens' own installation?
Yes, so the DCU as a product is an open product, but open in the way for other interfaces. And the product is not only used in the rail industry, it's also used in the, let's say, classic industrial business. So we've already implemented many different, let's say, network protocols that it is capable of being an active part of the overall network and then pushing the data out. It's OPC-UA is one of the examples, one of the, let's say, the mostly known, but also the other protocols like Profinet, Profibus. Basically everything is possible to push it out, and it does not need to be a Siemens system. It can be anything.
Good, thanks. If no question, we're going to go to the next session with building quantum secure networks for safer India. Dilip, floor is yours.
Hi everyone, good afternoon. So basically, I am representing Kyonu Labs. So we actually are a startup, deep tech startup, founded in IIT Madras a few years back, and we actually were formed because China actually announced that they have created a quantum secure network for around 2,000 kilometers. And at that point of time, there were lots of discussions about quantum computers coming up, and they're actually creating havoc for the system and the digital infrastructure. That's when we started. So we actually spent around 3 years in IIT Madras doing proof of science. And then as we speak, I think we have a portfolio of products, and we're happy to announce that we actually can make India quantum safe. So I'll talk about what is changing, let's say, in the landscape of cybersecurity, why it is changing, and then how do we address that. So if we look at it, right, currently when we talk about cybersecurity, right, we talk about, let's say, malware, we talk about phishing, we talk about somebody stealing your password and getting access to your server, and so on, right? So everybody assumes that, let's say, attackers would try to somehow steal information and try to come to a server and then steal data from there. So if you look at it, most of the cybersecurity solutions are actually trying to address that. In fact, 99.9% of the focus of let's say security officers or CISOs also is to basically make sure that this is taken care of. So there basically there is a fundamental assumption, right? There is a fundamental assumption. So the assumption is that if there is encrypted data flowing on the network, that is safe. So it's an assumption, right? So let's say we say, okay, we are using encryption, so whatever data is going to the network is safe. So now we need to make sure that we won't allow anybody to access my service. That is one thing. The second thing is that if let's say people have secured data repository, right? So let's say they have encrypted the data using whatever AES or whatever you say, right? Again, it is assumed it is safe. So these are the basic two assumptions in which we have been living, let's say, for the last 30, 40 years, right? But that is fundamentally changing, actually. It's fundamentally changing. So what is happening is that the entire public-private key infrastructure is actually already vulnerable. So basically, as we speak today, the data which is going on the network, even if it is encrypted network, is no longer safe. So whatever you use, right, you use IRSE 2048 or you use AES 256 or use the latest generations VPN or any sort of encryption, right? The data actually is now unsafe. Why it is unsafe? Because of two things. One, let's say the original algorithms for cybersecurity or encryption decryption assumed, let's say, certain amount of computational power increase. So let's say if you look at, let's say, last 10 years, right? So we probably have increased, let's say, the frequency of the process to around 3-4 gigahertz. We basically have 1632 cores and so on, right? So if you look at it at any point of time, the number of parallel shift this the machine language to quantum computers. So together with just with quantum computers and even more with AI and quantum computers, the entire traffic that is flowing on the network is now unsafe. So as we speak today, all the deployed solutions are actually unsafe. They are not safe. today somebody can actually just store the data. In fact, now hacking also has started. So that is a problem which we are trying to solve at QNU Labs, and fundamentally we have let's say a software security, let's say a security solution which actually addresses the problem, all of these problems. So recently, let's say there was a I think 3 months back, 3 months back, there was a आदि में कहावत है कि लोहा ही लोहे को काटता है, right? Iron basically cuts iron, right? So we have used the principles or the technology of quantum physics itself to create a solution which actually covers the entire paradigm of security. So for example, if you look at quantum computers, they are able to trace or track IRSE or equivalent protocols which actually generate symmetry keys. Now we don't use that, we use, let's say, quantum physics based solutions. So eventually where there is no algorithm as such, it is actually generated in quantum physics without any algorithm, hence nobody can predict it. So that is so we have no solution for data in transit and also solution for data at rest. So I've tried to let's say of course with my limited understanding of railways, right, I've tried to put some of those areas where, let's say, probably vulnerability is already creeping in, right? So we all know that railways actually is trying to become more and more connected. We have signaling systems which are controlled remotely. We have interlocks which again are controlled remotely, and in fact, let's say a very simple example, right? Suppose there is a locomotive tracking happening on, right? So we use the live location of a locomotive, and based on that, we, let's say, plan some interlocks, right? And if there is a hack happening, if something is hacked there, the location itself might be fault. We probably might switch the interlock somewhere else, and a disaster can happen. So if you forget about the reservation, let's say the train reservation part, right? If you look at the operations of the signal and traffic control itself, as we speak, entire digital infrastructure used by Indian Railways is actually coming into a zone where it is time to rethink, a time to give a good thought as to how do we make sure that it is not compromised in the near future. So try to just build a big picture, because I think the focus is on how do we create a quantum secure network for India. So basically, as I was telling earlier, so we actually propose to do it in two steps. The first thing is to secure the backbone communication itself. So for the backbone communication, we actually propose a combination of terrestrial quantum key distribution system and satellite-based quantum key distribution system. So with this, we can actually cover the entire length and breadth of India and even internationally as well, and ensure that quantum computers will not be able to break the encryption today or tomorrow. So this is basically one set of solution, but physics, that is one, and then physics, we actually use a combination of quantum physics and let's say a different algorithm which basically is called post-quantum cryptography. I use them together in a hybrid mode to secure the entire communication end-to-end. So I think I'll pause here. So because I think the idea was to just bring out this sensitivity that yes, cybersecurity is being threatened. The entire, let's say, assumption that data is safe and it can be broken only if somebody creeps into it is no longer valid. Even if it is just going on the network, somebody can just tap it on the physical line and still hack it. So happy to take any questions. Okay, thank you so much.
Yeah. Micro?
Yes, yes.
Yeah.
Broken with quantum computing. So wanted to, because we have to show to people that this has happened, So can you be part of which is called a red team, where we ask a bank or an organization and show them that yes, your current PKI implementation which you have done can be broken, can show yes, your current is broken, see, and now you have to adopt this one, new one.
Right. So basically, if you look at it, right. So first of all, if a demo can be shown, yes, it can be shown, but it will not be very generic, because if you look at it, so typically these breaches happen because of certain moles or certain scenarios. So for example, let's say if I am using IRSE 2048, which most of the banks use, right. I have a demo wherein I can tweak the random stream coming from the system, and in 2 seconds I can break it, right? So because end of the day, such incident has already happened. So let's say, and this is a typical scenario for India at least, right? So for example, all the systems that we use are actually foreign made. So now you do not know where the mole is and when it will get triggered. So in such scenarios, it is important to basically switch from a system generated, let's say, random stream to a third party remote random, which is in your control. So but we can demonstrate it definitely.
And implementation happens like in a normal PKI deployment, you have a route and you deploy on a route and then goes down, the similar as your diagram was showing.
Yeah, so basically we can help upgrade the PKI infrastructure, which basically would ensure that it will not be broken for the next at least 10 years from quantum computers. So we can do that upgrade.
And your licensing and your commercialization has started?
Yes.
Or this technology?
No, we have started commercialization.
Commercialization. Okay. Thank you very much. Nice product. Excellent.
Thank you. Any other questions? Yes, please.
Can you please explain what is post-quantum cryptography? Like, will the key be generated beforehand and it will be stored, or
no? So typically in the quantum computing era nowadays, we basically talk about classical algorithms, which basically were meant for let's say classical computers as they are today. So when you look at post-quantum cryptography, these are newer algorithms which are meant for situations when the quantum computers are there. So it's a different algorithm.
The algorithm itself is different.
Yes.
Okay.
Yes, please. Yeah.
So what attribute of blockchain is being used here?
No, it is not, we are using the blockchain, sir. So basically, if you look at it, right, for example, today everybody says that blockchain is safe, right? But if you look at it, blockchain basically again uses, let's say, a PKI infrastructure to connect to the other nodes and then sends data on that. Now that particular duration of 30 minutes, it is vulnerable. So basically, so we basically, when we say that we say blockchain, we basically mean that we would be able to secure that link as well.
Thank you.
Thank you, sir. Any other questions?
Any other question to Dilip?
Thank you so much.
Dilip, thanks a lot. Anyway, you can see we are moving from solution to solution. Here it was the case of the network, and now we are going with Siddhartha about remote diagnostic and predictive maintenance. Again, another domain of value add for our customers. So Siddhartha.
Respected officers, sir, ma'am, and dear audience, a very good afternoon and namaste. This is Siddharth Singh from Energy 7. And I will be discussing on remote diagnostic predictive maintenance system as per industry 4.0 in the next 15 minutes. So starting with the evolution of the industry, as we see, the initially started with the mechanical, then it shifted gradually to the electrical energy, and then there was a phase which we call it as SCADA, where things using microcontroller and processors, we automated the system,
And then SCADA with internet is IoT. So with the internet, we will be able to reaching the devices in bidirectional way. So we can give a command. At the same time, we can equally read the data also. So this is how the industry has evolved. Now coming to the main agenda, that why predictive maintenance is needed. So as if we see these graphs, these are signatures of a different point machine installed at a station. So we can see the bottom one, which has an orange line. It is an ideal signature for a point machine. Then we have then blue lines which have a small deviation, and then the pink line where there is a deviation is much. So as of now, when we do a time-based maintenance, we are investing our time and energy on all these 3 point machine, irrespective of their actual conditions. So with the help of the artificial intelligence and machine learning, system will help us to identify that out of these n point machines, which are we need for attention and we do need to maintain before time. So as we see in this diagram, if we see each dots as a signaling asset, as of now for a station, if we are maintaining, let's say 200 assets or 300 assets time based, now with the predictive maintenance system, in the next figure we see these red dots are the gears which need attentions. So as of now, the inventory which was earlier 200 or maybe 250 now has come down to 10 or 15 per stations. So it will save our energy and manpower. So coming to the next slide, I will be discussing how these things are achieved. The basic journey of predictive maintenance, as you start with collecting of the data and then computation. So how these data are collected over railway stations or any other scenario. So it consists of the basic node which we call as the things or device or atomic node. So these are nothing but are the sensors like voltage sensor, current sensors and vibration sensors equipped by data equitization unit, which collects the data from these sensors and sent to a central gateway which may be residing at a relay room or station premises, and from there using a STM backbone or 4G, these data are sent to the cloud. Over the cloud we can see there is a dashboard which displays all the data in a user interface manner, and at the same time that using artificial intelligence and machine learning we drive the computational part. Also in the picture we see these are the location boxes installed at the railway premises where we install these things or device which collects the data, and from there it sends to the station using LoRa network, ZigBee or maybe 2-conductor wired media. So this is how we collect the data. Now coming to the asset-wise description, that how we solve the purpose and use cases. So this is the scenario that how we detect the cable fault in a railway environment. So there are 2 ways. One is the existing ELD, which we extend to the remote diagnostic system. In addition to this, what we do, that we measure the voltage of bus bar in context to the earth. For example, if we are considering a bus bar supply of 24 volt positive, which is extending to the TPR in the field, so we will be measuring a positive bus with the earth and negative supply with the earth. If your cable is healthy, you will find equal supply on each of them, which you see in the lower graph. It is a 110 supply, and since both the conductors are healthy, you will be seeing 57 or 60 voltage, which is the half of the full range. So if at each of the conductor we are expecting half voltage of the full range, it means our conductor are healthy. At the same time, if any of the conductor which is going in the earth condition, it will go towards the ceiling, and the healthy one will go towards the upper limit. So you can see in the upper graph, it is a 24 volt supply. The full range may be 30 volt. So you can see the positive supply conductor is healthy. You can see the voltage is 19.55, and the one conductor which is going towards the earth, we can see 10 volt. So this is the detection in the cable that which is faulty. So I conclude we do it with a 2-way. One is the existing ELD, we extend to the RDPMS, and another is the voltage approach. Now if we have detected that okay 24 volt positive have earth fault symptoms, now where we should attend this? So what we do, that we match this with the function operated at the same time. For example, let's say a track 2 TPR tail end cable is the gear which is causing the earth fault. So for example, when a train will be moving through track 2, and when the track 2 is down at for particular 10 second for those particular 10 seconds the earth fault will go out. So we reconcile these change in state of the earth fault and the function which is operating in the yard, and we can conclude that which function is it, track, signal or point machine, which is triggering this earth fault. As we can see in the lower UI that there was an earth fault event in 110 volt AC, and upon checking it with the function operated, we conclude that there are 3 signals which are suspected cause for this earth fault, like S46, S12 and S2. So this is how we are predicting the cable fault in our railway environment. Now moving to our next slide, this is the point machine. So basically in point machine we are capturing the voltage and current in the field at the tail end cable which is going to the machine. So once we have the data of the current, we also generate the signature of the point machine operated, and also we have the time of operation. So generally if we have a time, for example, if a point machine is operating and getting set in 2.4 seconds, after some time if it takes 2.8 seconds or 2.9 seconds, still it is not failed, but something has caused in change of its property, so as taking more time. So it will inform our user in prior that the condition has changed and you need to attend it for so and so reason. Now in the bottom we are seeing 4 graphs. So when we see the first graph, it appears and ideally, because once the point machine is in static condition and once it is powered, you can see the rise in the current because it changes the state from static to kinetic. Now once the point machine is the running condition, then we can see the setting current and then finally turns off. In the second graph, what we see, one of the point machine after 1 second of the trajectory, the current is rising again, because somewhere in its transition it is getting the friction, maybe from the sleeper or due to the adjustment, it may causing the rise in current again before setting the current. In another last figure you can see, once the current is rising, it is rising again at mid of its trajectory. But this is normal because these 2 signatures are obtained from IRSE point machine. The last one is of thick wave point machine. The way thick wave point machine operates, it's different the way IRSE operates, because in thick wave the first rail first moves and after some time the second rail moves. So the second rise in the current is due to the second rail moving after the first has set. But in IRSE both end moves simultaneously, so you don't see those graphs for the IRSE. So a abnormal graph which we see in the IRSE point machine may appear a normal in thick wave point machine. So machine learning very easily detects it, that what should be the ideal signature for a point machine and in which conditions the user should be informed and in what scenario. In the upper graph you can see the cluster classification, where we see how point machine are classified into different clusters depending upon its deficiency. So for example, some point machine may have overwhelming issue, some point machine have adjustment issue, some point machine may belong to some different deficiency set. So our artificial intelligence classifies them into different clusters, and each cluster nominate for some set of deficiency. So this was the point machine. Now coming to the track, these are the parameters which we detect from the field, like feed in current, delay in current, leakage, TPR, charger. So these data once collected is passed through LSTM model in anomaly detection, and as an output we get 2 things. One is the probability of the failure, that what are the chances these gears will fail in the coming time, and at the same time it gives the cluster classification. For example, maybe some track may be deficient of shorting may be due to the glued, or maybe from the sleepers, or maybe some choke problem. So once we have a data set and once it is parsed through the ML models, we have the output of classification. At the same time we have the probability also. Now next is the signal current. Signal we use the current at the relay room and voltage at the field. Current can also be captured at the field also. Once we have that data, we can detect the failure reason also. For example, generally our LED are of 15 watt, so most probably the current signal current is LED is drawing maybe some around 110 or 115 milliampere. But over the time this current varies. It may go below 1.5 or go more than 150. So in those conditions, system will identify you the cause of the failure, and also it will help us to identify that where should we attend them. We should attend them in the field, or we should attend them in the relay room. So once we see the graph, there was a case in some of the stations where one of the signal has failed. So when we tried to detect those failure, backtracking it, earlier we were not able to resolve it with the simple LSTM model. So what we did, that we generated a trend and a seasonal trend for those signal LEDs. With those, then we able to determine that what was the cause of the failure, and we logged it with some cluster classification, so that if the similar pattern generates in the future, we can help the railway to identify in priority in before that this is the cause and these are the signals which need to be attended. These are the axle counters and UFSVI channel voltage which we read. These are the RX1, RX2, TX1, TX2 channel voltage. So any deviation in these channels may help us to identify with having time, and we can prevent these failures. And these are the typical output which our machine shares to any division. So at the top you can see that it is the count of the asset which informs to the railway. For example, 15 asset focus for next few days. So it is informing, it is the report for a division level. So it informs that which are the gears, what is the number of the count each station wise, and then detail of those assets which are logged for maintenance purpose. So for example, as we see 02 track, system informs that currently it has been logged for the glued. Recently there has been 2 threshold violations for this track. Threshold violations means RDSO has prescribed that okay, this track voltage range should be 2.5, not more than 4.2, leakage should be this range. So those alerts which are triggered against some threshold are under the category of threshold variations. The another one is model detection, like recently, like it says one time AI anomaly detection for the glued. So it will help you to determine and understand for a pattern of a track that how many times and in what conditions it has violated threshold, under which models of AI it has been observed, what were the probability of failures of these gears in the past 4 weeks, and most of the common symptoms in these tracks is so and so. It may be shorting, it may be the charger issue and all. So this is the report which we share weekly wise to a division to help them save their time and spend more than on the deficient gear rather than the whole inventory. And then a report of probability of failure of each asset is also shared along with these detailed reports. And these are the upcoming developments which we are undergoing in existing to the one we have achieved already. One is the correspondence test for the signal. There are some cases which we have observed that there are chances that by mistake if some wire of RG LED people may connect to DG. So to avoid those cases, or there has been some cases in some zonal railways where the LED was not glowing but still the ECR has picked up. It was so because there was some cable fault issue and the current driven was 650 milliampere. So due to the earth, since the current was 650, ECR was picked up and even the LED was not glowing in the field. So we will be using a lux sensor at each of the LED signals, and which will identify that which signal aspect is glowing and it with what intensity. So this way we can ensure our LED and correspondence. Also with the point machine, we are adding angular and linear displacement sensor, which in Western Railway recently sir has guided, where we in addition to the vibration, we will be able to declare that what is the displacement when a point has set in the close end and what is the displacement when the point is opened in the other end. So with that we could able to get the displacement also, and physically we could validate the condition of the point which is in normal and or in reverse condition. So the idea is that what is happening at relay room, we are physically proving at the outdoor also, and if there is a correspondence mismatch, we can raise a bit is equal to 1, which could inform to a railway and local safety officer for the corrective measures. So you can have a question, sir.
I think we have implemented this system somewhere in some station. Do we have the realistic data analysis as to how it has performed and how it has been useful?
Yes, sir. There is a dashboard in our system which shows you the consolidated report that these are the count of the asset which we have covered. These are the threshold alerts. These
I
are
just
the
wanted to know if the data is available off the hand.
as of now, sir.
Yeah, yeah.
For
Or
example,
any
sir, you can say Atul station in Western Railway. So there we have covered 31 tracks, 12 point machine and some 15 signals. So if we talk about the last month, there was an, I think 14 alerts of the threshold variations, and there were 7 of machine learning models, out of which 3 were identified. For example, one track 160T which has failed due to the glued problem and which was identified in prior to this.
Another, I get your point. My another question is very pertinent to the availability factor, that is MTBF. Every manufacturer, every equipment is defined or manufactured with respect to the MTBF to be achieved.
Sure.
So can we correlate that MTBF with the failure of the equipment that we have got, irrespective of the installation part? I'm only talking about the equipment part. And can we segregate equipment part separately and installation part separately, and then re-evaluate whether the equipments are doing appropriately or not, and whether the installation has been done properly or not?
So I correct your question, sir. You mean to ask that if the alert is generated, it is generated due to the our...
No, it should be correlated with the MTBF of the equipment so that we can match whether the equipment is manufactured to that level. And second part would be, other than the equipment, there is a maintenance activity.
Sir.
Whether the installation and maintenance is being done properly, that's correlation. So that we have the proper RAMs validation.
So if you see a journey of installation of any system, sir, we go through 3 phases. First is the installation part. Once the system is installed, we connect with the railway for the validation. Like each of the gear, example, something went wrong if the installation is being done in a wrong way. For example, if a track is wrongly connected, or if a sensor is not properly calibrated and it's been given the commission note. So there is a 3-process: validation, calibration and joint calibration. So before handing over any of our stations, we do joint validation with railway, where we physically drop a track, we physically operate and signal, and we physically operate a point machine and see that correspondence with the our system, and at the same time a joint calibration. For example, what readings...
And I'm thanking to you for your system installation. I'm talking about the overall signaling system. We have RAMs parameters for performance. Failures are the one of the critical things in train operation.
Sir.
We want to reduce the failure by providing these systems.
Sir.
We want to also reduce the maintenance efforts also.
Sir.
So these are the 2 things to be addressed, and for that the parameter is MTBF and MTTR.
Sir.
So please try to correlate those parameters in future in your installation, whether we are able to achieve and reduce that. And if we are able to reduce substantially, that is what is the output of the system.
Thank you, Siddhartha. I think the point is clear to have a correlation of the MTBF, MTTR with your data. Any other questions from the forum? We will only take one more question because we have to go to our next.
So through RDBMS, now you told all the parameters can be able to measure. Can we measure that the retentivity and that the battery voltages and that is healthiness of the battery?
So 110 volt battery?
Yes, sir.
We are already doing, sir. In all of the RDPM installation, you see there is a module for IPS battery bank where we measure the voltage of individual cell of 55 and gives the alarm if the voltage is, each cell voltage is going below 1.5, sir.
But it is existing, and can we measure that individual current of that battery, sir? Because already that Electronics achieved, there is a point health monitoring unit and battery health monitoring. But I'm especially asking only that individual voltage only we are measuring.
Sir, anyway, we are measuring the track current, so it is very much possible that we could measure the individual battery current also. But I think it will be a problem with the economics, and it will get the system more complex, because if we spend more on getting the 55 cell batteries, so each of the cell we have to fix the clamp sensors, and even the inventory economics cost of that particular station will go high. So the ultimate idea is that we should ensure that our end voltage and each cell is working fine, so that we try to do it the voltage. Possibility is always there, sir, but the only thing constraint is the economics and the complexity that we want to offer for a station, sir.
Yes. And then finally one more, sir. Sir, actually, nowadays, through RDBMS, we are measuring all the parameters.
Sure.
But I have one humble request. Is there any possibility to measure that opening of that, that tongue? Because we are not, all we are checking, but can we measure, actually this is a physical verification only. Is it possible
Yes,
to measure?
sir. The last slide which I was discussing, that the undergoing development which we are doing is for the displacement at the opening and the closing of the point machine, sir.
And then that the TWS also, that heel, the joint opening, that is, JOH is also very mandatory.
Yes, sir.
So is it possible?
Yes, sir. Displacement can always be possible, and we will be trying it with currently connecting with the P bracket.
Okay.
So if we will install the sensor with the P bracket, and we will be detecting the displacement at the time of opening and closing, and it will help you to get the better maintenance with those data, sir.
Okay, thank you, sir.
Good. Thank you, sir.
Thank you,
Thank you.
Thank you, Siddhartha. I think we have to go to the next session about the 5G mobile network for safety and the next generation of control system with Rajesh.
Thank you very much. Namaste, namaskar to everybody. With this, please consider all protocols as observed. I'm very happy today to share my views on setting up of mobile communication network at Indian Railways. This is going to be one of the largest networks being set up and would have critical applications to deal with. But before I get into or delve into the technology pieces, I thought let me share the landscape, especially because it's an international conference and we have many delegates from overseas. So in the landscape, let me first start with India. We are the 5th largest economy today, very quickly moving to the 3rd position, leaving Germany and Japan behind. We have one of the fastest growing economies in the world today, fastest growing major economy in the world. At 7.8% GDP growth, we are a force to reckon with. We've left China, US, and most of the Europe behind as far as the GDP growth is concerned. In terms of stability, I think today India has excellent diplomatic status. We have, with the consensus G20 declaration in Delhi, I think we established ourselves as a formidable player in the global geopolitical arena. So here is a country which has a size, which is growing fast, and is politically stable. The railway network is about 70,000 route kilometers, so large network with a lot of legacy elements. So this is the landscape where we are working. I move onwards to the government policies. Now, in Government of India, our bureaucracy and political leadership today is reasonably convinced that we need to be self-sustainable ecosystem. We coined the word Atmanirbharta, which means self-sustaining. So here we are looking at buying or acquisition of large public assets where there is significant amount of domestic value addition. So that brings us to the next part of the message that I was trying to put forth. The international community has to work closely with domestic players so that we have a fair amount of a decent blend of domestic value addition in it. Because that's a roadmap that Government of India is taking. And I think in the long run, railway will stand to gain if some amount of talent, skill, acquisition is available here. In terms of technology availability, I don't think India is any longer a country of snake charmers. We have the technology. We landed on the south pole of moon. We have fired satellites, multiple satellites in a single launch vehicle. So here there is technology, there are people, enough trained manpower. India has a 5G stack of its own. So we have developed the 5G stack. So this all brings us to an environment where there are large opportunities for global players to work closely with domestic players. And who are we domestic players? We are a country which believes in Vasudeva Kutumbakam. So here is a trusted fraternity that you can count on. We're willing and we're looking at working with you closely. Another couple of seconds to talk about the domestic mobility ecosystem. So we have guys here who design, develop 5G cores. We have MCX, mission critical servers. We have IMS developed here. We have 4G, 5G RAN systems which have been developed here. We also have a chipset which has been designed in India by a company called Signal Chip. So we have the entire ecosystem, the NMS, IoT devices, the different players, small, medium size, startups, etc. So this is a resource available to the global fraternity to work with. That's about the landscape. Now coming to the Indian Railways. It is a huge, it's the fourth largest railway network in the world. And our metro network is the third largest, one of the fastest growing metro networks again in the world. So that brings us to a very large network. We are, I think, the largest employer of human manpower in the country and amongst the top 10 globally. So that is a large landscape which brings us to the fact that there are a lot of legacy systems, there are a lot of legacy learnings. We have, even today, quad cable, we have E&M phones, we have train control communication system. These are the various communication technologies or systems or subsystems that are being used in the Indian Railways. So we need to carry it all together as we look at developing a radio communication network, 4G or a 5G or any RAT technology for that matter. We need to carry all this together. This involves a lot of human learning and skills involved. You know, I've been looking last couple of days, I took some notes also in the last session. Now we are all talking about AI. Excellent to talk about. There is a skill set today that resides in the minds of railwaymen, people who work in the Indian Railways. So that's where the knowledge base resides. That's a technology, that's a IPR by itself. Now when we talk here, in the last 2 days I looked at various, we're talking about sharing the NB-IoT data. That's the simplest thing to do. Collecting data is not a challenge, sharing data is not so much of a challenge. The challenge would be to own and control the algorithms that are going to drive the AI systems. So while most of the questions we asked last 2 days, or yesterday and today, have been centered around collecting data and sharing data. I think what will be most important would be the IPR that resides, today that resides in our mind. So we need to, Indian Railways has to carefully look at this, how are we going to control it over a longish period of time, and how are we going to control it when there would be multiple vendors operating multiple different systems. So it's not only the data, it's also how the data is going to control rest of the networks. Now coming down to the technology pieces, we being a very large network would obviously cannot depend on a single vendor. So we would need vendor interoperability. We would need multiple vendors operating on multiple subsystems. So given the spread of Indian Railways, that's going to be cardinally important. While confining ourselves or complying to the 3GPP overarching specifications, so that will be an umbrella specification. Every radio network that's deployed, while they may be conforming to 3GPP, the architectures could be different. How we follow the RFCs could be different. So here is a role for Indian Railways and the officers here to kind of work together and see how these multiple vendors are going to coexist and seamlessly work with one another. Then the legacy systems, they can be APIs built because these legacy systems, people have been trained, they have tested, they've been tried, and Indian Railways has been relying on it for many, many years. They are tried and tested. So we should look at a seamless growth path, which is possible. So that should be a part of the total agenda. The systems will have to be vendor-proof. This is a large country, and there are many people trying to hack it. So vendor-proof, vendor-resistance network should be, again, a very important driving force for us. So they can be vendor-resistant marker-based carriers or carrier hopping techniques. So different techniques will have to be incorporated to make sure that they are resistant, if not foolproof. Each of these components, now whether it's a core, the IMS, the radio, the MCX services, each one of them should obviously be 3GPP compliant. At least I personally feel that's the only way we can channelize and harness the global supply chain, and we can ensure availability of hardware. But Indian Railways will need to somewhere own how these devices are going to work with one another. That means, interoperating algorithms, APIs, or or AI-based algorithms which are going to actually drive the system. AI will, of course, be very, very important. So there will have to be an orchestration layer. When we're talking of so much of data coming from various different devices, yes, of course, an intelligent mechanism to control the network. So a consensus-based communication of these trains with V2V devices can definitely be used to not only optimize the traffic flow and to reduce the wait times, it can also be used to reduce your cost of ownership, the cost of running the network. Say, for example, one could have AI techniques, beamforming techniques, or electrical tilt. Now, that means you will divert all your resources, the radio resources, in the direction of the receiver. Can be done, not too difficult as far as physics is concerned, and this can actually amount to a lot of energy saving. The devices or the arrays of the grid array, which is not underused in an antenna, that can actually be switched off. So this will mean your cost of electricity, the energy consumption would be high. It will also mean a lot of throughput in the direction that it is desired. When rest of my resources are not being used, I could channelize my energies in the direction of the receiver, so increasing the throughput. Now, all this is possible by having an orchestration layer, which means you have the NB-IoTs of various kind of different sensors, which are giving you information. It is the algorithm processing this information and deciding what action to take, which should be critical. That's going to be more critical than setting up the physical infrastructure as such. Similarly, talking about AI, it will have applications just about anywhere. All, if in a particular direction there are no, there are no receivers, then obviously in that direction maybe we can switch off certain elements of radio network. We could decide based on AI inputs that more resources are required for a particular application. It could be a media handling application, it could be a user handling application, the UGC plane, or it could be any other services which requires larger allocation of resources. All this is containerized, all this is virtualized. So with AI algorithms, we could actually do it. So what at the top level somewhere we will have to decide on how this orchestration will happen, the algorithms, how and who will control these algorithms. In the network, a network of preference, you will need something like APNs, multiple APNs. It's like having VLANs within a LAN. This network, as we're talking more and more about NB-IoT, so it becomes extremely latency sensitive. Mission critical data will become an underlying requirement of this network. As V2V communication happens, consensus algorithms are working across trains moving at 160 kilometers, 200 kilometers, and quickly looking at attaining speeds of 300 kilometers, latency would become extremely important, which means you will start doing processing on the edge. So we need to look at a distributed architecture where everything right from the MCX to the EPC can be on the edge. The cycle time for a packet to flow would come down. We will need to redefine specifications of various other components of the railway network, whether it's TCCS, Kavach, IPPBX, emergency communication, your walkie-talkie systems, so that they all converge into the radio network which is being set up. This being a mission-critical application, the railway itself is going to be a mission-critical application, especially with all this NB IoT devices, V2V communication, M2M communication happening. You will need a lot of prioritization in the network. So you would need to follow the architecture, again prescribed under the 3GPP, but 3GPP is a guiding principle. It has some RFCs. Everybody can implement that RFC differently. So there could be multiple architectures. Now we'll need to be somewhere very careful in terms of architecting the entire solution. You will need QCI bearers. For all your MCX services, you will need 65, 67, 69. Different QCIs are prescribed for it. For signaling, there are different QCIs prescribed for it. The push-to-talk services cannot be OTT-based services. They cannot be a mere VoIP, because PTT will require RTCP-based control services. Fast signaling and connectivity, you will require multicast services. So there are 3GPP standards for each one of them. You will need a mechanism for multiple vendors to work with one another, because no single vendor would be able to meet all the requirements of the Indian Railways large network. You will need emergency communication. For your video, when an accident happens, a disaster happens, you want a video picture to be picked up, and there are hundreds of officers of the Indian Railway who are looking at that particular picture. What happens today in the normal mode of communication? There is a video stream going from this phone to every single person who's looking at it. Now that's going to be a massive drain on the limited resources that we would set up on a 10 megahertz spectrum, which Indian Railways is planning to set up. So you will need something like broadcast services. So there'll be only one bearer which will carry the video stream. Everybody else would receive the video stream as it happens in a TV. Now again, these specifications are available, RFCs are available. We need to work together, I mean the global community, the Indian community, to work together and deliver a solution which not only serves the purpose of Indian Railways in India, but we also export it together. Here is a talent, here are a set of people, here's a trusted community that you can all work with, and Indian Railways would be able to control the algorithms, they would be able to have a meaningful say in these algorithms and design a network which works seamlessly for many years. Thank you very much. I'm open to take any questions.
Any question to Rajesh? Yeah. Down under.
Question is on this last slide where you have mentioned about all these things, what is happening in India and designed in India. So does it meet the requirement of what we call FRMCS, the Future Rail Mobile Communication System, which UIC and IRSE are basically trying to standardize?
Gupta Sahab, I respect your views on it, but all I'm saying is, in this presentation of mine, why should we really try to copy some system? Indian Railways is a very large network. Why can't we own or we make our own specifications? This is what I've been requesting some of the senior most officers in Indian Railway. We will need these algorithms which are ours. You know, getting data is the easiest thing to do.
No, Rajesh ji, I'm with you on that.
Sure, it'll be at par. It'll be at par. Yes, yes. It will definitely be at par.
Yeah.
And maybe a shade better.
Yeah, that is great. Thank you.
Well, I'm sure Madam will make sure that it is a shade better than what you're talking about.
Okay, thank you.
A question?
Any other question?
Yes.
Okay.
At the top?
Okay, sure.
At the top.
Yeah, I just want to ask, I mean, if all the clearances, everything are given, what would be the time frame for implementation across the entire network? And as I can see, you know, I mean, amongst all the components, for example, chipsets, what you mentioned, there are hardly 2 people whom you mentioned. I mean, would it be a limitation, or what would be the actual limiting factor in terms of going ahead? Because you need to have a convergence of a lot of components and different technologies coming in. And of course, the implementation plan as well.
Sure, sir. Excellent question. Very good, very pertinent question. It's going to take a long time before this chip gets converted into a 5G radio or a 6G radio and handles all the various protocols that are required and RFCs that need to be complied. So it's going to take some time. But in the meantime, my suggestion to the government of India is that let us control the network. Let's have a blueprint for what all is to be achieved. Whether I want EMBMS or I want TV broadcast, and let's start picking up the pieces. Whatever pieces are not available here. Say for example, I don't have a 5G radio capable of doing EMBMS or handling the MCX services the way they should be handled. Let's acquire that piece. Let's control it and have a blueprint.
This dialogue is going on at what level?
I'm not the right person to ask this. Maybe Railway Board is.
Okay.
Thank you. Anything else?
Thank you. Thank you, Rajesh.
Namaskar. Thank you.
We go to the next session with Johar, which is the role of innovation in digital technology for safety enhancement.
Good afternoon, everybody. Namaste. The toughest session after lunch, I think, and everybody is in a different mood. That is why the questions are less, since we had that experience in morning. So sessions are different. Good, enriching enlightenment by the fellow speakers, taking different technology onto the dais. Now I won't take you away from all that signaling and all, and we take you on after the cyber security and signaling. I'll take you on to the physical security of Indian Railways. It is on asset security, operation security, the passenger security. So all that, what we are doing and how CP Plus is evolving with these technological advancement, enhancing the security and safety of passengers and operations for Indian Railway. So the journey behind CP Plus instigating indigenized innovation for long time. This journey started in 2007. We are the oldest one in giving security surveillance to India. We started in 2007 when we thought of that the first journey of indigenization and innovation started in about 2011. Because from 2007 till 11, the CCTV cameras were not the necessity but the luxury, and very few guys have that luxury with them. When it moves on to from the luxury to the necessity, or basically the project requirement kind of thing, then we control the firmware with us. So as my fellow friends have rightly said, that you have to have the control of software in your hand to basically fight on with any malware or any malfunction or any pilferage or any vulnerability. Looking that in mind, in 2011 we first have put in our R&D services and R&D functions working onto the firmware to control the software part of the cameras. And being the oldest, we have the largest installation in India at the moment. We are selling almost 14-15 lakhs cameras in a year. Now you can calculate it for 15-20 years that how much percentage, and we are taking on about 56% market share as of now in India. Now with this technological evolvement and technological enhancement, we went through along with the technological advancement done by worldwide, and then we have produced it by our own R&D and working out. And in this process, we have put in our first factory in 2017 itself. So the cameras, surveillance cameras are being manufactured in India from 2017, and the first factory was basically manufacturing about 1 million cameras per month for our own use and for India use. And this advancement is going on, and we have come on to that now that we have established our own R&D house. We have penetrated up to the tier 2 and tier 3 cities. We are giving them the kind of training, technological training. The advantage of it is this, like for Indian Railway, every station you come out, you will find a camera installed by CCTV, and you will get the services out there. So that is what is the service network that we have built up along this. In recent days, looking at this geopolitical situation and the export market, we have invested a lot in India, and we have built up a new factory, which is world's third largest factories and India's largest factory, and can produce about 3 million cameras per month. So that factory is there in Kadapa, which is about 200 kilometers from Tirupati. As of now, with this journey of about 15 plus years, 17 years, we've got 46 offices all over India, 130 branches, RMA, SWAP, to provide these services, 130 plus services. We've got 15,000 partners to provide sale and services at the remotest location of India. 450 plus towns we cover with services, and it is almost about 1,300 employees plus 3,000 employees in the factories what they are producing this. These are the certifications. We have got all the certifications whatever required for this. for R&D, CMMI level 3, level 5, we have got all IP67, IK10 certificates, so whatever certificates are required. So it's basically like we are maintaining the quality and quantity of the product right from the day one. This is our manufacturing unit at Kadapa, which will give you the thing, and I'll basically at the last I'll give the what all are the facilities we have there. Now coming back onto the new manufacturing facilities on this point, that this is largest in India, as I said. It is about 250,000 square feet areas, which is distributed into the production warehouse. So this huge capacity we have built up just to cater to the Indian market, because now everything, because CCTV surveillance right in 2007 from luxury, now it becomes the necessity, the home market also and the enterprise market also. Now, I'm just coming back that touching upon that what all are the solutions we are providing for Indian Railways. So there are three major railway solutions. As I said, that passenger safety, operation safety and the asset management for Indian Railways. So railway stations, platforms, yards, etc. We are providing securities for that. We have got all the solutions for these train engines, train coaches, and completely indigenized core components, what we are providing for these operations. Now in railway platform solutions, what was the need of railways? That basically is here, like the solution which was asked for and the proposed for is having different kind of cameras, NVRs, command control stations, containerized data centers, computers, compute, storage, everything the solution asked for, and we have built up according and customized according to the requirement of the Indian Railways. These are some of the claims for installations. How the installation works, we install, if you see these face recognition cameras are at the gate to recognize the every person onto the entry and exit. We can here recognize even the color of the shirt, color of the clothes. We can recognize that POC has been done, and we have successfully did that. Even with the mask or with half face, we can recognize the person's face, and if it is in the database, it will connect that it is working or not. Similarly, on different kind of cameras at different places, I'll not go because time would be there, and in face recognition, the system will detect the human faces appearing in the defined areas, whatever, and connect with the database and give you the fine result, so that you can stop that. Like if you see in these videos, if somebody is coming, then it would give that the complete details from the database. It would, at the side, it will give the details that who has come up onto the system. So as and when the person comes in front of the face recognition area, the area, then it would be done, and it will give the complete details of that person. Similarly, in service areas which are basically isolated, and we have got all intrusion detection system there, that if a person is working there, and if he basically is inside that range, what we have this fencing area, then it would be given a red alert to the control room. Similarly, this is left object applications. If somebody leaves these applications, so somebody leaves the luggage there anywhere, and we set up a time that for 5 minutes, 7 minutes, 10 minutes, if that is there, then it will generate alert after that time limit and give alert to this. Now, why I'm showing this is all general artificial analytics or AIs which are available in systems and all. Till this time, this all were available with the video management system or some different analytical engines running onto these servers, different servers and all. What we have built up is now all these analytics are working on our edge, at the camera of the edge. So it will reduce your compute, it will reduce your bandwidth consumption, it will reduce your network component. So that is what is the innovation did in these analytics, that these all are analytics are available at the edge of the cameras. Loitering object, if somebody is loitering around into that area, we've got heat map also, that if basically in the station area you want to see that yellow, red and this depending onto the crowd you maintain. So these all are available at the edge, and you can detect and get alerted accordingly. Similarly, in the train engine surveillance solution offerings, we have got the similar kind of this 2 cameras at the driver edge to basically those we call it driver cameras, which see that what driver is working, how he's behaving, and that is driver alerts. 2 cameras for the driver, 2 cameras at the station, at the entry gate to this, and 1 camera as at the front of the engine and the back of the engine, like it can be it can work both sides to view that what is there onto the track. Similarly, in train coach surveillance, we have got face recognition cameras at the gate and 4 or 5 cameras into the coaches, and with along with the panic alerts, so that if there is anything, one can alert with panic. Now, the key lies here is integration of proposed product and control rooms. Here you need the customization a lot, wherein the indigenization and the Indian competency in R&D is required. So anybody can give off-the-shelf product, anybody can give off-the-shelf analytics, but integrating those to take out what your concerns is, to take out what you want, to get the final result, you need an Indian R&D expert, and that expertise are available with us. That is through centralized video management software, which we control, and we basically integrate all the components through central video management system. We have got, this is the solution architect, that the cameras would go to the railway station, and railway station to the divisional headquarters to the control room. So with Tulisa's help, we can take all the cameras thing right till the railway board or headquarters to view things in a broadcast mode and in one go, sir. So this is how we can help Indian Railways, that we have got the expertise in understandings for serving for this. We have got complete indigenization, indigenized solutions and augmentation, pan-India presence, as I said. We have got high availability mode deployments for all the installations done by us. This is what I left over is road ahead to basically self-sustain India and Atmanirbhar Bharat, what we call it. This plant what we have built up is about 250,000 square feet, as I said. We have got the most reliability and testing labs, most reliable testing facilities there. All test equipments which are required to be there for testing the cameras, security, cameras, quality control, we have all got all that. We have got latest SMC line, so to achieve that 30 million, 3 million cameras per month. We have got complete dust-free flooring, that too in an area like Kadapa. We have got automatic PCB router machines, that is one in India, and like it's very rare in these kind of electronic manufacturing. We have got expandable capacity to serve to the requirement, those, and railway is the biggest customer and biggest owner of these time. We have got complete manufacturing and testing process, camera assembly line. If you see, this is the line what we have there. Then we've got Fuji's NXT third line. We've got leak test machines. Every camera pass through that. We've got strong quality check on all the cameras. DVR assembly line for digital video recorders and all. Aging room where we test the complete cameras after final testing. Then assembly areas, all cameras assembly area. So basically the idea of saying all this is that we are the oldest one. We have the largest capacity of producing the cameras. We have got the state-of-art manufacturing plant and manufacturing unit. But the thing is this, that we have the largest installation base also. Now, thing is this, that if somebody says that 6 years before CP Plus has supplied this camera, this one, so that was basically probably because of the ecosystem was available like that only, and we have developed that. We are proud that we have break that wall, and we are now working and competing those kind of geopolitical friends with these geopolitical situations with our friends, that we can compete it in any areas. Now, CP Plus is ready with all 3 layers, whether it is a home series or a project series or a premium series of cameras. We are ready manufacturing that, working on that with all these analytics which are required on edge. We are there to compete in those all 3 planes. Thank you very much. Any question?
Yeah, my question is regarding this face recognition technology. Is there any law in India how to regulate it? What are where we are morally and ethically about this? Because as I understand, this is a very big issue, especially in US and some other countries.
See, thing is this, as of now, as I said that security industry is evolving, there was no policy at all for usage of or supply of CCTV cameras in India at the moment. The policies are in making at different ministries, MIT and MHAs. And these kind of, what you said is covered that up to what level you can do, what kind of requirement, what kind of projects you can use face recognition onto. So I think I hope I answered your question, or so those policies are in making, and it would be a clear guideline that how to use that.
Hello, good afternoon. And
yeah.
Actually, you were talking about integration of other devices, right? So other devices means the devices which are manufactured by CP Plus only, or the devices which are from other manufacturers also?
See, thing is this, that there is a platform called OnWIF platform for CCTV cameras. So all cameras are OnWIF compliant on different categories, which is available on site. If it is a OnWIF camera, it can be integrated to any software. All devices can be integrated to any video management system. So are all, even VMS on the cameras are completely OnWIF there. So we can integrate to the devices which are OnWIF, and we can be integrated to the devices which are OnWIF.
Do we have some like protocol converter type of item which are not compatible with the CP Plus NVRs or CP Plus servers, can be connected to the CP Plus devices?
That can be done after reviewing the API kind of or SDK things from the software which is to be integrated, and then our technical team, that is the positivity of, or that is the positive side of having in-house strong R&D. So we can do that.
Okay, thank you.
Thank you.
Thank you.
Thank you, Joel. Thank you, Joel.
Sir, I have one question.
Who has a question?
Yeah, no problem.
Come back.
Please.
Sir, is there any backward compatibility of your new models with the existing models?
It is there, 100%.
Sir, is there any provision for accessing the data through cloud?
Means,
sir, we can access the camera data as an NVR through cloud.
No, that is where these things, see, in the earlier model it was, but now we have given the firmwares. Even I just want to mention a good thing you have asked for. In some of our older model, 5 years back, 6 years back, 7 years back, what we have supplied, there were some freelancers who have found some vulnerability, and the moment it has been reported to us, we have immediately upgraded the firmware, and whatever cameras have been supplied on that, it has been out of that vulnerability. So that is how we are working. Now you are saying that legacy cameras onto the same VMS, so that we do integrate with that.
Thank you, sir.
Thank you. Thank you, Joel. We reach the last session of this set of presentation about digitalization. We go now with Sanjeev on tamper-proofing of signaling field assets. Thanks.
Namaste, everyone. We all know that integrity of source information is the base for all digital transformations. So tamper-proofing of signaling field assets becomes very important because the train control operation depends on them. I will be discussing today with reference to the Indian Railway installations, the needs and the solutions. For tamper-proofing, we'll be giving you simple and complete solutions and secure solutions. Presently, the selection from the station logic is extended to the field gear through a pair of conductors. Now look at a signal. If I have extended a feed through a pair of conductors to a signal, which is red in color, I got the red selected here and I extended it to, corrected it to the red there, that's okay. But if the conductor is shifted to yellow or green, whilst I have selected red at the station, the one where the conductors are connected would be the one which will light up. And it would get proven as well at the station. So the system at the station will never know which signal is really lit up. Now this is a serious issue, so it needs to be corrected. Field asset proving is not really output based. It's indirect. For example, in a signal, while there is no relationship between the light output and the current, because the current flowing through the cable, which is being proven, is also could be coming from a cable leakage. It could be also coming from induced currents from the traction supply. It could be a fault across the line. So it is not really it's a low integrity proving. Again, in signals, we have greater difficulties because the length of direct feed is small. So we require to have cable breaks and switches in the field, which require 70% extra cabling and field relays. So when I have to operate the signal, I have to operate all those field relays to give direct connectivity to the signal. Now this extra cabling and those field relays are also a cause of 20% signaling failures. So maintenance issues. Frequencies of trains being high, if there is a tampering which has taken place, by the time we come to detect it, there is enough hazard time available for a mishap to occur. If you look at the point machine, the scenarios are quite similar. The point machine, in a way, is shade poorer in terms of proving, because we are carrying all the proving information, which is of course indirect, because we are not doing output proving there, back to the station and proving it there. So there are many conductors, some 10, 11, 12 conductors, separate conductors for the actual feeds, separate conductors for the selection, and then separate conductors for contact reading. This also needs to be addressed because it is prone to tampering. Tampering may not be always intentional. Sometimes during the course of maintenance, it happens. We have large trained manpower who are only having the skill sets for existing platforms. So whatever solutions we provide, we have to make sure that they are simple and they don't require a drastic change in their skill set. We shall be addressing all the besides safety, we should also be addressing the reliability, the availability, and the reduction in maintenance requirements along with this complete solution. Sanarthi has been associated with Indian Railways since 1988, so we are more of railwaymen. We have very good sense of the working. Based on our understanding, we have brought out simple and complete solutions through safe signal drives. What is the safe signal drive? The safe signal drive is a low count configurable circuit with nil possibility of wrong side failure. So that means my detector has become foolproof. So if I am able to suitably incorporate it inside the system, and preferably in a non-invasive way, so that my functioning doesn't get affected, my system doesn't know that it is there, then I would be able to achieve my tamper proofing, as well as I will not have to affect the skill sets of the people. So through safe signaling drives, we have two ways of tackling the tampering and making it tamper proof. One is we extend from the origin in a fail-safe way the selection to inside the field gear, which means the cable also gets into that part of the fail-safe proving. The second is that from the gear, we do output-based gear-specific feedback to the station. That also can solve our tampering problems. Now I'll come to the specific solutions. You are seeing here the current signal lighting circuit. We have a fuse link unit, we have a electromechanical relay for lamp proving, a cable. I have not shown the cable breaks and field relays, and the signal lighting unit. By installing a SSD at the origin of the selection in the station logic and a matching SSD inside the gear, which is the aspect signal lighting unit, at the point of entry of the feed, we are able to solve this problem. Now see how the miracle occurs. Unless when that SSD receives completes the circuit with this SSD this side, it is able to generate a fail-safe enable to light the signal inside. It's all electronics, no relays. And if it is getting from anywhere else, it won't light up. So as a collateral benefit, we also get noise immunity. And that translates into direct feed. So we have created a tamper proofing, we have created noise immunity, and we have also removed the need for all those 70% extra cabling and those field relays that we use currently for giving the cable breaks for unselected signals. This slide shows lots more information. For example, it also shows that with SSD on one side and SSD inside there, you also automatically get line integrity. So line integrity, of course, but line integrity to the extent that you can't even change the VX and the NX now. So it forces the maintainer, when he has to change the conductor, if it is effective, to only do corresponding connections. Because any other connection, the things won't work, even on the aspect itself. So we have addressed force the maintainer to follow the requirement, reduce the maintenance needs, and we have increased the availability of the signal, and we have given you tamper-proof working. So it seems we are fit to go for extensive use in the digital transformation. However, we still have the electromechanical lamp proving going on there. So that also has been addressed. We have SSD-based electronic proving units also available, and these would not only detect the minimum threshold of current in the existing systems, but they will also detect the fault across the line when there is excessive current flowing, and both of these would have a direct interface. These electronic proving units have a direct interface with RRI through any relay or SSI directly, EI directly. Similarly, now we are looking at the solutions from the other end. My LED signal, which was incorporated in the bulb lighting circuits, was forced to operate that relay. The LED signal was consuming only 4 watts, but I had to operate it at 16 watts just to draw that current enough to operate that relay, to make the relay pick up and remain in the safe and generate good contact pressure. But if I use optical sensors, which you can see are there in the signal, and I send optical feedback on the line, it does another miracle, because now I am not affected by voltage, I am not affected by current, and I am also not affected by cable leakage, sir. But for the fact that only when the cable becomes short, till such time my feedback goes on. This all information has been validated and submitted to RDSO. And we have also done harmonic analysis with respect to the RE. All harmonics have been injected through an induced voltage, and we have seen that it does not affect my optical feedback. So I have a foolproof system on the reverse direction. Now if I give from gear to the station, so now if I give you gear specific optical feedback, separate for red one, separate for green one, again I go into a very high integrity situation. So depending on the station logic, we can be using both the SSDs starting from this side and this from gear side to this side. But if the gear logic is good, then we don't need to use from both sides. Either side can be done, but tamper proofing with absolute integrity will always be with output based proving of the field asset. The same thing now we have addressed for the point machine. In point machine currently also we are doing indirect proving, because we are reading the contacts inside the machine. We do not know really whether those arms have moved and the rails have connected. So we need to put in proximity sensors and actually take input from them as well. I think in the session before lunch, there was a talk that we are using, after Balasore accident, we are going to put some proximity sensors and send them through Wi-Fi. But that is, in my opinion, not a complete solution. The complete solution is that I do the fail safety validation inside the point machine itself, and I send a feedback which is immune to noise, which has no limitations on the length of feed, and it is not affected by cable faults. So this is what we have generated here with the SSDs, we put one unit inside the machine, and we've validated the contacts, and we've also selection interlocked it. So the selection is also being validated along with that. Along with the output, we are validating the selection, giving you absolute integrity, sending it as a fail-safe feedback. Remember that SSDs are having nil possibility of wrong side failure. So we send the fail-safe feedback over a pair of conductors to the station. There again, this feedback is received in another SSD, and this SSD, well, for additional integrity, we again safety interlock it with the selection, and then we generate the final isolated, galvanically isolated output to interface with the station logic, whether it is RRI or it is EI, and we give you a foolproof, tamper-proof solution here. All those cable conductors are gone. In our opinion, we just need the supply of 110 volts to go there, and we just need one supply for this for the SSDs. And because we are selection interlocking, so we don't have to carry those relays into the field, and we make life easier, bring down our maintenance requirements, and go for tamper-proof working. So with that, I end my presentation. Thank you very much for listening to me, and with a small comment that SSD-based interlocking using power feed conductors is going to pave the way for a fail-safe local area network. We are also addressing the automatic signaling parts. They are under study. We are trying to see how this thing can be worked out, and we feel this has a big future ahead. And these are secure solutions, sir. Very important to note that this is system integrated safety. I'm not going into another medium. I cannot be cyber attacked. You know, it's a system integrated safety. Demonstrations are there of the live demonstrations are there of this in Hall C, booth number 4 and 5. We'll be very happy to show you the same. Thank you very much. I'll answer any questions.
Hello, sir. I'm here. Sir, your one SSD which is to be installed in relay room for suppose signal, if it is been bypassed or it is been removed, what will happen? Your signal will lit up or it will go dark?
No, it will not light up.
Okay. Say,
the two SSCs together complete a circuit.
Okay. And is there any chance that any of the technician or anyone can remove or bypass the SSD which is present inside the gear, maybe point machine or signal unit?
See, if he bypasses the inside the gear, in case of point machine, you won't get any feedback at the station. I mean, it serves no purpose.
I mean, it is possible that he can bypass.
You can physically remove the machine, the part from there, and let the point machine be there. It won't operate either. Wherever it is left, it will be left, and you won't get any feedback at the station. So what service you have immediate information in your station logic that my machine is gone.
Okay, it will show as a machine failure.
It will show as a machine failure.
That is okay. Because signal which I am seeing at your booth is a compact one.
Yeah.
So I think from those SSD cannot be removed or cannot be bypassed.
No, they are integrated inside the signal.
Yes,
That's
yes.
what I said, from the origin of the selection to inside the field gear. Now, if somebody opens the field gear and takes out the device, it serves no purpose, because my communication with the station logic is only on a pair of conductors, and he cannot generate that feedback because the two are bucking in tandem.
Okay, I got the answer.
Yes.
Thank you.
Any other questions, please? Thank you.
Any more? Thanks,
Namaste.
Sanjeev. Thank you.
Namaste.
So thanks to all of the panelists having given some great presentation about the value add of digitalization for our railway business. We have reached the end of this session, so thanks to all for your attendance and your valuable question and feedback. Thank you.
Thank you very much.
Ladies and gentlemen, I think it's time for us to first of all thank our session chair and along with that our session moderator for this session, which was the role of digestation and infrastructural upgradation and operational excellence, Mr. Sanjay Kumar being the session chairman, and our session moderator, Mr. Michel Obadia. Can we have a round of applause for all our panel speakers, our session chairman and our session speaker, please? And I can already see a lot of you right now moving out for tea and refreshments. I would like to request you, rather inform you, should I say right now, that tea and refreshments have been opened, but we are not officially having any break right now for tea and refreshments. In case you wish to have your tea or refreshment, you can kindly go outside and have your tea and then come back inside. But because we need to manage the time also over here, I'm going to be straight moving on to our next session, ladies and gentlemen. And this session is going to be about development in modern asset maintenance. The session chairman in this session is going to be Mr. A.K. Mishra, Chairman IRSE Indian Section. And the session moderator is going to be Mr. Navneet Kaushik, Director Systems NCRTC. May I please invite both of them on the stage, please? May I also now invite on stage, good evening gentlemen, may I also now invite on stage over here our session speakers for this session, Mr. Mauj Pandey from Statcon Energia, who shall be speaking on the green signaling power supply system, Mr. N. Shukla, Chain Code Consulting LLP, who shall be speaking on the digital twin tech and NFT, Mr. Ajay Singh, Director, Railed. Apologies. Mr. Ajay Singh, Director, Rail Dutech, who shall be speaking on the capacity building for safer digital railways. Mr. Deepak Sawant from McLaren Applied UK, and M. Nadeem Siddiqui, who shall be speaking on, who's basically the Export Director from Nefco Power. They shall be speaking on the digitalization for operation excellence in railways, blockchains and FRMCS-based decentralized train control. I would also like to invite over here Mr. Sanjay Kumar, Director from Kochi Metro. Also, ladies and gentlemen, just a small little correction that I wish to do over here. That is Mr. Deepak Sawant and Mr. M. Nadeem Siddiqui shall be speaking on cutting-edge 5G technology for train-to-ground communication. And Dr. S.N. Gupta, the chairman from Blue Town, India, who shall be speaking on digitalization for operational excellence in railways, blockchain and FRMCS-based decentralized train control. Mr. Rohit Kumar from Sublime AI Incorporation, who shall be speaking on applications of AI or ML in railways for predictive maintenance. And Mr. Dhawal from TWYN, who shall be speaking on creating smart factories, a digital twin approach. Post this session, ladies and gentlemen, there shall be a small summing up of the session and all through the entire sessions that we have had since yesterday. With that, we should also be wrapping the day too. But for now, I hand over the session to our session chairman and session moderator to kindly take it forward from there, please.
Thank you.
फर्स्ट मनोज पांडे का करना है ना? हाँ ठीक है। अच्छा नाम
हाँ सर ये एड ऑन हुए हैं मेरे पास एडेड ऑन लोग हैं नवीन से भी हाँ मैं इसका आपको दिलवाती हूँ मैं आपको दिलवाती हूँ
लेटेस्ट
Yes. I would like to welcome all the speakers at the dais. This session is, the subject of this session is development of modern asset maintenance, and there are seven papers. By chance this is the last session, and people must be in a hurry to return back to their homes. So I will request the speakers to limit their presentation to the extent possible without any compromising the quality and everything. Now I will request Mr. Manoj Pandey. The moderator of this session is Mr. Kaushik, Director NCRTC. I will request Mr. Manoj Pandey to give his presentation on green signaling power supply system.
Good evening. I will be talking about a very, it looks like a very general aspect of the power supply system for Indian Railway. However, what is important here is that when we are talking about, world leaders are there at COP28, we are talking about temperature rise, not more than 1.5 degree, etc., save the planet. So I will be touching upon how to save the energy or how to include the green energy into existing railway system and all railway system in signaling and telecommunication. So in a railway network, we are the power supply normally that is given to the signaling network to work is 230 volts, but you would be surprised to know that these two graphs, as they show, the supply is highly fluctuating in nature, and as we are adding more and more train onto the network, it's going to be bad not only in terms of the fluctuation in the upper and lower limits, it is also creating what we call as harmonics onto the grid. So any power supply system, which this is the typical power supply system which we are supplying and Indian Railway has designed, they are undergoing these kind of stresses, still working. In fact, this power supply, this method of signaling power supply is unique in the world, where it is a highly customized supply designed to work under adverse environmental conditions, be it dust, be it temperature, and the input line, all kind of the polluted input supply line, which is fed to it, and it is working and working in a most flexible manner, in my knowledge, in a signal network all over the world. So, as I was talking about adding the green energy, now the first name that comes to mind is solar energy. Now, most of us sitting here, or almost everybody thinks today that they know solar, but I am just trying to show that a very simple method of thinking about solar is, well, when the sun is shining, you store the energy, as the first slide, the left-hand side picture says, and when the sun is not shining, you use that stored energy. This, according to every expert or a normal person, is the most inefficient way of doing it. So the next way that came was what is called a grid tie, where you generate electricity and you give to the utility. So you
You generate, as the left slide shows, you generate the electricity. Whatever you are generating, you draw only the differential from the grid source or main source. And the right slide shows, if you are generating more than what your consumption is, you export to the grid, you give it back to the grid for somebody else to use. Sounds excellent, but this is not so simple as it looks, because there are a lot of rules and regulations. Anybody selling the electricity, well, today for S&T probably it is they're not charged, they are not billed, but the day is not far when somebody will be within the department also will be billing them. But this is generally true. So this is not so simple. The third method, which is a combination of the first and the second, and the most popular today globally, is what is called a hybrid system, where the terms started, behind the meter, or where you not only store it, you also blend the electricity and use from what is coming from the grid. So you top up the electricity over the electricity which is coming. You use is stored when the peak, the supply fluctuation is coming. So you add that. So you will not be adding burden to the railway electrical network, and you will be using a green energy. You will blending the green energy in the most efficient manner. And as the lower graph shows, by doing so, you can see this is a real graph where green is the every day, every 24 hour, a mix of about about 30-35% of your energy consumption, in-house energy consumption, is going to be green energy, renewable energy. So the world over, not only in railways, but otherwise all industrial and residential systems, the concept has come which is called distributed energy. So all of us know that we were all consumers. Any building, this building also, or railway asset is a consumer. And there is somebody who was a producer. A new word has come in a dictionary, prosumer. So the producer is a consumer and vice versa. So every building becomes a producer and a consumer simultaneously. And just to draw my point, the left-hand side, the Sonnen is a Shell group company. They have a huge community of lakhs of residential and commercial people. So using in Europe and US, and same is Tesla. We all know Tesla Powerwall launched in 2015. So in Europe and US, where the power failure is not a thing to be thought of, there also these kind of hybrid solutions are in operation, where you judiciously use the solar energy. So how we can take it into our use? I have just 4 more slides. It's very simple to understand for anybody. Now, whatever roof space is available, you don't require 10-20 kilowatt, just 3 to 4 kilowatt of roof space that is available in every signaling installation. We have more than 7,000 to 8,000 installations, and if we have just 3 kilowatt or 4 kilowatt at every place, we will be able to use about 40 to 45% of our electricity requirement from the renewable energy. And this is going to be a typical example of the Meri Bijli Mere Ghar type. Each signaling installation will call, it is my homemade electricity, self-required electricity, and the payback period is going to be maximum 2 years, not more than that. And think of it on a macro level, what is a kind of contribution. This is in addition to the megawatt plants which railways are doing, or all such things are happening. Similarly, a more appropriate case is coming for the railway telecom installations. We have BTS and we have large number of telecom assets where there is a diesel generator set, and incidentally they are paying at commercial rates, 10 rupees. It makes more sense for them, not to run the DG set, but that is not the point that I want to drive. It is that they can blend the renewable energy into their daily consumptions, and we have been doing this with lot of BTS and many such microgrid and such installations where that is where the term behind the meter is called, that you don't export, you don't give to electricity board, but you generate and you blend in different proportion. This is possible through power electronics, the power converters that we manufacture. Our name is STATCON, is for static converters. So it is possible, it has been possible through power electronics, and it is said in various forums that the rotary generators are facing a very tough challenge through power electronic converters, the inverters. And this is what is, you will see in next maybe 5 to 10 years, this is going to be a game changer. Lot of diesel generator sets are going to be removed by hydrogen and fuel cell and power electronics, which has a flexibility of blending different things connecting to the main grid also. So this is what I suggest, that on existing installations as well as in new installations, this kind of thing can be incorporated, so that the Indian Railway Signaling Department also joins the Prime Minister's mission or the global mission of reducing the carbon credit. Why should we go far off elsewhere? It is available around us. It's available for us, for each and every installation to be converted and add the renewable energy. The last slide is another thing. Now, the technology has evolved, the engineering, the solution, everything has changed. Even POTA cabins, many places, why should you have a civil work or POTA cabins? We can have such power converters in what is called IP55 degree of protection. So by the side of the track, with battery inside or another cabinet for the battery. If you have a space, have a small solar panel of 3-4 kilowatt or without solar panel, but have these things at different locations, remote location, level crossings. There are umpteen applications of different sizes. We are doing this for microgrid operators in India and for a lot of African countries, especially Nigeria, where such people are using up to 50 kilowatt of systems on the same concept. Building no room, no POTA cabin, just by the side. So this reduces the stress on all these investments and gives you clean, green energy. This is all I had to just share on the contribution of renewable energy. Thank you.
Thank you, Mr. Pandey. Now, I will request the audience, if there is any question on the subject he just now presented, it can be asked. Yes.
Sir, good afternoon, sir.
Mr. Manoj.
So now input is given through solar panel. During rainy season, so there is no any sun energy means. Can we adapt? Can we give input through DGZ as well as that is actually available that OH AC source? Okay, sir. AC can able to give in case of the solar energy not available. And in case if if this problem I have, say immediately the changing over to solar to that available AC voltage, can these existing SMPS and the ACDP can adapt that existing that connectivities and all, the transient?
If you had noticed the IPS configuration, there was a battery. We all know that solar may not come for about 60-65 days in a year. There is no need to get sentimental and use 100% solar. It's not right. That's what I have been telling. In a hybrid system, it is a blending of renewable energy into the grid. Grid energy is one of the best friend. Try not to use solar. So, well, there would be days when the renewable energy will be less. You use the grid, nobody stops you using the grid. What I am trying to say, reduce the usage of the grid energy, which is today coal-based in our country at least. So I have never said that don't use the grid. Even daily we will be using maybe 60% grid and 40% renewable energy. So top up the renewable energy, don't throw anything. That's what I have tried to say.
In case of any emergency, if a changeovering means inside that equipment that something connectors, and can it withstand that heavy
No
that peak
transfer
current and
time.
all?
It will work seamlessly without any transfer relay. There is no such problem. It will work that way. It has been designed that way. You can ask your specific questions. I can give you more details and draw more analogies. Not a problem. It is seamless.
Because some cases there are existing some the companies, when we are may change over that actually modules, I mean 5 amps to 10 amps increasing means but that something connected is burned, some problems are coming. But in case of this type of things, we are changing over means there may be the chances may burn and something that the increasing transient current, there may be problem will come, because surge is more in that actually AC source. That's why I'm telling.
I don't know what scheme you're talking about. You can write to me separately. This type of schemes or technology has no such changeover device. It is seamless. There is nothing. They will work in tandem. So you send your scheme, I'll be able to answer and give you an alternate. Okay? Send me a mail, we will do it later.
Yes, sure.
Yeah, thank you.
What is the area is required for 1 kV generation with the present efficiency level of the solar cells?
So today about 100 square feet for 1 kilowatt.
Okay.
So not much, because panel sizes have changed nowadays, 600 watt,
Correct,
600 plus
correct,
watt panels
yes.
are available.
The second is when we talk about the green energy, is it not finding, are we not able to find the viability of using the wind energy along with the solar in tandem with the different form of, lots of concepts have come with the wind energy as well. So even at night it can generate some energy, even at the odd weather, inclement weather also it can generate some energy to supplement the green energy.
Yes, so any excess energy.
Wind, I am talking about the wind energy along with the solar.
So we are, I didn't talk about wind because in railway, well, a lot of things have been talked about. If you have wind also, we are doing solar, wind, biofuel, micro-hydro, everything we are doing.
Yeah, just a minute. We are advantageous because our trains are moving every on and off onto the track and our installations are besides. So wind is likely to be available with us, maybe in a little form. So I think it can be very useful to us.
Yeah, sir, some experiments did take place by putting a vertical wind, so train moves, that wind is generated.
Something that kind of a thing, or maybe some other alternative. Yeah.
It has, yeah, but somehow I don't know why it has not gone beyond some proof of concept. It's a good thing. Trains keep moving and you keep generating, add along with solar, and it's possible to do.
No, but I don't think such type of experiment has been done anywhere in the world so far, right, with wind energy. In coastal areas, yes, coastal areas the wind energy can be utilized for generation, that is good, but not in all the areas.
Sir, 500 watt, 1 kilowatt things.
Actually, for this wind also there is a topography, like a survey has been done, because as you see that if you go in, as Sir has rightly said, that in coastal area you will find the wind, and there you will find a lot of wind wheels are there. But not in all other places where you will get the wind and then you can install easily. If that be the case, people would have installed at their houses also. So and that will not have a basically that what you can say, that energy will not be sufficient.
Okay, right. Next question.
Sir, I'll just answer this. Even in houses, people are installing 500 watt wind in heart of Delhi. You don't need to be in that zones, and along the train, what he's saying is right. When the train is moving, it will move. So lot of energy, and if you add on the day basis, will happen. So what he's saying is, I am in agreement with him.
No, that is right. If the train is moving, lot of wind energy is generated.
Sir.
But I don't think so far in the world it has been, some work has been done on this thing. But yes, of course, this theory can work.
Yes.
In future. Now, next question. If there is no question, then I will invite Mr.
Thank you.
Mr. Sanjay Kumar.
Yes.
Kochi Metro.
Yes.
Kochi Metro. What is the subject?
Sir, use of AI use cases.
Okay, right.
AI
So,
use cases.
please go ahead.
I have given my presentation. Yes, sir, PPT already given. One moment. I already given them. Yeah. esteemed guests on the dais, respected dignitaries, myself Sanjay Kumar, I'm Director System Kochi Metro Rail. Basically, since morning, since yesterday, we have listened about the AI, how to use AI, but I'll be bringing some use cases and digitization in Kochi Metro, what has been done in-house. I will be covering basically this agenda item. So something has been done inside that is called OMMS. We call it Operation and Maintenance Management System, Document Management System, QR based Maintenance Management System, Rolling Stock Management System, and implementation of AI system. Why OMMS is required? Basically it is a e-government focus, in-house innovation, efficient module, and we have used the open source technology for this work. And what open source technology we have used, that is a LAMP stack source, basically LAMP acronyms for Linux, Apache, MariaDB, PHP. Basically this is operating system, then web server, DBMS, and programming language. With that, my in-house engineers have developed this OMMS system for the Kochi Metro. This can be implemented in the railways as well. So there are 8 different modules in this OMMS system. One is work management module. Here we manage this PTWs, permit to work, and then job cards. And then we have got lost and found modules. Let's say somebody has missed his mobile or some other valuable equipment or some purse in his train or some station. It will be kept, and there is a module on a website, and it will be logged on there, and then when that person will inquire through customer care, he will come to know that yes, my material is there, and whenever he will be informed that okay, you go, you come with your identity, and then accordingly he will be delivered all the things. Then we are doing the train operation and crew management system. With this module we are operating with this internet device registration, any new device, a mobile or a laptop, we are registering into this through so that there should not be any hacking kind of system should come. Staff assurance, normally on a daily basis or some weekly basis we are using some SOPs or circulars. So those are not in a physical mode, these are all in a digital mode. So we give and then get the assurance. Failure management module, a failure is generated and then these are all paperless, sent to the maintainer gets this and get it attended. Then roster and smart attendance, this is basically let maintainer has to go to particular station for his attendance. He need not go, even his mobile there is an app, through that he will go to the particular failure location, and then he will logged in there, and there is a geo-fencing arrangement is there in that particular app, and through that he will put his attendance, and then after attending the failure he will get it to close that also. And then dynamic forms and checklist, that also is being done through this OMMS module. Now this is what is the OMMS app. This is basically smart attendance. This is geo-fencing arrangement. It has got a biometric authentication, GPS based check-in check-out arrangement. It is basically, it will avoid the proxy attendance, the real-time data sync, what time he has actually come and gone. Then there is something called QMMS, QR based system. This is basically, I have deployed it for my power supply equipment, the transformers, inverters, the switches and all other important power supply equipments. And these are the modules. Basically through QR, it will tell what are the problems, whether it's a corrective maintenance or the preventive maintenance, and what are the readings, and automatically system will generate the mail to the respective personnel, and they will come to know that this is the status of the equipment. Now I'm coming to this AI in maintenance, rail and metro. So AI, as we know that AI is this basically this system how to basically to train the machine, and then machine learning is another subset of AI, which is basically a statistical tool to analyze and analyze the data basically, and then deep learning is further using the multi-neural network. Now coming back to this kind of a brief on type of machine learning. So there are 3 types of machine learning, that is, one is supervised learning, unsupervised learning, and reinforced learning. Supervised learning is basically based on the labeled data. Labeled data is nothing but the data for which output is known, and then unsupervised where the output is not known, and then reinforced is basically a small part of labeled data and maximum part of the unlabeled data. Then with that we are using it Like supervised learning, we are using for the predictive maintenance. All that we were talking of, basically supervised learning, predictive maintenance, and the classification. And if you go for this unsupervised learning, here it is clustering. I'll be giving subsequent slides examples also. And the reinforce is basically agent and environment based. Let's say something, it's like a trial and error method. And then the following algorithm we are using, like in supervised, we are using linear regression, logistic regression, and then unsupervised k-mean, and then q-learning in the reinforced learning. So this is again the similar slides with some use cases and examples. Like in supervised learning, we are using like email classifications, IMDb, the range predictions, weather predictions, sales predictions, and unsupervised you are using this customer segmentation. Like recommendation, we are giving, Amazon is giving some recommendations, that is through that only unsupervised learning. And then coming to the semi-supervised or reinforced, like a self-driving car, robots, building games, like that. Then there are 7 different steps of machine learning. First is basically we have to collect, because I am already working on this particular aspect, so data collection is already going on. So data collection, then data has to be prepared in a respective format, and then we have to choose the appropriate model so that we can train that particular model, and then on that we have to evaluate what particular the analogy or what particular algorithm you use, this is working or not. And if it is not working, probably we'll have to change the model, we have to retrain the model, and then further tuning if it is required we have to do, and then we'll get the prediction. This is what is the standard principle used in almost all kind of AI applications. Now this is 2-3 examples to understand, like this is a machine in between, and then input is given, and that the machine is trained with this kind of a dog, so it will come to know that, okay, this is the picture of a dog. It's a kind of supervised learning. And then similarly this side, right side, there is a family in that there is a dog, and the training is something like that, it's not able to know. So if you go further for the deep learning is basically a multineural networking. Like ANN, CNN. So there the machine is further trained by going to, by leveling it further. So here that machine has come to know that no, this is a picture of a dog. This is further example of this classification and clustering. The first one, there is a group of some objects, and then these are basically the labeled data, and through that we have classified the 3 particular objects. And below that, this example is unsupervised, basically again a clustering. Through this it will identify these are dogs and cats. And this right side, there are some small amount of labeled data, as I told, and then unlabeled data. With that it will bring this particular the environment and agent examples. Now coming back to this, there are various top frameworks we are using it for AI. One is your TensorFlow, which is of Google. Normally we are using Theano and Keras, and there are many more available. This is just for information. Now for doing any AI project, now so far we are totally vendor dependent. In fact, I am using this engineering college student of 3rd year and 4th year. So what is to be done is the role of AI domain engineer. We are the domain engineers. What is to be done and how it is to be done is the role of AI expert, training of the model, and then along with the domain experts. And then key activities, there are 7 stages in that I told you that collection of data in respective format, preparation of data, then we have to extract the features, that is feature engineering, and then model training and evaluation. Now I am giving one use cases, there are in Kochi Metro. So use cases is again the classification, supervised learning, where gender and age classification, we have deployed the camera on our AFC gates, and then we take the data for a weekly or a daily or a monthly basis. So based on that, we have deployed this particular algorithm, and we have found out now that how many age of the passengers, age of the customers, and then their probably this age and gender both. And with this, currently we are getting around 75% of the accuracy. The cameras are actually old 2015-16. Now they are suggesting go for the new camera, as we see that now CP Plus and others probably will try to use one of those camera to get a better result and better accuracy. And similarly, we are going for the traffic predictions. There also, with the help of one engineering college, we are doing that. And around 70 to 80%. These are all based on historical data. What has happened in the past and what was the output. Based on that, we are getting this result. I think something. Then these are following projects you have taken, the queue management, rolling stock maintenance, civil building, viaduct, traffic forecast, gender and age analysis, signaling equipment predictive analysis, APC equipment predictive maintenance, AFC basically. Now these are the applications in our rail and metro, predictive maintenance, then we have to go for maintenance scheduling, remaining useful life of the any asset. We have to predict based on the historical data, sensors and usage pattern. Then root cause analysis, we can also predict based on those models. Then traffic management, energy efficiency, ticketing and fare management, crowd management and passenger behavior analysis. All these are possible with the help of different models, different algorithm of the AI tools. Now another example, though we are going to implement this one, that finding out the defects in our civil structures, our piers and the viaduct. So for that we are using this photogrammetry technology with we are taking the photo and videos using the UAVs, unmanned aerial vehicle, with drone basically. And with that using this beam technology and digital twins, we are making this 3D reconstructing the diagram so that we can make the appropriate model and then apply that pathology to get the particular defects. Like these are the 5-6 inputs we are giving, like we are taking a photo, video, LiDAR, 360-degree cameras and thermal. With that we are able to make out that 3D photogrammetry, and using the deep learning models, that is basically CNN. With that we come to know that what are the fault, or if there is any kind of a fault in the system in our civil infrastructure. So these are the typical kind of a fault, like crack due to AAR and leaching of concrete. So many, there are 7-8 categories. So all these faults can be detected with the help of AI. We can map it also. So like the CNN, as I told, there are 3 types of deep learning: ANN, CNN and RNN. CNN is basically used for the image processing. ANN is used for where the number system or the text kind of a data is there, and RNN is basically for the time series. So CNN, here we are using CNN because it's all the images we have taken, the photo geometry input we have taken. So what are these anomalies using against CNN, and then what are the anomalies and where are they located, which pixel belongs to each of the anomaly. And with this I like to conclude my session. Then the following digital technology has enormous power to harness the data for handling O&M activities of railways and metro. These technology includes, basically only single technology may not work, it all the blend of the technology, that artificial intelligence with the machine learning and deep learning, and the IoT. I think somebody had told in the IoT how it works, and then big data and analytics. As we know that in a monthly basis we are generating around 10 to the power 18, that is 40 exabyte of a data, and then there are a lot of enormous power with the structured and unstructured data. Then blockchain technology, so far it has been told that it is a tamper proof, but somebody gave some example that there are chances. Then cloud computing, lot of these cloud services are available, like infrastructure as a service, passenger platform as a service, software as a service. We can all use this one. A lot of demo we have seen which is based on the cloud computing system. Then VR, XR and AR. So these days a lot of training can be created on these models, so that in case if maintainer is going, he can see that there is no problem, and he can really identify the problems and attend it. Then digital twins, again creating a digital twins of particular physical gears, robotics and cyber security. Thank you so much. Any question?
Thanks, Sanjay. We can take 2 questions
Yes.
on this presentation. Anybody want to ask question? Right? If there is no question, then I will invite the third speaker, Mr. Ajay Singh, Director, Rail EduTech. Anand Shukla is not there, I think. No, he is there, sir. So then why are you sitting there? Oh, please, please. Sorry, I thought your name is not there. Okay. So we'll take up first Mr. Anand Shukla's presentation, Chain Code Consulting, LLP. His subject is digital twin technology and NFT. I hope I'm right.
Right, sir.
Okay, right.
Digital
Please
cloning
go ahead.
primarily. Thank you, dignitaries. Respected audience, my name is Narendra Shukla. I am the CTO of Chain Code Consulting. It's a blockchain and AI company. It's a 5-year-old company, and I am here to present my views on digital cloning for Indian Railways. So this is the introduction. Okay. So before we get into the duel, a lot of talk has already happened since yesterday with respect to what exactly is a digital twin. So if we start defining it, we would just simply say that it is a virtual clone of a real world asset, right? Very small, precise definition. But what is more important here is that the virtual clone is synchronous with the real object. So if you want to map it, it will be simply like if there is a clone of a train traveling from New Delhi to Ahmedabad, right? And if the digital clone applies brakes remotely, the same brake would get applied to the actual train moving in real time wherever it is. That is the bigger idea here. So it's going to be synchronous. And when I take a deep dive, I get lots of, it's very exciting actually. I also feel that we as humans, we have 5 senses. We identify ourselves through 5 senses. These sensory systems work for us. That defines us as being human, right? Now machines are evolving, right? Machines, all parameters of machines, we can read, we can sense, we can identify what exactly is the state of the machine at this point of time. What we are calling predictive maintenance is nothing but understanding what causes the tampering of the device or misfunctioning of the device. We read those parameters, we develop this intelligence through machine learning, that what causes it, and we predict it by learning continuously, slowly. That is the high-level idea of digital clones. And it is not just one technology. It's a mix of a whole bunch of technology, starting from cloud, artificial intelligence, IoTs, you name it, big data. So that's where the power is. Okay, so we just saw that these technologies are synchronous with the real world assets. I just want to say that John Vickers from NASA was the first person who coined this word called digital twin. And in 1960, they were the first person, unknowingly they did something like digital twin, wherein their spacecraft, Apollo program, it was there, and it was sending continuous signals to a clone at Earth. And you know, any space being a very, very inhabitable space, we don't know what happens there. So any uncertainties were passed through the sensors to the ground station to calculate what exactly would be the next path of that spacecraft. So it's as intricate as that. Okay. I think a lot has been talked about this with respect to capabilities of digital twins. Real-time monitoring, yes. Simulation, yes. Predictive maintenance, we have talked a lot. Data visualization, machine learning, life cycle management. Now, this is an important point. Life cycle management simply means that every asset has a life cycle. It gets commissioned, it gets decommissioned, it gets scrapped. This digital clone is a living object. This is a point to understand. It's a living object. It's not a static thing, static data sitting somewhere in the database which responds only on a particular command, but it actually reacts on its own. Suppose a train, suppose the track is designed to run only for 80 kilometers per hour, the train is running there at 100 kilometers per hour, we can handle that dynamically. It could be done. So this is where digital clone comes, and especially for big industries with heavy and complex equipments like railways with massive assets, under the head. This is something which will enable us to understand our machines better, derive the right kind of insights, and increase our operational efficiencies. Some of the use cases in Indian Railways could be predictive maintenance, yes, fleet management, especially for taking goods from point A to point B, safety simulations. We also have identified some use cases here, which we will quickly take you through. Okay, so let me give an idea what happens. We have traveled from digitization to automation in Industry 4.0. We are slowly moving towards autonomous behaviors of machines. That is where we want to go. Now, what exactly is autonomous? That machines do things on their own, right? When I say that they do things on their own, of course, there will be a governance attached to it. But many of the mundane tasks which we as humans do could be replaced by the new atmosphere, by these new technologies. Okay, for example, starting with digital clones, we talk about asset models. We first identify the object of focus. Here, let us say that we are just talking about a railway engine. There is a railway engine. It has something to do, some purpose attached to it. That is the model of it. Why we are doing it, that will be defined by the model. Cloud is necessary because the omnipresence of the data is important for us. It is vital. That is a dire need. It will give you remote capabilities. IoT is, of course, sensor technology. Blockchain. Why blockchain? By design, this is intrinsically tamper-proof technology, number one, and it is the purest way of storing data. In my lifetime, what I have seen, purest way of storing data. And that simply means that data is the fundamental. We are talking about data-driven economy. So that simply means if we have pure data, the AI engines will come up with pure AIs, relevant AIs. So the blockchain and AI are definitely going to meet in the coming time, and it's already happening behind the scenes, but I want to highlight it on this platform. And of course, artificial intelligence, we can't avoid at this time. Okay, so just talk simply about a railway engine. It has some attributes, some definition, some identification, just like we have a IRSE book for our vehicles. So there is always an identity of the machine associated. There are some attributes, there are some function which it does, some action which it performs, all clubbed into one. Into a 3D model, you see things happening. In real time, the sensors data are taken, and it becomes a live object. Now, a new world has come up, which we called as asset as a service. Asset as a service. My asset is a railway engine. It is important in ticketing. It is important in maintenance. It is important in safety. These are all different departments or verticals. I will create one model, and I will derive different services out of it to make it relevant into different departments. Of course, you can see there. Okay, these are some reports. McKinsey says that using digital clone, operational efficiency is going to be enhanced by 20% at least. And these are the big numbers which you see right here is the market size which is expected. Okay, probably Hansraj. We just highlighted some very basic use cases of digital clone technology, and some of it are in the POC stage. The point to understand is that the imagination is endless here. What we just highlighted, because of time constraint, we just have 3 basic use cases which we will be talking about.
Good afternoon, everyone. Thanks, Naren, for giving control. So in the upcoming slides, I will highlight practical use cases visually, how we can use digital twin technology in railway. So let's see this one scenario where we can see that there are currently 2 trains on the loop lines. There are 2 malgadis, one on the up line and one on the down line. Now, in the next, as we can see that one train we are expecting on the upline with the ID 18629, and we have deployed RFID sensors on the every signal post and also the speedometers as well as the GPS. So when the train will pass through this RFID scanner, we will get an idea that this particular train has passed through this RFID sensor, so that we can also get an insight that this particular train is traveling on this track. And also we will get insights about the GPS coordinates as well as the speed. And we have also strategically deployed touch sensors specifically at the point system near the railway track. So it will give us insights about the track configuration, that if it is set for the main line or the loop line. So, and accordingly we can get prediction if the train will travel on this particular train and on this particular track, and if the point system is set for loop line. So as we can see, we are predicting and we are thinking in advance that after 4 minutes then the train will be on the loop line, and as it is already occupied by Malgadi, so there are probability of accident. So in this case we can generate necessary alerts for the responsible authorities. Also we can integrate with automatic braking system Kavach to make it fully autonomous. Moving next, here we will see another use case for mitigating railway accidents in the Ghat and hilly areas. So here the LiDAR sensors are deployed in front of the locomotive engine, which will scan the front surroundings of the locomotive engine, and it will create the detailed 3D map. And if there are any obstacles along the track, we will activate the camera. Strategically, camera will be hidden initially, and we are only activating when LiDAR sensor will find any obstacle due to weathers, fogs and other conditions. Camera is not best idea to put outside, and camera will automatically enable the video recording, and we will swiftly transmit to the responsible authorities. And also I would like to highlight that it will be the self-cleaning camera. Before even start recording, it will clean itself, and after sending it to the responsible authorities, we can shut down the camera, and this way we can prevent the necessary accidents in the Ghat and hilly areas in such challenging terrains. Covering last scenario quickly, how we can identify the health of tracks by finding the cracks, the structural issues, the track stiffness, the roughness. So we have deployed acoustic sensors below the locomotive engine. It will monitor the noise which will be produced when the train will travel on the track. It will produce particular noise, and if there is a crack there is a track roughness, any structural issue, it will produce some different kind of noise. So we are labeling this as a good noise and bad noise. And in case of bad noise, we will transfer the exact GPS location of that track to our digital twin system, so that the necessary responsible authorities will get an idea that at this GPS location there is a need of maintenance. So here we can have predictive maintenance, so that we don't need to go there manually and check that if this track will require maintenance or not, but we can just get an insights. And here, so I would like to conclude here. Thanks everyone.
Sorry, thank you very much. We can take 2 questions. Any question, please? Yes. No, just wait for the mic.
Very good presentation and very good technology. I also happened to interact with you yesterday in the exhibitor space. My question is, you started with digital twin and NFT, but NFT is not covered. So you are looking for a non-fungible token, or what exactly is the NFT?
Sir, I wanted to tell you that digital clone and tokenization. NFTs we are using for tokenization. There is one small concept which I have missed in the presentation, that is called tokenization. Tokenization creates a secure entry pass to the asset. जैसे कि हम कोई bond को financial terms में, let's say if I tokenize railway tickets, what capability will I get on top of it? I will be able to share it to somebody else in a secure way. There could be provisions created where a mother and a small child could travel together. I mean, the association could be digitally created there. Some liquidity could be created out of it.
Okay.
So it is empowering. Tokenization is the key to empower digital clones, because the idea is to empower it, empower the digital model to an extent where it is a 100% replica of the physical system, and that is dependent on the sensory technologies, IoTs, definitely. But we are doing very good on these sensors technology. The market is doing really
So
good.
your idea is not any NFT for an asset like any railway station platform or a train? These kind of suggestions are not
Yes,
there.
yes. There are many ideas around creating NFTs for ticket and empowering it through creating the best passenger experience, right? There are talks with respect to why don't we check in passengers when they come to railways, right? There is no log. I just go sit. Sometimes the ticket is checked, sometimes it is not checked. There has to be a mechanism. So the people just go and they take their mobile phones and do like this, I'm inside. Railway should know these people have boarded, they have not boarded, stuff like that. There has to be a transparency created to it. All these steps could be handled using tokenization and NFT concepts behind it.
Okay. Thank
making
you.
it unique.
Thank you.
Next question. If there is no question, then I can invite the fourth speaker, Mr. Ajay Singh, Director, Rail EduTech. He will give a presentation on capacity building for safer digital railways.
Good afternoon, everybody. I hope after 2-3 hours of lunch, now must be little bit relaxed. Dose of lunch is now getting less affected. So, I am Ajay Singh, Director, Rail EduTech Private Limited. This is a startup training company. We are doing training in niche skills, especially related with the railways. Since yesterday, past 2 days, there has been so many paper presentation. More than 6 sessions have held. This is the last session. This is 6th session. And in all these sessions, except the inauguration session, when Honorable Minister talked about the industry and academia relationship, integration, training, all the people who have presented their paper, they are talking about the technology, all good technologies which is taking place in the for digitalization, modernization and all that. Now when the project is there, so normally we call PPT, PowerPoint presentation, but there is one more PPT that is called process, person and technology. For any project, these are 3 elements which are required. Process, yes, process has to be there. Technology has to be adopted. So we have been talking about the technology, we have been talking about in many presentations our processes, but we have perhaps forgotten or ignored, I don't know. We have talked very less about persons involved, except that Mr. Sanjay Kumar just spoken in his presentation that he is taking some help of some college students and all that for doing the experiments. So my idea is how to empower our new generation, and as all we know, we are passing through the Amrit Kal, and possibly very soon we will be the 3rd largest economy. Maybe thereafter we travel furthermore, we become developed economy. But all this will not happen if our persons, if our youths are not skilled. That is the one of the core things which at the political scenario, Honorable Minister, Prime Minister have been repeatedly repeating it, that we are the largest population in the world. So that is bad also, because we are largest, so our resources are shared. But it is good in the sense that if all our youths are empowered, then we are really going to achieve the development status before even 2047. So I am here not to talk only any technical paper, just going to give the information what we are all doing in this domain. So this is the need I am explaining. The more you sweat in training, the less you bleed in the combat. Yesterday somebody talked to me, and we also experience in our projects that there is a need of more and more manpower because my work is getting delayed. Instead of getting more and more manpower, if we start making them efficient, then perhaps the work will be done in a economical manner and quicker also. There is a global shortage of skilled manpower professional in rail industry, even in UK, even in Australia, even in other countries. So is the case in our country. Unfortunately, we don't have that kind of data. We are not maintaining those kind of data. So we are not able to predict what is the kind of requirement going to happen, and we get prepared. Then technical training for providing skilled manpower is the need of the country, because we know a lot of development is taking place, digitalization, modernization, and all those things are happening. IoT, AI, and all blah, blah, blah. So many things are coming up. But if the manpower is not trained accordingly, then possibly the things will get delayed, then things may not go right also. And training for technology application in railway for time-bound implementation of modernization and digitalization is very important. Gone are the days when a project which was supposed to complete in 2 years was completing in 3 years, 4 years. Now with this modern government, we see that all the projects which are finishing before time. And one of the major role in this is the persons who are involved with this. Only skilling of youth can help India to become the economic power. Multi-dimensional efforts to ensure safe operations, implementation of equipment like coverage from accident, and mandatory IRSE licensing for all those working for signal and telecommunication design, installation and maintenance. Independent safety assessment is another area where we need to develop the capabilities and capable people. Then implementation and follow-up of international safety standards. This is very, very important, as we see that whenever we forget to implement these standards or follow these standards, we get some kind of difficulties. Railtel Corporation of India Limited, a Government of India PSU, has taken a lead in this. They have launched a Center of Excellence for Capacity Building. They have collaborated with IIT Roorkee. The MOU was signed yesterday in the morning to establish the Center of Excellence in Signaling and Telecommunication. This is the Center of Excellence for Capacity Building, which has been launched on 2nd of November. For mentoring of IRSE license, cover training and cyber security, these are the 3 areas where we are going presently to work. Then many more areas as per need will be adding to it. Then IRSE licensing is another area which is through Railtel we are going to emphasize and get the people trained. IRSE is the professional institution for all those engaged in or associated with railway signaling and telecommunication, train control, traffic management and allied professions. IRSE offers signaling and telecommunication courses for professional development and practices, and IRSE provides licenses to qualified professionals for standard safety practices. And very soon Railtel will going to be SSE organization, so there will be mentoring and capacity assessment and all those things will be possible through Railtel. Then this is the company Rail Edutech Private Limited, which is an AICT evaluated training company for Kavach. Trained manpower required for the installation, O&M, online training for theory and practical, and IRSE has agreed to give the practical training for that. Cyber security, we have collaborated with Silas which is one of the largest, which is the technologically advanced company in the world. We are offering cyber security training for railways in collaboration with Silas Israel, network technology and operational technology. Then yesterday one MOU was signed with RailTel for establishing a center of excellence in telecommunication for continuous talent building, professional courses for young engineers, application-oriented R&D, and cross-pollination of ideas, benchmarking of best practices. There also we are going to launch these courses, 3 courses for training of manpower to be launched with collaboration of IIT Roorkee and RailTel Corporation of India Limited and Center of Excellence. First will be PG certificate in independent safety assessment. Another is PG certificate in signal and telecommunications. The third one is PG certificate in application of technology in railways, which we have been talking for past 2 days. So, training manpower for signaling and telecommunication, for signal designing, modern signaling, Kavach, LTE telecommunications. And in the certificate in application of technology in railways, train manpower for application of technology, cyber security, digital twin, blockchain, augmented reality, AI and all those things. And for the independent safety assessment, the independent safety assessment role is to verify whether the relevant technology, technical and operational risks have been reduced to an acceptable level according to the Senelec standards, assessment according to the common safety methods and according to the functional safeties. So we will be training the people on these parameters. Then resource partner for capacity building. We are the resource partner for the capacity building. Rail EduTech Private Limited is a Government of India recognized startup. This is an AICT evaluated training company. Network of trainers consisting of ex-Indian Railway officials and person from the industry. So thank you very much for being with me on this presentation. This is what we are going to do in the next coming years. If anybody has some questions, I am open to it.
Thank Mr. Singh. Any question? I think there is no question, so I can invite the next speaker, Mr. M. Nadeem Siddiqui. Please give your introduction also, because something is missing here. Okay. He is Export Director, NAFCO Power, and he will talk about tower and power solutions for RailTel.
Oh, definitely,
right?
yes.
Right?
Yes, yes.
Okay.
Power, energy, solar, hydrogen. Believe me, these are the hot topics everywhere. Wherever I go in the world, I find these are the subjects being discussed anywhere on everywhere in the world every day. This is a fact. With this info, I introduce myself, as already been introduced. I am Muhammad Nadeem Siddiqui. I am the exports director for a company named NAFCO, which is a Dubai-based company having its presence in over 110 countries globally, with its specialized equipments and known for its total solution provider. Equipped with equipment spread over 1 million square meters and 17,000 workforce. We are known as a total solution provider in our industry. Coming back to like in India, where we have our presence is already there in aviation industry, where we have been working in over 130 airports with our specialized equipment, which is known as aircraft rescue and firefighting equipment. We are basically firefighting equipment manufacturing, but NAFCO has got different verticals, and one of the verticals is NAFCO Power, where we are present here for. Coming back to talk about the RailTel, which is a significant telecom name, we will definitely be giving a specialized solution, a specialized product for RailTel with the innovative equipment known as super capacitor. So I will So before I go for the presentation, I would like to run a video which will showcase each and everything what we are going to discuss today. So can you run the video, please? So as a total solution provider, we are going to discuss with RailTel and see the requirements which will give us a chance to provide them the complete solution which includes the power and the tower. So I have with me to discuss Mr. Mike. Can you come please on this? He's the CEO of our OEM. Come all and he will take up the presentation for the generators. Okay, go ahead.
Thank you very much, Nadim, to hold me the stage. And welcome everybody. I'm Michele Greca. I'm from Italy. We are the technological partner of NAFCO in this project. Basically, Ascot is a company since 1986. We born as a diesel generator manufacturer for tailor-made application for the vertical markets. And we turned it in a system integrator for the market, because the changes of the market, the revolutions that is taking all the industries is requiring that all the industries need to change the way of doing the business and rethinking about the business. So basically what we do, we normally study the application in general. Then we sit with our client to understand the specific needs of the client and of the applications. We build a prototype and we prove it, and then we build the delivery in the quantities necessary. This is what normally we do all around the world, starting from America, Middle East, Asia, Africa, and so on. So I'm very excited to be here in RailTel in India for this project and taking part of this really revolution, transformations of the of this railway system that I've seen through different presentations that is trying to really taking taking the way to move forward for the traditional traditional system to the new and innovative, and creating also this digital twin that is very interesting because it will be the future. The good news is that we know how to do it because we've done this in different countries, and the bad news is that we don't know how to do it for this specific application so far, because we need to learn, we need to understanding the entire project and the entire chain of process, and I do believe that this is something very new for everybody in this room. So anyone need to questioning the old technologies and understanding how these new revolution, new transformations really can impact. And I've seen here even very well reputable and manufacturer of energy solutions that is in the stage here that have presented the solution, and I do believe that their experience is very important. And but again, as I said, experience is very important, but we need to be able to translate this experience in the new model, and this will be the challenge for everybody that is trying to addressing and try to be part of this big project. Of course, what we do, we integrate the new solutions with the time that the new technology became available. So initially we have the diesel engine, then biodiesel engine, then LPG, natural gas, hydrogen engine. Whatever is coming new, we integrate with in the products. So we need to be open and fast. And having the vision, because before we can make a project and this project can last for the next 10 years. Now, if we are not a very good visionary, we cannot project ourselves in what will be the future. We risk to generate, to design something that tomorrow is already overseeded. Thank you very much. And what we have special, the experience. So we are trying to sell the experience to the market and learning from this market. In these presentations, again, there is nothing new, but in general, regarding the generators, the new things is that we don't have a AC generator, we have DC generators. So generators that directly go at minus 48 volt, 12 volt, 24 volt, any voltage to powering the load, bypassing any rectifiers and go directly to the batteries. And the new presentations. Okay, these hybrid solutions is a hybrid solution designed again specifically for big loads up to 10 kilowatt, 12 kilowatt, and so on. But in this specific case, for the railways, there is for us these I see two kind of applications. One is for the signals and the towers, and in this case the load will be very small. And the big one for the gallery, for the tunnels, when they will need a big power to powering the air extraction, so what will be necessary. And we have done this in the past in Italy for all the railways, and so we do have the experience. But the fact that we do have the experience is not a guarantee that we can do it even in India, because again, we need to learn understanding the application. Supercapacitors is one of the new technologies that can replace the lithium batteries, but not only, because maybe going with the hydrogen will be jumping the batteries, will be not necessary anymore. So no one knows how the thing is developing, is going forward. For sure, these batteries, that we have 500,000 cycles compared with the 4,000, 8,000 cycles over the lithium batteries. So it's great number more. But again, technology that can be proven and slowly applied to the technologies. We cannot change completely in one day, but we need to have smoothly transitions. Okay, I will not go to the unique features and so on, but what I want to say that the working principle of this hybrid really is the one to reducing up to zero the running hours of any engines, that so far would be still necessary, maybe in a small scale, depends on how important is the energy. Because if you have a backup energy, you can have it or you can afford not to have it. But if you don't have it, you have to rely at least to 2 or 3 energy sources. And the monitoring system, IoT, digital twin, is what is the future will come that we are implemented in our solutions. Mountain structures.
Yeah,
thank you very much. Sorry, I'll take so far, but I will leave the floor.
As a complete package, we included the towers also, and we have our tower partners, Indian tower partners sitting out there. And so as a package, if you are given a chance, we will be giving the complete solution with tower and power, IoT based, and more sustainable, environmental friendly, carbon free, and power source, power 24/7. That's all. Thank you very much. Any questions?
In fact, I have one question.
Sure.
You are using RailTel emblem here. Have you got any standing MOU with RailTel?
We used it for our presentation only.
Okay, but there is no standing MOU.
Nothing.
Okay, right.
For our presentation only we used.
Okay. So any question, please?
What is the speed of the engine that you use? RPM?
But in general, the speed is variable between 1,200 to 2,600, but depends on the applications. But in this case, for the specific user case, I think that the solution would be completely different, maybe even without engine. Thank you.
Microphone, please. Please use the microphone.
Yes, it's asking for the integrations, I do believe, with the supercapacitor with the system, right?
Please repeat the question.
Actually, supercapacitor.
How this supercapacitor is going to help in the integration of the whole system?
Yeah, supercapacitor is basically a replacement of lithium-ion batteries with the longer life. As you said, that it is 500,000, 500,000 cycles. Projected life is around 45 years, whereas in lithium-ion it is hardly 5 to 10 years, and it is getting degraded after 3-5 years. So you can replacement of with the supercapacitor, the long life, plus supercapacitor is a electrostatic and not electrochemical, so it does not get heated. So there's no air conditioning required. Whereas in the module of lithium, where the lithium battery is there, you need to fix the air conditioning also. So in this case, it is not there. So you make a lot of, it is a cost saving, and in a span of 20 years, you save with the normal generator, if you spend capex coming around total with OPEX, $750,000. In this case, it is coming 120,000. So you make your ROI in a very short time, with the use of supercapacitors.
One more question: how much is the saving on diesel in India? We normally use.
It is, if the diesel cost is over $1 or above, then it is very good. It is very effective because then you make your savings actually. Like countries like Nigeria and where we have done so many, Saudi Arabia, Dubai, and UAE, they have adopted, although the cost of diesel there is not as much as we have it, but they have adopted this supercapacitors. And now in India, in this tower, the POCs with somebody is doing it with us, and for Reliance we are talking, and now the biggest, the most significant Rail Telecom we go. And temperature range, of course, yes. It works from -10 to 65 degrees. So no, you just fix it and forget it.
Thank you. Yes, time is gone.
Any more questions? Yeah.
I think, thank you very much, Mr. Siddiqui. Now I will invite Mr. S.N. Gupta. S.N. Gupta. He will be speaking on an interesting subject of use of blockchain and FRMCS for the train control system. Mr. Gupta.
Thank you, sir, and it's a great honor to be given this opportunity to present my thought actually on what I'll call a contradiction to the conventional rail control system. It is called CTC, the centralized train control, but in this case it will be decentralized train control using blockchain. The good thing is that Mr. Narendra Shukla already covered the digital twin. Actually, that also will be used here. And though this presentation is a bit long, but it has to be done in the 15 minutes only as agreed. And the starting, because we are talking on the digital transformation, luckily in the UN Connect agenda of 2030, blockchain is already listed. And just for the definition purpose, though it has been covered also, blockchain is also called Internet of Value, IOV, and it is a decentralized ledger technology. So you will see, and it has already been covered, how it works. Of course, we cannot cover it in this time given, but it brings transparency, traceability, and trust. Trust was being talked about in the earlier session also, to the transactions used through immutability and cryptography. And that is what is the main thing here, and this is how it works. But main thing actually, the blockchain, though it is defined as a decentralized ledger technology, and some of them take it as a synonymous with the Bitcoin, which is not the true thing. Bitcoin was just one initial application of the blockchain. So blockchain is much bigger than Bitcoin, and it is much bigger than an individual technology. Actually, blockchain, and that is what these 5 pillars of blockchain ecosystems are covering it. So it starts with the cryptography, of course, that is its main strength, the public key, private key infrastructure, and then hash function, like you have checksum, so here they make use of the hash function. That is another technology made use of. And most important thing about blockchain is the consensus algorithm. Through consensus, it makes, actually it brings the trust actually. So there is a proof of work, proof of stake, there are different consensus mechanism. Like in railway signaling, we used to do that comparative, and is in electronic interlocking, 2 out of 3 and all that. Here, it also is a like majority voting by consensus. And then the database technology is distributed actually. So it is, though it is called decentralized, there is a difference between distributed and decentralized. The railway signaling especially, everything is distributed, as you know, throughout the track, then in the locomotive, in the relay rooms, on the stations, and everywhere. So that is already there, a proven technology. Now most of the databases are distributed, DBMS and everything. And the 5th one, and that is the most important part of this, that is the decentralized processing. The decentralized, someone talked about, I think Mr. Shukla mentioned about the autonomous thing. Decentralized means there is no single control, or there is no single point of failure. Like in the CTC, the centralized train control, there is a single point of failure because everything is centralized before a decision is made, or any decision, and that is, it is reverse of that. So that means there is no single authority, no single point of decision or control. And this I have made in these 5 layers, like in the internet, and blockchain is also internet of value. So in the internet there are 7 layers, OSI layer, but in the blockchain we have made 5 layers, and because 5 pillars are there. And the first layer, luckily the first layer, which is also called hardware or infrastructure layer, that is what is the existing interlocking or existing system what we are having, that everything will be used. It will not go waste actually, everything will be used. This blockchain will be additional layer, and that will be a software layer which will make use of cryptography, which will make use of hashing, which will make use of decentralization. So it will be, and which will be making use of digital twin also actually. Half of the job is done in the train control to make it means fail safe, and beyond that by digital twin itself actually. And so these are the 5 layers, the main layer, then there is a data layer, the normal data layer as you know, and network layer. Here the network layer, that is the communication part, that is peer-to-peer. That is another aspect of blockchain. So it is one-to-one communication. It is not going through a central switch or going through an intermediary. Every device, every element of the network will be having a one-to-one communication actually through IoT or through Wi-Fi, and after that is the consensus layer, that is the main thing, and then the application layer. All these what we are talking, like digital twin is just one of the application of the blockchain also, or it has AI also in that. Same way, what I'll be talking decentralized train control, that will be application. So they will be lying in this layer. There are a lot of salient features, so I'll not waste time there. Transparency, decentralization, power to user, efficient transaction, no intermediary, reliable database. But the 4 things actually which come out very clearly by use of blockchain is the security, which we need badly in anything, and especially in the train control. So by cryptographic encryption, then integrity, because immutable, and accuracy of the data. All these are required. Cost efficient, cost effective, that of course. So it is blockchain in railway, and we are talking about the operational excellence. So in addition to decentralized control, the train control, it can also make the operation, the conventional operation efficient, supply chain management efficient, or these things because of its transparency and trust. And this also I'll skip, I'll go the value addition as I mentioned, and there is a national strategy here. The railway can also make use of that. The other attribute related to blockchain, like digital twin has already been talked, is called smart contract. That is a wonderful thing, a powerful blockchain app for multi-party, multi-dimensional agreements actually. So smart contract, if you use, the agreement can be automated and it can be litigation free, and especially in case of public-private partnership agreement, railway is having a lot of them actually. So it will be automated. It will be not subjective kind of thing. It will be litigation free, arbitration free. Actually all the agreements, as you know, with the government, public-private partnership go into arbitration, and lot of cost overrun is there, lot of delays are there. So all these things can be a thing of past if you use smart contract attribute of blockchain. So that also will be used. But I will start now. Actually, this was the basic of blockchain. Now the real thing. Real thing is actually, since last 2 days, we are hearing about the railway technologies and especially signaling and all that. And everything, all of us are taught that railway signaling system have to be fail-safe. Fail-safe, everyone knows that the failure cannot be on the wrong side of it. If it fails, it should be on the safe side. So, but after that also accidents are happening. So that means there is some problem somewhere actually. So for that, I have coined a term, failure not an option. Actually, it is used in satellites communication. When our Chandrayaan was to be launched, the failure not an option. It is not just fail safe. Actually, it should not fail. And blockchain can help there. So it is a very big ask, but it can do that. So that the probability of the failure itself is 0. And that is done with decentralized, autonomous, and trusted decision-making system powered with smart contracts, what we have mentioned. So that is of the future. But what today itself blockchain can help railway is for empowering machine-to-machine communication, including rolling stocks, by using the IoT and FRMCS. Luckily, one earlier presentation, Rajesh Tulli mentioned actually what we have already done in railway with RailTel and other is equivalent or better than FRMCS. The world is actually struggling to make FRMCS a reality. It is just a specification, or it is just a piece of paper at the moment. But it is a great thing, and FRMCS can help in overall productivity, line capacity, punctuality, passengers experience improvement. So this is the low-hanging fruit. If we use this along with the blockchain, and this is what is shown here by smart contracts, each train can communicate to other train also actually, 2 trains. Suppose by some mistake or something, some happening, 2 trains are about to collide. So if you have a blockchain and there is a peer-to-peer communication between the trains, then they can avoid that collision. This is done in the aeroplanes actually already. So it can be done in trains also. So they can, so this is a zero failure thing through decentralized train control, algo-based smart contracts, and even driver's license, driver's health, because sometimes the accidents happens because the driver health was not good or something like that in the morning, as you know. So with blockchain, all these things can be monitored and automated actually. So, and digital signatures are used. So three things I have wrote actually. One is the decentralized train control, that is the main thing. Smart contracts already I mentioned, and effective supply chain management. Railway supply chain is a so big thing. If you use blockchain and if efficiency is approved by 30%, so you can do so much saving on your supply chain. So for railway also I made this 5-layer diagram actually. The one is the execution platform. Execution platform means whatever is already there, let's build on that. That have to be there. We want to improve. If it's at a probability or availability 99.999, by using blockchain, let's make it 100%, something like that. So that you use, and then you start implementing the blockchain. Blockchain can be a platform. It is a technologies of technologies, and on top of that you use these smart contract, ledger, key pairs, applications and all that. So there is an example here that how we start using blockchain in railway. This is called Distributed Data Ledger Platform, DDLP. So we already have a lot of data logger anyway. Everything, and since 2 days we are listening, a lot of information have to be logged in the data through sensors, all those things. It is that, so you have a platform, distributed data ledger blockchain platform for railway. Every element, every piece of data should be connected to this platform, and it is not a centralization. It is wherever the data is there, because you have put a sensor and some data is already there. So let it be there, but finally it should have a tokenization, what was mentioned, and it should be represented and should be available. So that is there. And so predictive maintenance, 2-3 things were already mentioned, but I'll straightway now come to the decentralized train control. These are the case studies of blockchain on Russian railway, and you know the CBTC already known, and if the same CBTC you use FRMCS as a communication backbone, and then all these things, and these you have to have the 5G kind of capability which are already there. So this is the starting point, concept of decentralized train control, and it is also like digital twin kind of thing. So you will have every element of signaling, whether it is point machine, signal, relay, will have to be tokenized. Everything will have to be a token. Like in the point thing, what I was getting the idea of digital twin. So if a point machine which have to set the route actually, whether train will go straight or it will go in a loop line, so that is how. So if you could have a digital twin of that point, normally it should be a photograph and all that. If it is not there, they are just proving it by those contact, by relays, and sometimes the shortcut can happen or mistake can happen. So if you can create a digital twin of the point machine before switching the signal, then your job is done actually. Then you could have avoided accident like that, which happened recently. And so this is what, and this you can see the blockchain based train control. DB Germany, Frankfurt, actually they are already doing a POC on this, and this yellow thing here is basically the blockchain part. The green things are what already there. So blockchain will come in between actually, and it will help through decentralized train control, through efficiency, and its actual final thing will be what they have named already BRCS. BRCS is blockchain based rail control system, where the existing infra and then the blockchain layer. That's all the elements of blockchain will be used and existing infra will be used. So final decision will be taken by blockchain now here by use of digital twin. So you will not have a centralized controller, you will not have anything. And if you go for the future, you can actually make each train talk to each other through IoT, and they can avoid the accidents if it is happening, like our Kavach, what is supposed to do. So this can also be done. Of course, the infrastructure of Kavach will still be used. It will be only strengthen that. So this is my last slide, and that is the conclusion kind of thing. So according to me, because senior railway officers are there, blockchain should be made the integral part of railway technology vision. They should establish a directorate of blockchain applications, and they should try to create railway's own blockchain, a private blockchain kind of thing, can be named Bharat Rail Chain, and using that DDLP and this center of excellence is luckily already there. Maybe blockchain center of excellence can also be there, and Mr. Singh was already mentioning about some workshops he's doing. And main thing is the change of mindset. Actually, from fail-safe we have to go to failure not an option, and from centralized train control we have to go to decentralized train control. If we can do that, I think a great time has come. Today's paper minister was mentioning that he wants to replace everything, he wants to make it error-free, he wants to make it accident-free. So this technology can help to achieve the vision of minister which was there in the paper today. So thanks a lot for the opportunity.
Thank you, Mr. Gupta. I have one question.
Yes, sir.
Like local area networks, 2,
Yes,
3, 4 local area networks can be connected together.
Yes, sir.
Is there any possibility of connecting two blockchains to each other?
Yes, sir.
And if it is there, then what is the plus point and what is the minus point?
Actually, sir, it is there because we have a national blockchain strategy, especially in India. Though world over, they are all dedicated or separate. But in India, we have a national blockchain strategy. There is a actually standard, because if you want to interconnect various blockchains, you have to follow a standard. So it is there. They have to be interoperable. The plus, of course, is there because you can have a universal blockchain. But as far as the railway I'm advocating is you don't have to have a public blockchain what is used by Bitcoin. You can have your own private blockchain. The beauty of private blockchain is no cyber attacks, no external attacks can happen. So you have your own private, like you have VPN. Same way we can have our railway's own private blockchain. And according to me, sir, I don't feel there are disadvantages, means it is not coming to my mind immediately.
No, as you told that there is no possibility of any hacking in the blockchain.
Yes, sir.
So,
if you have private,
so that is a major problem if 2, 3 networks are connected together. That is why different networks are not connected, just to avoid the hacking and other thing. So if it is just not possible to hack the blockchain,
yes,
then I
if it is private,
there
sir,
should not be any problem.
Yes, sir.
Anyway, any question from the audience, please? Yes, that's at my microphone.
I am Prem Chandra. I just want to ask 2 simple questions actually.
Yes.
One is we are talking about the digital twin.
Yes.
Material behavior and the software simulation behaviors are completely different. How are we actually predicting the abrupt behavior of the material by creating the digital twins?
Yeah, in the earlier one, it was mentioned there are dynamic digital twin, or they are basically synchronized with the actual. Actually, digital twin, yes, a simulation, but it is the replica of your actual at that time. Like I'm talking about the find machine. If find machine is, let us say, reverse direction, so the actual at that time when it is reverse at site, digital twin will also show it like that.
You could not understand my question actually.
Yes.
We are having the point machines in which we are having the slides, so many things actually.
Yes.
Most of that, one of the failure is like point machine is moving and all of a sudden it's a slide breaks.
Yes.
How will you actually implement in the digital twin? How can you predict actually whether this slide will break?
No, I'm not talking, the digital twin is the replica of the state of a element at that time. If that state is changing, the physical thing is changing, then the digital twin also it will change. But the predictive maintenance is different. Digital twin is different. Digital twin is just replica of that moment state of a element which is away, which is physical, and you have converted it to this 3-dimensional thing which is virtual, but it will be same. Actually, if it has broken, then the digital twin also will show it broken. But it cannot say it will break after few minutes.
That means abrupt behavior of the materials cannot be predicted by the digital twins.
Yes.
I think you can discuss separately with Mr. Gupta.
No, there is one paper actually on digital twin.
Another question, sir, just
yes, please.
That's just one line only.
Yes, please.
We are talking about the failure, not an option.
Yes.
How will you actually duplicate actually a site, a physical device with a virtual device? If physical device actually a breakdown happens with the physical device, how can you actually replicate and attend through your model?
Actually, yeah, this I've copied from the satellite communication. Like when you launch a satellite, they have actually done it. Actually, ISRO have already done it.
This is not actually something virtual. Actually, it's actually things has to be actually.
Yes.
Hardware has to be in place. Actually.
Exactly. That is the vision. Because I'm not telling it can be solved immediately. It's a big vision. It will cost a lot of money also. But if satellites guy can do it, why the railway cannot do it? That is the only thing. It costs money, of course, and it has to be physically also. There have to some duplication at physical level also, some redundancy. That is sure.
Right. Now I will invite Mr. Rohit Kumar. He is from Sublime Incorporation, and his subject of presentation is applications of AI/ML in railways for predictive maintenance. Mr. Rohit Kumar.
Thank you. So glad to be here. Myself Rohit Kumar. I'm the CTO of Sublime AI Incorporated in USA, and a lot of the work that we have done in AI has been in the US and European market, railways, as well as doing predictive maintenance for vehicles and in manufacturing. So currently, I'm also part of the Government of India initiative with CSC, where I'm heading R&D, and also been actively involved with startups. So that's a bit about myself. What I'm going to discuss today sort of stems from a lot of the state-of-the-art research, and hopefully I can bring that to light, some useful tips and insights that can help if you are designing your own predictive maintenance system. So the fundamental inefficiency that of a manual maintenance, or a human oriented maintenance, is the repeatability. So if somebody, now we end up in relying on somebody who's very experienced. There was a recent Netflix series on on a gas leak situation, and it kind of showed that if the human person is not trained, then there can be mistakes that could come along. So that, I think, in some sense is the opportunity when you're talking about bringing that knowledge into a intelligent system. So things have improved a lot, definitely, no doubt about it, and Indian Railways is a great example of that. There are exceptions, which was a recent incident, but that should not scar the fact that there has been a huge drop in accidents from a decade. So kudos to that. I wanted to kind of cover in this slide was actionable insights. Okay, what does that translate? Because whenever you're designing an intelligent system, you can get very caught up into imaginary things that your system can do, and it can be like sky's the limit. But focusing on actionable insights is very, very important whenever when you start designing an intelligent system. So things like rapid vibrations, irregularities in the accelerometer, leading to rolling stocks. Temperature variations can highlight track issues. Current fluctuations can be, showcasing signaling issues. So there's a long list of these things. Like high resolution images can, show wear and tear. So if you look at an intelligent system, you have to look at different modalities as well, and not just one piece in the puzzle, which could be a sensor, right? So there are all these different sensors, and together they tell a picture, as opposed to one particular, modality telling a picture about a problem. I think the journey of designing something like that, and you know, of my experience of dealing and the research team that I have been managing, is that, you know, it starts with you know, the hardware, where you are collecting all this data, and generally SIMs stand for, you know, sensory interface modules. So basically, these modules can come from all different shapes and forms, and the key over here is that you want to make sure that whatever module you put in, or whatever software layer you put on top of that hardware layer, is interoperable. So because, you know, you could, hardware will evolve, right? But you want to make sure that the data that you're processing is following standards, you know, and is basically bringing that input. So if you break that inputs, these days with sensors getting so advanced, you know, voltage sensor, current sensors, resistance inputs, you know, all of this data that is coming into whatever system we are designing ends up in having two characteristics, two big things. So one is that you're trying to use this data to figure out whether the object you're observing, you're managing, like in this case rolling stock or the, you know, the railway infrastructure, is that misbehaving, or is the sensor itself misbehaving? So these are two things that may not be very intuitive to demarcate between you know, one as the other. So that's another thing to factor when you're making that decision. So largely speaking, you know, there have been you know, conversations about data processing. Generally, you know, this is one of the least attractive, but one of the most important aspects of you know, when you're building an intelligent system, especially powered by AI. So if you all must have heard and used ChatGPT, Gemini, Bard. You're looking at big foundation models. It's very interesting when you go deep into the implementation of these technologies, as I have, that they are a function of the data set they were trained on. So data is truly becoming the new oil, and they have indeed curated, and there have been experiments shown that, you know, the quality of data you bring in heavily determines, you know, what your output is going to look like. So first step when it comes to data pre-processing, it is about, especially in the world that we are talking about in the case of railways, it is to make sure that the sensor data, there are, you know, you're filling missing information. That will happen, it's inevitable. Instead of assuming that you will have the best sensors or the best you know, transmission protocols in place, it's better to design a system that fails gracefully or tries to fill in missing data. Now, many people tend to just think of this as an afterthought, but if you look at, there are lots of algorithms that go into how you can actually fill missing data. There are all these various techniques, all the way from, you know, doing multiple interpolations, imputations, then being able to, the latest that is in the batch, which is working well, and we have tried it in our you know, center, where you're doing variational or autoencoders. So basically, it's a deep learning based neural network thing where you're feeding a lot of effectively data and asking the neural network to reproduce it. So that's input output, and you're effectively asking the neural network to compress. So that's what a variational encoder is, and it produces the best output or best performance when it comes to filling missing data. But the downside is that it is expensive to train, and it can become you know, expensive to run as well. Before I go further down this road, then comes the next step is feature engineering. Okay. Now, anomaly detection is very, very critical for a lot of the applications we're talking about, and it really relies a lot on feature engineering. People tend to think that, you know, I'll take a bunch of data coming from my sensors and I'll feed into an anomaly detector. You know, I'll learn patterns and try to identify, but that's not it. You have to actually model your features. You have to look at that sensor data and see what kind of a distribution it is fitting. Is it actually fitting a Gaussian distribution or not? For example, let's say the value of you know, a sensor is X. Depending on your readings, you'll have to see whether X square fits Gaussian better, or whether it is a log of X that fits it better. So I mean, this kind of a human you know, inspecting your data and trying to fit it and do feature engineering is critical, especially if you're doing unsupervised learning and anomaly detection. But there are other kinds of things as well, like wavelet transforms are needed when you're dealing with especially data that you cannot just simply see, right? You have to analyze, extract the frequency of it. Image processing side, there is there has been some latest things which have been working phenomenally well, like if you take an image, being able to segment an image and extract the various objects of interest. Facebook has this model called SAM, which is segment anything model, which is open source and can be used for doing that thing. And then there are statistical methods like mean, standard deviation, skewness, which is standard. I did want to bring this to light based on whatever I've heard so far. I think something transformational has taken place in the last 2 years in AI. And the core behind it is the fact that when you look at systems like ChatGPT and all, they were trained to predict the next word. So they were given a bunch of text and they were asked that, okay, you know what, here is a piece of text, now predict the next word, and it can, that's a form of unsupervised learning. So they would suddenly be untapped unsupervised learning, which was never possible. The history of machine learning has been largely based on supervised learning. When this happened, things have changed, where the network has started to learn in order to predict the next word. See, you might think predicting the next word is like just predicting the next word. No. To predict the next word, you have to encode intelligence of your ecosystem. So what we have been trying is that why not apply the same principle, but now to sensory data, right? Different modalities data. Why can't that system, I'm not talking about it generating anything. I'm just simply saying that the system can learn how all these things are interconnected. The knowledge of the world or the knowledge of basically your operations. So that is, is basically how a pre-training task is set up, which is it's predicting effectively what the next value of the sensor is going to be, given input values of that sensor itself and as well as other modalities. And embedding is a concept. I don't know if you all have heard about it, but it's basically literally transferring text, image, or whatever it is into a vector space, okay? A 512 dimension vector or whatever it is, but that particular space is what you're transferring your data into. And what I have, and in the interest of time, I won't go into this, but this is a breakthrough paper that introduced transformers. So any of you are interested, you should highly recommend read that paper on which is called Attention is All You Need, which basically brought all this revolution. Then comes the stage of training and fine-tuning. So far I just said it was unsupervised learning. Now comes the place where you're actually giving it data. And see, the beauty over here is it's cheaper to do this. The other one was expensive. It requires a lot of GPUs, a lot of hardware. So in this particular case, you can do it much cheaper with less amount of data. See, the power is in the first phase, you learned all the, basically you trained a child effectively to understand what the world is. In the second phase, you're actually telling that, okay, this is what I want you to do, now do it. And it's able to learn much faster and cheaper. So that's really what it is. I put in some, details of loss functions that you can use to train these for different applications, and you can refer to it later. And then the third phase, which is called reinforcement learning with human feedback. Think of it this way, that now you trained a system, but now you want it to be personalized. So imagine you have deployed this in a particular station or a particular condition, or maybe a particular train plan, right? RLHF is a way for the system to personalize, okay, effectively. So it's based on human feedback. You keep giving and saying, thumbs up, thumbs down, and then the system tries to adapt its output to what your inputs are. Just 3 case studies, and in the interest of time, I wanted to bring them to notice because I found them very interesting and also related to some of the work we've been doing. Visual inspection, which I think is an untapped opportunity, in the sense that cameras are very easy to install, and they're also very easily available. You can automate a lot of visual inspection. In this particular case, it's been successfully done, where you can just simply reduce hours and hours of time to minutes, where you can identify potentially that if there is a bolt that's probably missing, or there is a leak or anything like that. And the way, again, architecturally it is done, I put in a few pointers here, that there is a model called clip embeddings. It's again open staging them right now, because you can't expect a human to, once you design systems like this, you can place it in so many places. You can replicate, effectively that intelligence. And the last one that I wanted to cover was, the Siemens Rail Center on Bogie Maintenance. That is such a big piece of, railway infrastructure, and, costs can go up 300% if you don't intervene at the right time. So again, here you can leverage all those sensors, temperature, pressure, vibration, and so on, in addition to maintenance cost data from the past, like how much it costs to repair things and so on and so forth. Here it will be a standard prediction thing for time to live. And I conclude with what I think the future is. The future is, in the numbers. It's already showing that the market is increasing like 3/4, like it was, almost 1.3 billion in 2020, and it's going to get to 3.6 billion in 2026. And the one thing I did want to end this conversation with was that even, putting AI as a way to even predict and monitor human error is something that where I think we eventually will get to. Like, there are human errors as well, which often are the reason why systems are configured incorrectly or are not, put together. I think that is another area that we should look into, because often that leads to problems. So that's all I have, and thank you.
Thank you, Rohit. I think we are running out of time, so I will not allow any question, and if any clarification is required, it can be taken separately from Rohit. Now I will invite the last speaker of this last session, Mr. Dhaval. He will give presentation on creating smart factories. Am I right?
Yes.
Okay, please go ahead.
Good evening, everyone. Thank you for the chance and opportunity to come and speak here. It has been a tiring day for everyone, so I'll keep it short. First of all, I'd just like to thank IRSE and RailTel to putting up such a great show. So just let's put our hand together and thank everyone. So thanks a lot for that. It has been a great experience. Thank you for that. I am Dhaval, and I'm the Chief Operating Officer of the company called Twin. We are not just any digital twin company, but we are a phygital twin company. And what phygital twin is it's basically an amalgamation of physical and digital systems. So nowadays what we see is that we see a one-way transmission of data from the physical world to the digital world. But nothing goes back to the physical world. What we are doing is we are bringing immersiveness, and we are taking back the insights from the digital world to the physical world. So that allows us to make a more comprehensive assessment of our reality and make decisions much more smartly. I'll also invite Mrs. Gurpreet Dogra on the stage. She's the country head for Twin. So we'll just share this stage together and move forward with my presentation. So one point that I really wanted to make was that we do not reinvent the wheel here. All the discussions and all the topics that you have heard throughout the 2 days here, you have heard a lot about AI, ML, you have heard a lot about digital twins, you have heard a lot about blockchains. What we do complements each and everything that you might have heard and talked about in these past 2 days. One aspect that we have been hearing is IoT, and we have been hearing about IoT since probably 2011 or 2012. But what it failed to become was the new gold. Just like oil was supposed to be the new gold, similarly data sort of failed to become that new oil. 95% of the data that we have been collecting over the past 10 years has been just sitting in our data centers and not really been helping us, because we cannot comprehend that data in a way that we usually do. Humans, when we make decisions in our real life, we use our experiences and our know-how of physical matter and then make those decisions. We learn from our experience. Take the example of cricket. The introduction of DRS system after, let's say, an LBW was all, before that it was all just a guessing game. But after DRS system and bringing in digital versions, we see the ball tracking properly being done, and predicting exactly what, and basically be more efficient at what you do. I just talked about this. One thing that we are really proud of is that we do not need any external hardware for our solution to basically run. We take your existing systems, we take your existing PLC data, SCADA data, we take your existing IoT data and merge it all together inside our platform to allow you to create your own digital twins. We're also not providing the creation of digital twins as a service. We are rather providing it as a product platform where basically you have all libraries of assets where you can just pick and place, drag and drop those assets and create your own digital twin by yourself. So you do not need a system integrator to sit with you and basically work throughout the journey and basically give you cost overheads. You can basically retain your own team and they can manage the whole system for you. Some of the solutions that, or basically use cases that we could come up for railways is basically track infrastructure monitoring, right? Through the already installed sensors, we can basically create a whole 3D map or 3D visualization of the track and infrastructure and give you that inside the platform. You can basically do the track geometry monitoring. You can basically do all the use cases that all the gentlemen have talked about in the past, and basically give it a much more better understanding and implement that using your team. The second would be basically rolling stock performance optimization. Again, everyone has already talked about how we can improve and how we can sensorize the rolling stock and take the performance data. But now in real life, in real time, with 3D representation of the rolling stock, you can also see the conditions of the rolling stock. One gentleman also did talk about the abnormal nature of mechanical inside, let's say, a train or let's say a coach. But through the use of multiple sensors, we can create patterns and anomalies and then work on them to understand that what exactly is happening with the physical systems. Even the slightest of anomalies, let's say caused due to an aerodynamic suspension of the rolling stock, would be represented in the data. And through 3D visualization, we can understand that pattern and then showcase that inside the platform and tell you what exactly is going wrong, even if it is just, let's say, a misalignment of a panel. There's also a lot of talk about environmental and livestock monitoring in railways. We want to minimize those damages and we want to minimize those incidents. So for that also, using these already installed sensors, even let's say yesterday when we were there, we were having a lot of discussions with companies who have installed fiber optics to identify elephants near the railway tracks. So even that data can be brought into our platform and then showcased in real time where exactly is the livestock and what are the chances of the rolling stock hitting that livestock. Even weather changes, let's say there is flooding on the railway tracks, we can identify what is the level of this flooding, and then the driver can basically take their own informed decision whether to go through that flooding or to basically stop the train in much more in advance. Similarly for traffic management and control, right? All the rolling stocks, all the trains and stations are connected, and in real time in 3D you can visualize where exactly the traffic is coming from, where the traffic is going. So the optimization of the entire process can be done much more efficiently. Similarly, one aspect that I did not hear a lot about was digital twins of workshops. Workshops for railways is a manufacturing hub. It's very, very important. They have massive equipments, and any downtime with respect to workshops also hurts, and it is definitely bleeding productivity. So even when if we basically bring those workshops back to our platform, we can improve those efficiencies, we can give them more productivity, we can reduce the manpower that we require and probably redeploy them to more critical areas. So digital twins, or let's say a physical twin for workshops, also become an extremely viable use case for railways. We can extend this to human resource tracking as well. We can basically, the people that work for us on the field, we can track them, we can track their activities, we can track their tasks, we can see what's the progress of different tasks. We can also basically prevent trespassing and theft using geofencing and trespass prevention activities using a digital twin. So we can exactly monitor where exactly our personnel is, where they should be, where they shouldn't. You can track their timings and whatnot. Over the past years, we have worked with a lot of Fortune 500 companies like Samsung, Panasonic, and Maruti, and we are glad to have given an opportunity to try out a POC with Indian Railways as well, and we are extremely grateful today. I just want to end my presentation with a short AV, which will tell you a little bit about our product further. That's it. One last thing that I just wanted to highlight was we have been talking a lot about immersion and AR, VR, but no one really knows what's the future of AR, VR is. Right now, whenever we talk about virtual reality, the only thing that comes to our mind is those bulky headsets, which are extremely difficult to wear. Imagine a frontline worker wearing those headsets. He's not able to maintain his head upright. How would he really go in and maintain a machine? So in the future, we are already downsized the whole process or the whole ergonomics of virtual reality to this level. These are no bigger than your Ray-Ban glasses. And these are extremely comfortable to wear. You can wear these, you can walk onto your shop floor, walk onto your factory, see in real time what the health is of your machines and basically make decisions on the fly. So the future is already here. Let's work together, and thank you a lot for the opportunity. If there are any questions, we'd love to answer those.
Thank you so much for staying back late and being patient till the end. And I think Dhaval has already covered that we are smart, immersive, intelligent, interactive, digital twin company. We've changed the term to digital twin to phygital twin. And if anybody has got any questions which we can answer to actually highlight any feature sets that you really want to discuss.
Thank you very much, Mr. Dawal. If any clarification is required from twin, it can be taken separately.
Yes,
now I'll request
Yeah.
Mr. Kaushik to briefly summarize the presentation before we come to the end of this session.
Thank you, sir.
Right?
Thank you.
Thank you.
It was a great session. In fact, it's like a movie where there are many things which have to come, and I wish that when we have next IRSE seminar, we have visits exclusively planned to showcase digital twin use cases. So to begin with, Mr. Manoj Pandey gave a presentation on blending of energy, integrated solutions, where the solar and other modes of energy generations are integrated, and the power is available for 100% of the time. Mr. Sanjay Kumar, my friend, in fact, he is doing a great job in-house development of operation and maintenance management system. It's like creating its own mini ERP for various functions like asset management, ESS, and also he's planning to use AI/ML for certain applications. Then we had a presentation from Mr. Shukla, NN Shukla, that was out of the world. Future of railway signaling, totally new world, creating digital twin, and also using it for preventing train collision on railway track, integrating it with Kavach, and the area is still developing, but I'm sure by the next IRSE seminar, we'll have many applications working physically in the country. Then we had Mr. Ajay Singh, who is in collaboration with IIT Roorkee and Railtel. They have developed number of courses to create that manpower which is needed by the country. We are lagging behind, and in fact such institutions are needed so that the required skill set is provided. Then we had presentation from Mr. Nadeem Siddiqui from NEFCO Power, and again he talked about the energy solutions, something similar to what we had earlier, and also about the tower solution, and especially the scalable tower solution, so and smart power, and also using IoT for remote control. And one important thing which I don't want to miss, that was about supercapacitor, which he brought out, and hope that we'll have supercapacitors in our installations also in future. Then Dr. S.N. Gupta, again, in fact, that was something which is yet to come, but that's the real future, decentralized train control and application of blockchain ecosystem, so that the real benefit of decentralized processing is made into use. Then he in fact introduced or rather told us about many new terms, Internet of Value, then and he covered many salient features of blockchain, smart contract, failure not an option, another important thing. And he gave many ideas for future, where he said that CBTC and FRMCS and blockchain combined can give you more safer systems and productivity. Then we had a presentation from Mr. Rohit Kumar on use of AI, ML in railways, That's something very, very important, and for predictive maintenance, that's something which we cannot miss. Then he talked about the complete basic process, fundamental process, whether it is collecting the data, how to tackle the missing data, anomaly detection, and then finally adding the human feedback to personalize this AI/ML. So I'm sure that will be the future, and he gave some examples of using this for predictive maintenance in various countries like DB for rolling stock and low adhesion and bogey maintenance. And finally, we had presentation from Mr. Dhaval. That was another exceptional presentation, creating smart factories, digital twin, and he in fact pointed out very categorically that it's not only physical world to the digital world, but then finally from digital world to the physical world. That's what digital twin is needed, and more immersive use cases. And he presented that how it can be used for track monitoring, rolling stock performance monitoring, environmental monitoring, livestock monitoring, and so many use cases. And I'm pretty sure that we are all these are around the corner, and we'll have it very shortly in our railway industry, Indian Railways and other associated railway partners, whether it is metro or RRTS. So future is there, where a lot of work is to be done, and only thing is that which nobody talked about was that cost effectiveness, and data and communication security. That of course we'll all have to work, and thank you very much, and let's see in next IRSE seminar all these implemented. Thank you.
Right. Thanks, Kaushik. Thanks, Kaushik.
Well, ladies and gentlemen, this actually brings us to the end of day 2 when it comes to the session. But before I wrap up, I would definitely want to thank our session chair over here, and also our session's moderator, plus our panelists over here, for having convened this last session so effortlessly, and of course also on time. First of all, can we have a round of applause, please, for all our esteemed panelists, session chair and special speaker, please. And now, ladies and gentlemen, I would like to invite over here Mr. Anshul Gupta, ex-GM, NF Railway, to kindly come up over here and give us the closing address, which shall be summing up the last 2 days of here. Can I have a round of applause for him, please? Thank you.
Thank you, Sakshi. I think we have not finished, because the second phase of technical visit is around the corner. Tomorrow we shall be starting at 10 from State Entry Road near New Delhi station for the 3 locations. NCRTC, whose director is sitting here, Railtel and Delhi Metro. There are 3 groups, so everybody is requested, whosoever has opted, to assemble at 10 hours. So thank you very much. Very engaging 2 days. We started with minister's session, and then we started with the innovations, the things which Indian Railways have done so far, then various technologies, and ultimately the future, the digital twin, which we want to have, and it's a requirement. As you know that more than $100 billion of investment is coming into Indian Railways, so that the objective of New Rail, New India, that if railway becomes modern, digitized, India becomes a developed, a very fast 5 trillion economy. So that's the vision. And many of the technologies which have been discussed in last 2 days, they are under implementation or under planning stage, and we hope that what Navneet also said, that when we had next IRSE seminar, and which is very soon, in February we are having next one, and every 3 months we plan to have one IRSE seminar, it's not convention, so that this exchange of knowledge, it continues, and new ideas which flows, even the policy makers, they understand that how the industry is moving so fast, and what are the ways and means, and the startups the very, very good works the startups who are sitting here, they have done. So this is the way we have to move forward, and IRSE basically is into competence development, and without developing the competence, all the technologies, whether it's a digital twin or anything, cannot succeed. So that's the idea with IRSE launching these programs, and very soon with the help of IIT Delhi and WailTel, we have these courses starting. In fact, we have already launched officially, and these courses will start soon. They will be online as well as offline at IIT Roorkee's campus at Greater Noida. So thank you very much. So many people have contributed to the success of this
Speakers over here. Thank you so much, gentlemen. To each one of you who's made it till this part of the evening today and been over here for the knowledge that has been shared, as Anshul Gupta ji just mentioned, a humble thank you. It takes a lot to sit through such long days of knowledge and to soak it all in, and also to be able to share and express it. So I believe each one of you should be applauding. A round of applause for yourself also over here. Thank you very much, ladies and gentlemen. I do hope you all have a good evening from here on ahead, and I hope to see you again in the future once again. Goodbye, good evening, take care.